Since its inception in the mid-90s, Java has delivered on the promise of being able to write applications once and run them on any device that supports the Java platform. Today, Oracle puts that at around 3 billion devices. As a Java developer, you have a myriad of choices when it comes to specializing on the platform. This includes web and enterprise applications, mobile applications, and specialized desktop applications. This course teaches you the fundamentals of the core Java language, which you will be able to use no matter which direction you choose. As such, we will not focus on any particular user experience, but learn to build applications that can later be plugged into any front end with little or no modification. Once you have mastered the skills in this course, you can then graduate to the more advanced Infinite Skills Java courses, such as Java Database Programming, Learning Java Enterprise Edition, or Learning Android App Programming. I'm assuming you have no prior programming knowledge. We will start from the beginning by installing our development environment and then use modern tools to give us maximum productivity as we build a working application in Java. If you have heard the term object-oriented programming, Java has deep roots in this programming paradigm. Many Java courses out there teach you basic concepts and then throw a couple of lessons in at the end on object-oriented programming. This course will be different. Everything we do in this course will be focused on the object-oriented nature of Java. We will start at the beginning, but by the end of the course, you will not only have a good handle on Java syntax, but you will also have a solid understanding of object-oriented programming. So without further ado, let's get moving. This in-depth course on Java 8 covers many topics. Instead of teaching you a laundry list of commands and syntax, we will learn everything within the context of a working project, which will be a simple airline reservation system. First, we will need to install Java, as well as additional tools that will help us write code productively. I will cover the installation on Windows, OS X, and Linux platforms, and work with tools that look the same on all three. We will learn key concepts along the way and apply them to our project until we have a working and deployable application. We will also learn critical aspects of application design, such as data modeling, testing, logging, and error handling. My name is Mike Kelly, and I'll be your instructor for this course. I first started programming in high school with a brand new Sinclair ZX81 plugged into a black and white TV set. 30 years later, I've had the pleasure of working with and training software developers in many industries, including nuclear power and medical research. Java is everywhere. I hope this course will be your starting point into an exciting and high-opportunity industry. Java version numbering can cause a bit of confusion for developers who are getting started with the platform. So let me give you a quick rundown on what to expect as you work with Java. When the first version of Java was released way back in 1996, it was called appropriately Java 1.0. It was free for developers to download and build applications, and so they downloaded what was called the Java Developers Kit, or JDK, and it was also version 1.0. It allowed you to build your applications for free, and then there were many companies that licensed the runtime version of Java, which allowed your applications to run on their systems. Those companies included Microsoft, Netscape, etc., so that your applications could run on Windows or in your browser or on other platforms. So all was good with the first version. Then in 1997, they made an update to Java 1.0, and it was released simply as the Java JDK version 1.1. In the press release, it wasn't referred to as Java 1.1, it was simply referred to by the JDK version. Then things started to really get interesting. In 1998, they made a significant update to the technology, so much so that they decided to brand it as Java 2. So that's what you saw in the press release. In addition to calling it Java 2, they also released 3 different types of the platform. So as a developer, if you were building standalone applications, you would download what was called the Standard Edition, affectionately known as J2SE. If you wanted to build enterprise applications that ran on a server, you would develop with the Enterprise Edition, or J2EE, oftentimes called J2EE. And then if you wanted to build applications that ran on small independent devices, you would use J2ME or the Micro Edition. Now, if that isn't confusing enough, the version number was not updated to 2.0. It was simply bumped up to 1.2. So now you're downloading J2SE version 1.2 instead of Java 2 as it was referred to in the press. Now, the Java 2 branding lasted through several additional versions. So when the JDK was updated to version 1.3, it was still called Java 2, same thing with 1.4. Well, when JDK 1.5 came out, it again was a very significant change. So in the press, they still referred to it as Java 2, but now they called it the Java 2 Platform 5.0. And on the JDK side, it was called J2SE, but instead of bumping it to version 1.5, it was now version 5. So now we're starting to converge on both sides of the camp. The next release of Java was branded as Java 6, and as a developer, the name changed to Java Standard Edition 6, as well as the other editions, the EE and the ME versions. There were many security updates that happened during this period, and so instead of bumping the versions, they simply called them updates. So now you would download Java SE6, Update 1, etc. And this went all the way up through Update 45. There were a few updates that happened after that, but they were not publicly downloadable. Java 7 was pretty much the same as far as naming went. To the public, it was called Java 7, and the JDK was simply called Java SE7. And as time went on, they also created several updates for that. Now we're on Java 8, and as they create updates for that, I'm sure it will follow the same naming convention. Now I mention all this because as you work with Java, you're still going to see a lot of its early roots. For example, when you're working in a terminal or a command line and you ask Java to tell you what version you're on, even though I've installed Java 8, it still replies back saying I'm on version 1.8. So the compiler still follows that original naming convention. So that's Java's sordid history of version numbering. Hopefully this will clarify what you see as you work with Java. Let's take a quick look at how a Java application goes from the code that you write as a developer to an application that you run on a device. The first step is to write what is called a source file. This file will contain the instructions you want your application to perform. You write it using the Java syntax that we are learning in this course. Source files are simple text files, so you can create them in any text editor. However, you can be more productive using a programming tool that checks your syntax and provides shortcuts to a lot of your typing. We call this an Integrated Development Environment, or IDE. In this course, we will install and use a very popular IDE called Eclipse. However you choose to create your source files, they will need to have the file extension .java. If I were creating, say, a mobile application that checks stock prices, I could name the source code file stock.java. The processor on your device cannot understand human-readable text, so your source file needs to go through a process called compiling. Languages like C and C++ get compiled all the way down to what is called machine code, where the processor can essentially read and execute the file directly. This gives you the fastest performance, but if you want to run your application on a device with a different kind of processor, you have to recompile it specifically for that device. Java is compiled into what is called bytecode, which is the same for all devices and operating systems. So the same compiled Java file can run on any device that supports Java. This is a huge advantage when you want to distribute your application across multiple operating systems. And with modern devices, the performance loss is often measured in nanoseconds. To compile your .java file, you use a utility called javac, which is the Java compiler. We get the Java compiler from the Java Developers Kit, which is one of the reasons we downloaded and installed it. By running the javac command, which stands for Java compile, it compiles your file and gives the new file the extension .class. Continuing our stock application example, I would execute the command javac followed by the name of my source file, stock.java. This would compile the source file and create a new bytecode file called stock.class. In order to run Java files, you need to have a Java Virtual Machine, or JVM, installed on that device. This is also called the Java Runtime Environment. You can install a JVM on almost every operating system out there, including those on tablets and phones. The JVM reads your compiled Java file and executes it. On a device with a terminal, you do this by the Java command followed by the file name that you are running. Then your application runs in the style in which it was written, whether that is in the terminal itself, a browser, or its own graphical user interface environment. Taking our compiled stock checking application, we would enter the command java space stock. Notice we do not need to include the file extension in the command, and our application runs. Perhaps it may look something like this on a mobile device. So in summary, you first write your source code, compile it, and then run it on any device running a Java virtual machine. In this video, we are going to install our development environment on Windows, and that's going to involve two separate parts. The first will be the Java Developers Kit, or JDK, which allows us to compile and run Java applications, and the other part is an Integrated Development Environment, or IDE. That's a graphical environment which is going to improve our productivity as we write Java. We will download both of those from their respective websites. We'll start with Java, which you can find at www.java.com. You'll notice on their homepage they have a button here which says Free Java Download. Now I bring this to your attention because this is not what we want to install. This download is for the Java Runtime Environment only, which lets you run Java applications but doesn't give you all the other tools you need for developing and compiling. So for that we need the Java Developers Kit, which you'll find down here at the bottom of their page by clicking on the Developers link. So from here, we'll go to this JDK Downloads link. That will take you to their download page, and we want to download Java 8, and particularly we are going to download the Standard Edition. So again, we want the JDK, so we'll click on this first button here. It will bring you to their download page where you'll need to first accept the license agreement, and then come down and choose your platform. So for this video, we're working in the Windows environment, and you'll need to choose whether you're running a 32-bit or a 64-bit version of Windows. If you're not sure which version you're running, you can come down here to the Start button, and this will work on Windows 7 or Windows 8. Then just right-click on Computer and say Properties. On the Properties page, next to System Type, it will tell you which version of Windows you're running. I'm running the 64-bit operating system, so I want the 64-bit version of the JDK, which is right here on this link. So I'll click here to download it, and we'll just let the file download. Depending on your browser, you may have a different dialog for downloading files. Once your file is downloaded, you'll want to double-click on it to execute it. And this is a very simple install. You basically just choose the defaults for everything and let it take care of the rest. So I'll say Next. I'll ask it to install everything, and then just let it finish up. Next. And we're ready to go. Now there are two things that I always like to check after I've installed Java, and that is to ensure that everything runs correctly from your command line. Now Eclipse will run independently of your command line, and so it will take care of everything on its own, but there may be times when you want to go directly to your command line and execute some of the developer commands. So let's test that real quick by going to our Start menu, executing cmd, and the two things that I want to do are to check the version of the runtime environment and the compiler. We do the first by just typing in java space dash version. And you'll see that it comes back saying that we're on Java version 1.8, which in marketing terms is Java 8. So we're good to go there. So this will let us run any Java applications. Now we also may want to compile Java applications from our command line. You check that in a similar way by saying Java C for the Java compiler, space -version. Now you'll notice here that the command is not recognized. And that's because when we installed Java, it configured everything for the runtime environment, but it didn't set up our actual development environment for the command line. Now this is really easy to fix. Just go ahead and close your command line, and then come back to the Start menu, right-click on Computer, and choose Properties. What we are going to do is set a couple of environment variables, and that's done by going to Advanced System Settings and then saying Environment Variables. The first one we are going to set is called the Java Home variable, and that just specifies what directory the JDK is installed in. So we create a new system variable, and we call it Java_home in all caps. The variable name is the path where the JDK is installed. Now it's probably easier just to browse for that. So I'll come here and open up a Windows Explorer to my computer, double click on my C drive, and then go into Program Files. You'll find Java under the Java directory. And as you can see, we have the runtime environment down here, but specifically we want the Java Developers Kit or JDK here. So I'll double click on that to open it. And you can see I've got that path up here at the top of my folder. You can take advantage of a handy little shortcut by just clicking on this folder icon. That puts the full path to the directory right up here in the address bar, and it's already selected. So I can just do a Control-C to copy it, then come back to my environment variable that I'm defining and do a Control-V to paste it in there. Click OK, and now you've got Java Home set. Now, the main reason that the Java compiler wasn't recognized in our command line was because the path to the libraries underneath this directory were not in our path. The path is what tells your command line where to look for executable files. And you can see a variable called path that's already set, so we are just going to edit that variable. I'll click Edit, come to the very end of the line, and add the new path to our JDK. So I separate the last item in the list with a semicolon, and instead of typing in that whole pathway again, I can just reference the variable name that I created. And I do that by enclosing it in %signs. So I open a %, I say Java_home in all caps, close the %, and specifically I want to go one level deeper into the bin directory. That's where all the executables are. So I'll do a \, and put bin at the end. Now we'll click OK, get all the way out by clicking OK. And in order for this to work, you need to open up a new command line. So ensure that you close the one that we had open earlier. Now I'll come back here and say cmd, and I should be able to say Java C -version. And it comes back saying that I'm on, again, 1.8.0, which is the Java 8 version of the compiler. So we are good to go in both regards here. Okay, the second step is to get Eclipse installed, and this is very simple to do. Let me just clean up my desktop here and go back to my browser. You'll find Eclipse at their website at www.eclipse.org. From their homepage, just go to their download button here on the right, and we want Eclipse Standard, the latest version. Now it knows that I'm on Windows, so all I have to do is choose 32 or 64-bit. Again, I'm on 64-bit, so I'll click that, then just choose where you want to download it from. I'll click this top link here, and then it will begin to download the file. It's a pretty good-sized file, so just let it download. Now, Eclipse is a zip file. There's actually no installation that you run to get Eclipse installed. I'll just click on it to open up the file, and it just comes in a directory called Eclipse. So all you need to do is drag it to the location where you keep your applications. Let me close my browser here and open up a new Windows Explorer. And I'm going to put mine right inside of Program Files, along with the other applications that I run. To do that, all I need to do is just drag it from the inside of the zip file and just place it right here. Windows will take care of the rest and unzip everything. Once Eclipse has unzipped from its file, if you open the subdirectory, you'll find the icon for launching Eclipse right here. Now I don't want to go into this subdirectory every time I want to run Eclipse, so I'm going to create a shortcut of this icon. I do this by right-clicking, saying Send To, and sending it to your desktop as a shortcut. That will put the shortcut right here on the desktop. Then what I like to do, since I'm going to be using this so often, is I like to put it down here in my taskbar. So I'll just drag it down here and pin it. So now we have Java ready to go, and we have Eclipse installed so that we can start taking advantage of all it has to offer. In this video, we are going to install our development environment on Apple's OS X. Now, normally Apple provides a very simple way to install Java. Simply by running any Java command, it will detect that you don't have Java installed, and it will prompt you to install it. However, as of this video recording, Apple has not quite caught up to the newly released Java 8, so we are going to install it manually, which is still very simple to do. Once we have Java installed, we'll then install Eclipse, which is a graphical, integrated development environment which will increase our productivity as we write our Java applications. So let's start with Java. We'll just go directly to the Java website to get a download, and the address is www.java.com. Now you'll notice this button here that says Free Java Download. This is only for the Java runtime environment, which lets you execute existing Java applications. It doesn't give you the tools that we are going to need to develop Java applications. So to do that, just scroll down to the bottom and click on the developers link. Then come over here to where it gives you the link for the JDK downloads. We want to install the Java Developers Kit version 8, so we'll click on this download button, and it will take you to the main download page. Now the first thing you'll need to do is accept the license agreement, then come down and choose the platform for which you're going to run the JDK. For us, that's Mac OS X running in 64-bit mode. So let's click on this link and begin the download. It will take just a moment, so go ahead and let it complete. Now, since this downloads as a disk image or DMG file, all we have to do is run it to start the installation. So I'll come down to my Downloads folder. I'll say Open in Finder, and then just double-click on the file we just downloaded. This will start the installation, and we just double-click here to begin. It's a very simple install. You essentially just choose all the defaults, so I'll choose Continue here. I'll install it, put in my administrator's password, and say Install Software. And we're all set. So I'll close this and just clean things up a little bit here. Now, once I've installed Java, there are two things that I always like to test. And that is to make sure that the runtime environment is working, as well as the Java Developers Kit. And the easiest way to do that is from a terminal. I'll just go up to my Go menu and choose Utilities, and at the bottom, I'll run the terminal. To test the Java runtime environment, you just put in the command java -version. It should come back that it's running Java version 1.8, which is the marketing term for Java version 8. Now to test the Java Developers Kit, I'm going to execute javac, which is the Java compiler, and then -version. That should also come back with 1.8.0 in this case. So now we know that both our runtime environment as well as the compiler are both running Java version 8. So we're good to go on the Java side. Well, let's finish up by installing Eclipse. We'll get that from their website, which is at www.eclipse.org. They just have a download button here on the front page, and they know that we're running OS X, so we just choose 32 or 64-bit. All versions of OS X since Lion run on 64-bit, so I'll click that. choose the location where I'm downloading it, and then it will begin the download. Eclipse just ships as a tar file or a compressed archive. There's really no installation. All you need to do is put it in a location where you want to keep your applications. So I'll open it in the Finder, and to unpack it, you just double-click on the file. Here's the application, but it's sitting in our download folder. What I'd like to do is just move it into my applications folder, so I'll just click and drag it and drop it right inside of applications. Now if I click on applications, I should see Eclipse in here. To run Eclipse, you just open it up and double-click on the Eclipse icon. Now to keep this handy, you may want to drag it down onto your dock. Now you have it right where you need it. So we're good to go. We have our Java Developers Kit installed, as well as Eclipse, which will help us out as we write our Java applications. In this video, we will install our development environment on Linux. Now there are many different flavors of Linux. I'm going to be using Ubuntu, which is one of the more popular versions. We will need to install two different things. The first is the Java Developers Kit, which gives us the tools we need to compile and run our Java applications. And then we will also install Eclipse, which is a graphical integrated development environment, or IDE, that will make us much more productive as we write our Java code. We'll start with Java. So let me first bring up my search dialog, and I'll search for terminal. We'll run our terminal. And the first thing I'll do is just see if Java is already there. We can do that by typing in the command java -version. You'll notice that it's not installed, and it gives us a couple of suggestions for how to install that. Now we want to install Java 8, which is not part of this recommendation. So let me show you how to do that. We are going to be using the Advanced Packaging Tool, or APT. The first thing that we need to do is add the repository containing the download files we want. We'll need to do that as a user with root access, so we'll start with the sudo command, and we'll say add-apt-repository space, and then the site where our files exist. So that's ppa:/web update team/Java. Then I'll press enter. I'll need to enter my root password. And now it has added that repository. Now you always want to be careful when adding new repositories to your environment. Web Update Team is very well respected. And the nice thing about this particular install is that they don't actually host the files that we need. They simply point to the files on the Oracle website. I'll finish this up by pressing enter one last time, and we're ready to go. Now before actually installing Java, I'll run an apt update by saying sudo space apt-get space update. So this just updates all of the system files on my workstation. Depending on how long it's been since you've done a file update, this could take a little bit of time. And so now we're ready to install Java 8. So again, we say sudo. We're going to run this as an administrator. apt-get space install space, and the name of the library is Oracle-Java 8-set-default. And this is a special installation which not only installs Java, but it also sets it as the default development environment. Press enter, and away it goes. We want to continue. We'll accept the license agreement by pressing enter, and then press your left arrow and enter on yes. Now, once the install finishes, there are two things that I like to test first, and those are to make sure that the runtime environment is working as well as the compiler. The way I test that is by entering first the command java -version like I did before. Now you'll notice it comes back saying that version 1.8 is installed, which the marketers call Java 8. To test the compiler, I do something similar. I say javac for Java compiler space dash version. And that should also come back saying you're running on version 1.8. So Java is good to go. Now we just need to get Eclipse installed. And this is done right from their website. So let me open up my browser. And I'm going to go to the Eclipse website at www.eclipse.org. Let me maximize this, and I'll just click on their download button. It knows I'm running Linux, and I'm on a 64-bit version of Linux. So I'll click on the download link for that. Choose the location where I want to download it from. And I'm going to choose that I want to open the file after the download is finished. So I'll click OK and let the download start. Once it finishes downloading, it opens up the archive. All we need to do is tell it where we want to extract these files. And everyone has their own personal preference where they like to install applications. To make it easy, I'm just going to put mine in my home directory. So I'll click Extract, and I'll just put it right here in the mic directory. Okay, so it's done extracting, so I'll say Show the files. And here's our Eclipse directory. Inside of that, you have this Eclipse icon. Simply by double-clicking on this, you'll run Eclipse. So you can just leave this here, or you can move the shortcut off to your sidebar. Now we're good to go. We have our development environment all installed, and that includes the Java Developers Kit, as well as Eclipse. In this video, we will get our first look at Eclipse, and we will set up the project that we will be creating throughout the rest of the course. So wherever you put the Eclipse shortcut, go ahead and click on it to open it. Now in Windows, you'll get this warning about opening the file. I'm going to uncheck this so I don't get this dialog every time I run Eclipse. When Eclipse opens, it's going to prompt you for the location of what's called the workspace. This is where Eclipse is going to store all of the files that you create. Now you can put this anywhere you like. Every platform is going to have some kind of user's home directory, and that is where I'm going to define my workspace. C:\users mic documents, which is the My Documents folder, and then I'm going to create a workspace directory called Java. So you can browse to a different location if you like, or you can type in your particular workspace location. Now you probably don't want Eclipse to ask you this question every time you open it, so you can check this box here, which will now use this as the default workspace location. Then click OK and Eclipse will open. The first time that you open Eclipse, you will see what's called the Welcome screen, and this just has some handy links to some documentation, an overview, some samples, a couple of tutorials, and so forth. Eclipse uses a tabbed user interface, so you can close this welcome screen simply by closing the tab. This will bring you to what's called the workbench. Now, if you want to see the welcome screen again, you just go up to the Help menu and you say Welcome. Let's set up our project. Our application will be contained inside of what's called a Java project. So to create that, we just go to the File menu, we select New, and we say we want a new Java project. There are a couple of settings that we need to give it, not the least of which is the name of the project. And since we're creating an airline reservation system, I'm going to call the project Reservations. It will ask you where you want to put the files that you're going to create, and as you can see, it defaults to the workspace directory that we set up earlier. Now, this next section is an important one. This tells Eclipse which Java runtime environment you want to use to execute the files that you create. The default is what's called Foundation 1.1, which is a standardized configuration for running Java files. There are a number of these to choose from. Each one will configure your Java application to run under a different version of Java. What this will do is when you're finished building your Java application and you bundle it all together to run, if you use one of these pre-configured setups, your application package will be smaller in size. Now for this course, we're focusing on Java 8, which is brand new, And so Eclipse hasn't actually caught up to a Java 8 configuration yet. So we need to be specific about that. Now we installed Java 8 and made it the default runtime environment when we're using our command prompt. And Eclipse knows about that. So instead of selecting a built-in configuration, let's just tell it to use the default Java runtime environment. And it tells us that that is set to Java runtime environment version 8. That way it will compile and run using Java 8. Well, that's all we need to set up right now. So let's click Finish. And now we have our project. It's represented here as a folder. And this Package Explorer will give us access to all of the files that we create for our application. Let's see what's inside of it currently. Right now, our reservations package contains all of the libraries for Java 8, and it contains what's called a source folder. This is just a location where you are going to store the files that you write in Java. Now, as we create different types of Java files, we want to organize them into what are called packages. Packages are used when you bundle the final version of your application together, and it allows you to include certain packages in your bundle and exclude others. For example, we will be writing tests for a lot of the files that we create. We don't need to bundle those into the final version of our application. So we'll put them in a separate source folder. The next thing that we'll do before we write our first Java file is to create a package. That's done by right-clicking on the folder, saying New, and then choosing Package. You'll notice that it's going to put our package inside of the src folder, so the name that you give your package is pretty important. It's used to uniquely identify the files that are going to be inside this package in the event that you end up sharing them with others. And in the Java community, that's fairly common. So if I create a file called customer and you create a file called customer, we have to be able to share those in a way that they don't conflict. And that's done by putting them in a unique package. Now, the Java committee and Oracle recommends a naming standard for your packages, which is your domain name on the internet in reverse. Now, if you're never going to share your application, this isn't as important, but let's assume that you are. So if my website is www.airline.org, the naming convention I should use for my package so that it doesn't conflict with anyone else would be org.airline. Then follow that typically with the name of your application, which for us is reservations. So that is going to be our package name. Let's click Finish and it'll create it for us. And there it is right there. So all of the Java files that are going to execute as part of our application will go inside of this package. Now, in much larger enterprise applications where you may have hundreds of different Java files, you may break these packages down even further. So for example, the Java files that represent the data portion of your application may have their own package. And then the files that represent the user interface would be in their own package. But since we're not building that large of an application, we are just going to put everything into one package. So our project is all set up, and now we're ready to create our first Java file. In this video, we will create and run our first Java application. We created a package called org.airline.reservations, and this is where we want to put the file that we are going to write. These files are known as classes in Java, and classes are part of the object-oriented nature of Java applications. We won't be covering object orientation just yet, but in order to create a new Java file, we right-click on our package, and we say New and Class. So again, double-check that it's in the right source folder under the package we created, and then we need to give our class a name. The naming convention we use is that the class should start with a capital letter. I'm going to call this class Demo, so I'll use Demo with a capital D. And then I'd like you to click this first box here that says public static void main, and then has this string and args at the end. I'm not going to explain everything about this class just yet. I just want the very basics to get this going, and this will save us a little bit of typing. So now click Finish. And here is our class file in our structure, and it shows up here in the editor. So this is the beginning of a source file. It has the package that it's contained in at the top, and every Java source file contains one and only one class. So this line tells it the name of that class. You'll notice that it matches the name of the file without the extension at the end. Then here's this line that we checked when we created the class. This is what's called a method, and a method contains the instructions that you want your Java application to perform. When we run our application, the Java runtime environment is going to look for a method called main. And so that's why I checked that box to include the line that defines the main method. We'll talk about the details of what all this means a little bit later. You'll also notice that the class begins and ends with a curly brace as well as the main method. So both of these begin and end with curly braces. The instructions that we're going to create for our Java application will be contained in between the curly braces for the main method. And for this very basic example, we are going to give it just one simple instruction, and that is just to print something out on the screen for us. So I'll press my Tab key so that the instruction is aligned underneath the main method. It's not required, but it looks nice. And the command we're going to give is called system with a capital S, period, out, period, print ln. Now that's a bit of a mouthful, but essentially what it means is we are going to print a line of text. And the command to do that is contained in a Java library. A library is just a container of other Java applications that you can execute. And println is part of a library called system in a subcategory known as out, which stands for output. That's exactly what we're doing, is we're sending some output to our screen. Now, what we are going to ask Java to print to our screen will be inside of two parens, and the text that we're going to print out is going to be inside of quotes. Now, in most programming classes, the first thing you ever print out to a screen is the text "Hello World." I'm a bit of a rebel, so I'm going to deviate from that just a little bit. And my very first text string is going to say, "Look, Ma, I'm programming." You can really put whatever you want in here. But the idea is we are going to send this string of text to our screen. Now, at the end of every Java command that you type, you end that with a semicolon. So this is our first Java application. It's just one simple instruction. Let's save this, and now we can run it. Well, instead of running it from a terminal or a command line, we can run it right inside of Eclipse. And we do that by right-clicking on the file we just created, saying Run As, and choosing Java Application. What it will do is it will open up a console, which is the same thing as a terminal or command line, and it will put the instructions from our application down there. And it's doing just what we told it to do, print out this line of text to the screen. Okay, so that was pretty straightforward. The nice thing is Eclipse did a lot of work for us. It saved us a lot of typing up front. It compiled our file in the background when we saved it, and then it ran it in the Java runtime environment when we asked it to run as a Java application. And so now you're seeing the benefits of why we decided to use Eclipse as opposed to something like a text editor and a terminal. In this video, I want to show you the mechanics of how we can write, compile, and run a Java application. Eclipse did a lot of this for us for free, and so I think it's important to understand what really is going on. It will also give you an appreciation for all the benefits you get of using Eclipse. So let's write a really simple Java application using Notepad. I'll just run Notepad from my Start menu, and you can use any text editor that you have available to you. Now in Eclipse, we only had to type one line of the actual code that we were executing. because Eclipse provided everything else for us. Well, with a text editor, we are going to have to type in everything. This is going to be a class called Note, and so the first line we have to write is to declare that class. Again, I'm not going to explain every single thing we type because I really just want to show you the mechanics of compiling and running a Java application. So the first line is the class declaration, and that starts out with the word public space class, saying we're creating a class here, and the name of the class is Note. Again, the naming convention for classes is they begin with a capital letter. The class will begin and end with a curly brace, and everything in between the curly brace is what's inside of the class. So let me push this down a bit. And inside of our class, we will have our method called main. So I will indent by 4 spaces. The number of spaces is really up to you. But to define our method, we say public space static space void space main. So that's our method. And don't worry, you'll understand what all those words mean a little later on. Inside of the main definition, we open a paren and we say string open and close square bracket space args, close the paren, space, and just like with the class, everything that goes inside the method will be between 2 curly braces. So let me push that one down a little bit and I'll indent it as well. Now we'll put our command, which I'll indent again, and all I want to do is simply print something to the screen. So that command will be system.out.println, and in parens, we put a quoted text string. I'll just say Java is easy. Close my quote and make sure my paren is closed, and then at the end of the statement, we put a semicolon. All right, so now we'll save our source file. Here's my documents directory underneath my username, and this is the workspace area we created for Eclipse earlier. I'm going to put this file in that same place. Now I'm going to keep it out of the way of the project that we're working on in Eclipse, so I'll just leave it right here, and I'm going to call it Note. Make sure it has a capital letter, just like the class definition does, and use the extension Java. I'll save that. And now that we have our source file created, we can compile it. To do that, I'll bring up a terminal. Now I need to move to the location where that file is. And for me, that's inside of my documents directory underneath Java. If I look for my files, I should see it right here. And you'll want to double check that Windows or whatever platform you're using didn't put an additional extension on it. In other words, sometimes when you save text files in an editor, it wants to tack on a txt extension there. And for us, it needs to only have a Java extension. So now we compile it, and we do that by executing the Java C command for Java compiler, space, and then the name of the file we are compiling, which is note.java. Press enter, and you should just get your prompt back. If you didn't get anything else back, that means it compiled successfully. If we look inside that directory, we can see that now we have a file called note.class. So that's the compiled version of your Java file. We execute that by just saying Java. That runs the Java runtime environment, and then the name of the file, but you don't have to put the extension on it. Press enter, and it executed the file, printing out that string. This is the manual way of creating and running Java applications. If you've been following along with how we've done this in Eclipse, you can see how big of a time saver it is. So this is probably the last time you're going to see me do it this way. I want to take advantage of all of the productivity gains I get by using Eclipse, so that's what I'll be using from now on. But this should give you a nice understanding of what's happening behind the scenes. You organize a Java application by dividing it up into classes. If you were to describe what your application does, think of classes as the nouns in that description. So if you were building an ordering system, You might have classes representing customers, orders, and products. If you were building a game where you knock down a structure with a cannon, you might have classes for the cannon, the projectiles, and the blocks of the structure. Let's take a minute to organize the classes we need for our airline reservation system. Remember that this is a simplified design. We will only need a few classes, whereas a reservation system for a commercial airline may have 20 or more. The core of our reservation system is going to be a class called Ticket. The ticket will contain or link to all the other information in the system. One of the core pieces of information that will be on that ticket is the passenger, so we'll create a separate class just for the passenger. It will contain information such as their name. Now I've drawn an arrow between the ticket class and the passenger class. This is called the relationship between the two classes, and the direction that the arrow is pointing indicates that the ticket has a passenger. Now, if you've ever made an airline reservation, you also know that, of course, that ticket has a flight. So we'll create a class for the flight. The flight will contain information such as the destination city, the time of your departure, etc. So every ticket will have a passenger and a flight. And finally, when you purchase a ticket, you are also reserving your seat. Now, this is one place that we are really simplifying this system. We only own one airplane, and that airplane has 6 seats on it. In a commercial reservation system, each flight might involve a different airplane with different seating arrangements. So therefore, we would need classes for the aircraft, the seating layout, and so forth. Since we only have one airplane, those 6 seats will be the same for every flight. And so therefore, we will just link them directly to the ticket. This will keep things simple for the application that we're building. If you later go on to learn more about enterprise application design, you'll deal with these more complex structures. So these are the 4 main classes that we will start with as we build our application. In this video, I'd like to show you around in Eclipse a little bit and also set up a practice area that we can use to try out new snippets of code that we're going to write. So first, a few things about Eclipse. As with all good applications, Eclipse ships with some really good online help, and you can get that right out of their help menu in the Help Contents screen. There's lots here that you can read, and it's of course broken down by topic, and you can search for things as well. So keep that in mind as you want to learn more and more about Eclipse. This arrangement of work areas is what we call the workspace, and it's made up of these tabbed areas, each tab performing a different duty, so to speak, within Eclipse. Now you can arrange these tabs however you want, and whenever you leave Eclipse and come back in, it will save your workspace as you exit. So that way, when you come back in, it will look exactly the way it did when you left. Now you've probably worked with tabbed environments in your browser, for example. And so in the same manner, you can of course close and open tabs. You close the tab as you would expect by clicking on the close button to the right of the tab. And if you've closed a tab and you want to reopen it again, you'll find them all underneath the window menu by going to Show View. So I just closed the outline view, so I'll come back and open it back up again by choosing it here off the menu. Now it opened in the last place where it was located, but I have the ability to rearrange these views however I want. You do that just by clicking and dragging the view. And you can see what I mean. As I come down here, I can stack the views on top of each other. I can put them side by side. I can move them over here. I can put it down here right next to these other tabs down at the bottom. So I have all kinds of flexibility on how I arrange my views and where I put them in my workspace. I'm working with a pretty small screen for these videos, so one thing I like to do is close down the views that I'm not using. We won't be using this outline view. We'll come back to tasks a little bit later. So now my text editor has quite a bit more space. I can then come over here and I can resize my views So maybe I'll shrink this up just a little bit. So this gives me a nice open workspace for editing my Java code. Now, depending on what you're doing in Eclipse, there are typical views that you usually have open. For example, when we're writing Java, we would want our package explorer to be open. That shows us our different source files. We certainly want the text editor, and maybe we want the console to be open. There are some pre-packaged workspaces that are already bundled within Eclipse, and those are called perspectives. A perspective is just a predetermined set of views that are opened, and their layout is predetermined as well. You'll find your perspectives up here on the right, and simply by installing the Java JDK, Eclipse now opens with the Java perspective. This is your generic code writing perspective. However, later on, as your application gets more and more complex, you may want to open up a different perspective, and a common one is set up for debugging your Java applications. So another common perspective is the debug perspective. And you'll find those right here under the Open Perspective button. You can just click on that and you can see all the available perspectives. So if I wanted to switch to debug, I would just click on that and say OK. And now you can see that there are different views that are open and their arrangement is a little bit different. This just allows you to focus on different types of tasks. The nice thing is I can easily switch back and forth between my perspectives just by clicking on these. And if I'm done with one, like debug, for example, I can just right-click on it and then close it. Now finally, you can minimize and maximize your views, and that's helpful if you want to temporarily focus on something without actually closing the tab. Let's say I'm running an application in my console, and I want to see this console full screen. Well, I can just double-click on it, and now it makes it as large as it can. Then when I'm finished, I just double-click on it again and it restores it back to what it was. I can also minimize things just by clicking on the minimize button, and that will send it over here to the left in its own toolbar. So again, that gives us more screen space for our other views, and then if I want to bring it back, I just click on restore and it pops it right back to where it was. So those are some quick navigation tips with Eclipse. We'll be looking at a lot of different things as we go along, but that'll get us started. The last thing I'd like to do is set up a practice work area so that we can try out simple snippets of code. When we wrote our demo class, we had to set up the package, we had to declare the class, we had to set up our main method, and then we just wrote our one line of code here. It would be nice to be able to try out these lines of code without having to bundle it all up with everything else that's needed. And we can do that through what's called a Scrapbook page. To use the Scrapbook, you need to create a Scrapbook page. And I'm going to put it right underneath my reservations folder. I don't want to put it inside my package here because it's not going to be part of my final application. So I'll just come up here, right-click on it, and say New. And it's a little bit hidden. I have to come down and say Other, and then go inside of the Java folder, and inside of the Java Run Debug folder, and there I can create a Scrapbook page. Choose Next, and then I'll just give my Scrapbook page a name, and I'll just call it Whiteboard, because it's just going to represent some of the things we're going to practice. I'll choose Finish there, and now I have my whiteboard page. The beauty of this is you can just write a piece of code and then execute it. Now there are several different ways that you can do that, but let me show you the way that we'll be using it most often. Let me just write that one line of code that we did in our demo, which was system.out.println, and we'll just print a line of text. Maybe I'll say, practice Java every day. That is a valid line of Java, but it's not inside of a method and there's no class or package defined. To execute this, I select what I want to execute, and then I just come up here to the Execute Selected Text button. And it'll execute that. I told it to print this line of text down in my console, and so when I look down at the console, I can see that. So we'll be using this quite a bit in the beginning as we start to explore the different aspects of Java. In this video, I'm going to introduce the concept of variables. Any application you build will need to store and manipulate information. For example, the name of a customer, the amount of an order, or the speed and position of a projectile. We refer to these containers of information as variables. Now, there are other categories of variables that have different names, and we'll start to use those later in the course. But for now, we'll just call them variables. Now, when you define a new variable, we have to give it a valid name and tell Java what kind of information will be stored in that variable, and that's known as the variable's type. We can then recall that information as we need it by referring to it by its name. So we are going to use our Scrapbook to introduce variables. Now, if you don't have your Scrapbook page that we call Whiteboard visible in your workspace, you can bring it up easily. Let me close all this down and I'll show you. So if your Project Explorer is not showing, we can bring it back up by just going to the Window menu, saying Show View, and choosing Project Explorer. Here's our application called Reservations. We can open that up, and here is our Whiteboard page. So you can show that just by double-clicking on it. And then all of our source files are under this source directory inside of our package. And here are our source files that we've created so far. So let's work with our whiteboard. To define a variable, you start out by stating its type. And in technical terms, this reserves the appropriate amount of memory for the information. But more importantly, it keeps you from putting the wrong kind of information in the variable. For example, it would keep you from trying to store a picture in a variable that should be storing a date. And if your actual Java code has these mistakes in them, Java will tell you when it compiles your application instead of having you find out while your application is running. Now, there are two different groups of types that we'll be working with, and those are primitives and complex types. Primitives are the basic variables that contain things like numbers and single characters. Let's start with a primitive type, and we'll work with the basic number that has no decimal places in it. We call that type an int, which stands for integer. To define that, we start out by giving the type, which is int, follow it with a space, and then you give your variable a name. Now, the Java documentation, which is at docs.oracle.com, describes both the naming rules and the standards for variables. The net of all of that is that you should begin your variable with a lowercase letter and follow it with additional characters or numbers. So let's call our variable flight. Then you end this definition with a semicolon. Now, you've seen me do this several times, so let's address when we use semicolons. And I'm going to go back to our demo.java file that we created earlier. Now, there are some complex definitions of when you end things with semicolons and when you don't. But instead of going through all of that, let me give you a basic definition that will work for the majority of this beginning course that we're in. And that definition is this. You want to end every statement that you write with a semicolon unless that statement is a comment, which begins with 2 forward slashes, and we'll work with comments a little bit later, or if your statement ends with a curly brace, whether that is an open or a closed curly brace. So you'll notice that everything with a curly brace on it doesn't have a semicolon, as well as this statement here, which is a comment beginning with 2 forward slashes. Everything else does have a semicolon after it. This line here and this line up here at the beginning. So again, there are technical reasons for all of that, but if you keep that basic rule in your head, it's going to work for everything we do in this course. That is the minimum syntax required for a variable, just its type and its name. At the moment, we haven't assigned a value to this variable, and sometimes when you declare a variable, you don't know what its value is going to be. That comes later on in the application, so you just give it its type and its name. Now, if you do know what the value is, you assign that by putting an equal sign and then the value. Now for integers, that's just the number without any decimal places. So for example, this might be flight 5100. So this is how I would define that. Now, just a final word about variable names. Technically, a variable can start with a $, an underscore, or any letter. However, all the documentation strongly discourages you to begin it with anything except for a letter. And the standard is to begin variables with a lowercase letter. You should also use meaningful names for your variables. For example, flight as opposed to just the letter F. That's because your Java code should be somewhat self-documenting. Anyone else that comes along and looks at your code should easily understand what this variable is being used for. Flight is a lot easier to understand than just seeing the letter F. Now, if your variable is going to contain multiple words, again, the standard is to keep everything in all lowercase, but begin any subsequent words with an uppercase letter. For example, if we wanted this variable to be called flight number, we would spell it out like this, with the second word being an uppercase N. And we call this camel case. This is the best practice for naming variables using the camel case format. And by the way, whitespace is not allowed in variable names. And so we'll be looking at variables in detail as we go along in the course. In this video, we've begun our study of variables by learning how to define them. We specify their type, give them a name, and optionally assign them a value. In this video, we are going to learn how to work with integers. When you declare an integer in Java, you first start out by specifying the type, which is int, followed by the name of your variable, the operator, which is always equals when you're declaring a variable, and then the literal value that you're assigning to your variable. So in this case, we've created a variable called flight number and assigned it a value of 5100. Once you've done that, you can now refer to the value of that variable simply with its name. For example, if I wanted to print the value of flight number to the screen, I would use our systemoutPrintln command. And instead of putting some value in quotes like we've been doing, we can just put the variable name. And as a result, it will print the current value of flight number to our screen. So let me select all of this and then execute that from our Scrapbook page. And you can see down here in the console, I'm getting the value 5100 just as we assigned it. So now whatever value is assigned to flight number, I can use that in my Java class simply by specifying the variable name. Now, as I've mentioned earlier, sometimes you don't know the value of a variable when you declare it. And so sometimes you may declare your variable in this way without an actual value. And then later on, you'll then decide or derive the value for that variable. Since you've already declared the type as an integer, you won't need to do that when you set a value to flight number. It would simply look like this. You use the name of the variable, an equal sign, and then the literal that you're going to assign to it. So this is the same thing that we had before, it's just that you're declaring the variable with an empty value up front and then later on assigning it a value. So let me just clear my console and we'll execute these 3 lines of code and we get the same result that we did before. So let's talk a little bit about what can be inside of an integer variable. By its nature, integer means that there is no fractional value. So you can't assign a literal that contains any kind of a fraction in it. If I try and do something like this, you'll notice that I get an error. So it's saying here that 5100.1 looks like what's called a double, which we'll be covering later, and it can't convert that into what it's supposed to be, which is an integer value. Now, as you would expect, you can perform any type of mathematics on an integer. So for example, when I'm assigning it, I can say 5100 plus 1, and you'll simply get the result of that expression, which is 5101. So you can do addition, subtraction, multiply is with an asterisk, and division is with the /. Now, if the result of any arithmetic that you perform on an integer contains a fraction, That's okay. Java will just truncate the fractional part of that result. For example, if I divide 5100 by 7, that will have a fraction in the result. When I run this, you can see that it just takes off the fractional part and gives me just the integer. So you won't have to do any checks when you're doing arithmetic to ensure that the result is only an integer. Java will take care of that for you. Now you can do mathematics not only on the literals, but also on the variable name. For example, I can assign the variable at one point and then change it later on. And something that you'll see very common in Java is taking a variable name, assigning it itself, so I'll just copy and paste here, and then performing some additional arithmetic on it. So maybe I'll just add 1 to it. So this starts by assigning 5100 to flight number, and then taking the current value of flight number, which is 5100, and then adding 1 to it. So now I can execute this, and you can see my result is 5101, as you'd expect. In fact, you can do arithmetic purely based on the names of different variables. Let me create a second integer variable. I'll just make it another integer, and I'll call it other number. And right here, I'll just set it equal to 20. I can do arithmetic based on both of these names. Let's just take the flight number, set it equal to itself, plus the other number. So I have no literals in this expression, yet it will handle the mathematics just fine, as you can see here. So these are the types of things that we'll be doing with integers in our application. Now, just a last word on the range of values that can go into an integer. By definition, an integer can contain a value between minus and positive 2.1 billion. Now, that's an approximate value. If you're interested in the mathematics, an integer is a 32-bit number, and I'm not going to go on a tangent on binary math at the moment, but the equation is if you raise 2 to the 31 power, this is the maximum negative value that you can use on an integer, so minus 2.1 billion and change. Now the reason I raised it to 31 is because the 32nd bit is used for the sign to tell it whether it's a positive or a negative number. The maximum positive value that you can use is this value minus 1. So negative and positive 2.1 billion and change is what you can put into an integer variable. This is a pretty sizable number, and it will work for the majority of things that you're using in your applications. However, if you're writing an application in the field of, say, cryptography or maybe astronomy, you may need a number that's larger than this. And so if you try and stuff a value bigger than this into an integer variable, you'll get an error. So there's a special data type created just for really big numbers, and it's called the long data type. It's still an integer, but instead of a 32-bit number, it's now a 64-bit number. Just to give you an idea of how big this can be, again, the mathematics would be 2 raised to the 63 minus 1 for the positive side. So you can see that now you're dealing with extremely large numbers. So those are the two data types that we use when we're working with integers. Int for a 32-bit integer and long for a 64-bit integer. Now there are others if you're working with much smaller numbers, and those are the byte and short data types. It's somewhat discouraged to use those because it's very easy to overflow the values that go into them. They do use less memory, so for example, if you're embedding Java into your toaster, you may want to consider using those other data types. But for modern devices like smartphones and personal computers, it's not really something that you would worry about. So that should be enough to get us going in the use of integers. In this video, we are going to learn how to create floating point variables. When you need to work with a variable that contains a decimal fraction, we call that a floating point number. We call it floating point because we use a set amount of memory to store the sign of the number, the integer portion, and the decimal portion. So that means if you have a number that is large, in other words, the integer portion contains many digits, you'll have less room to store the fractional portion of that number. Let me give you a quick example. Using our scrapbook page here, let me just print out a number that's calculated by dividing the number 10.0 divided by 7. Now, by specifying a decimal portion, it will force Java to use floating point math on this expression as opposed to integer math, which would just truncate off the decimal portion. When I execute this, you can see down here the result that I get, which is the number 1 followed by quite a few decimal places. Now, if I add a value of 100 to this and then re-execute it, you'll notice that I'm now using 3 digits for the integer portion, and so the total amount of memory, which remains the same to store the number, now only has room to store a fewer number of decimal places as opposed to the first calculation that we did. So as you can see, the overall length of the number is the same, and as the integer portion gets larger, the decimal portion gets smaller. So that's why we call it floating point arithmetic, because the decimal place will float around the number. Now, as we look at these numbers, we are seeing the digits 0 through 9, whereas the computer that's performing these calculations are having to deal with them in the binary format, which includes just zeros and ones. So that means all of these numbers need to be converted back and forth between decimal and binary as we use them. Now, with floating point numbers, that can mean that there's going to be a loss of accuracy as you perform multiple calculations on a number. For example, when I was in high school, the computer I owned had an 8-bit processor, and so the calculations that it performed could only be contained within those 8 bits. I remember very clearly one day a friend of mine came home from class and said that he had learned how to calculate pi to as many decimal places as you want simply by performing a certain set of calculations over and over again on a number. Well, this was very exciting to me because I could write a program that did just that. And of course I did, and to this day, many years later, I remember the result of that program after running for an hour or so, giving me the result of 3.1415285771. Now, this is what we would call a precise number because it's written out to 9 decimal places. And when you're doing floating point arithmetic, it's very important that you understand the difference between precision and accuracy. So as I mentioned, this is a very precise number. Unfortunately, it's not accurate. If I bring up a calculator and I ask it to display the value for pi, you can see that these two numbers are different. So although this original calculation had 9 digits of precision, it's only accurate to 4 decimal places as compared to what's on the calculator. And so you need to be careful when you're doing floating point arithmetic to understand that that's what can happen. It's really just the nature of doing binary math. Now, in the same way that we can increase accuracy with integer types, we can do the same with floating point types. And in Java, there are both 32-bit floating point numbers as well as 64-bit floating point numbers. When you define a 32-bit floating point number, you use the type float. So if I wanted to define a floating point number, say called total, I would use the float type, give it the variable name, and set it equal to something. A float, being a 32-bit number, provides what's called single precision accuracy, whereas a 64-bit number gives us what's called double precision accuracy, or twice as much as we get from a float. To define a double precision number, we use the type double. Now, this is the last time that you're going to hear me refer to the float type. And that is because the Java documentation discourages you from using float unless you're very restricted with memory on your device. So when using floating point values, you should always use the double type. In fact, Java assumes that you're going to do so. Let me give you a quick example here. If I define a variable of type float, and set it equal to a value containing a decimal point, notice what happens when I try and execute it. It's assuming that this value is a double, and it says that we're getting an error because we're trying to put a double value into a float variable. And so all decimal values are assumed to be double right off the bat. Now, the same problem can happen if you try and assign this using an integer. So even if you are defining a double, if you put in an integer for the literal value, you'll get the same type of error. So to force this to look like a double, you just put the letter D at the end. So this says that this is 10.00000 and should be referred to as a double value. The double value will be good enough for most of the operations that you do in your applications. However, if you are working with complex currency operations like computing compounding interest, or scientific calculations where you might be modifying the same number thousands of times, there is another type called big decimal, and that is more suited for those types of calculations, and it will maintain better accuracy. For our application, the double type will be just fine, and that is what we will use for any kind of numbers involving decimals. In this video, we will learn how to define and use the Boolean data type. Booleans are the simplest of the primitive data types because they can only contain the value true or false. Booleans are sometimes used for lower level math operations, but for our application, we will use them for a few other purposes. The first being a simple to-state field. If you think of the different forms you have filled out on web pages, they've probably contained fields where you either answer yes or no, or you checked a box. Those are examples of to-state fields. The value that the field stores can only be one of two things, yes or no, true or false, checked or unchecked. You define a Boolean like you do with the other data types. You start with the type Boolean, follow it with the name of the variable you're creating. So keeping with our airline theme, maybe I'll create a variable called child in arms. Then you use the operator, which will be equals. And this is where things are a little bit different. You set a Boolean to either a value of true or false. Now you'll notice that Eclipse turns this value red. That means it's a reserved word. And that's different if I were to use an integer, for example, like the number 10, or a quoted string like Mike. So true and false are reserved words in Java. You'll also notice that it needs to be in lowercase. So I can only set this variable to one of two values, true or false. And of course, when I print it out, I'll get that same result. So I'll just quickly execute this from our Scrapbook page, and I'm getting the value back of false. Now you'll also notice that the values of yes and no will not work here. As you can see, it's not recognizing that as a Boolean value. So if on your web form you have an answer choice of yes or no, you'll need to convert that to a true or false value. Now the other use of a Boolean is to compare things. There are many uses in Java when you want to ask the question, is this value like something else? Depending on the result being true or false, your application may then take a certain action. So let me give you another example here. Let me create an integer variable called bag weight, set it equal to 32, and then I'll create a Boolean variable called bag fee. And if you're a frequent flyer, you're probably cringing at this point. And what I'm going to do is I'm going to set it equal to a comparison of my bag weight to a certain value. So for example, I'll say bag weight greater than 50. So I'm asking a question here. I'm saying, is my bag weight greater than 50? True or false? And that answer I want stored in this variable called bag fee. So let me just print that to my console. And let's go ahead and execute this whole block here and see what happens. it's not greater than 50, so the answer to this question is false. It's being stored in bag fee, and as we print that out, of course, we get that answer of false. So based on the answer to this question, I then could write additional Java code that does something, such as charging the customer a certain amount. Now we can do the opposite here. Maybe you bring a big old bag to the airport, and when we check that, you'll see that now this comes back as true. So our bag weight is greater than 50 in this case. We will use Booleans quite extensively when we start to test our application by asking whether the application did what it was supposed to do under a certain condition. If the result is false, we know that the test failed. So that is how to define a Boolean. They are very simple, but nevertheless important in many aspects of our application design. In this video, we will explore the data type for storing strings. It is critical that any programming language have robust support for manipulating text. Java certainly delivers in this regard with the string data type. When you want a variable that holds text, you use a string. Unlike integers, floating point numbers, and Booleans, strings are not considered primitive data types. Instead, string is a class. Now, that doesn't need to mean much right now. In fact, the only thing of consequence you need to understand is that when you define a string, you use a capital S instead of a lowercase, like we did with int, double, and Boolean. But the bottom line is that because it is a class, there are many things you can do to a string once it is defined. You define strings like other variables. You start out with the type, which is string, followed by the variable name. I'll create one here called firstName. Follow that with the equal sign, and then the text that you want the string to hold is always inside of double quotes. So I'll put the string Mike inside of this variable. Now, even if you put an integer inside of the quotes, this is still considered a string. And if you try to change the string to something else, you will get an error. So let me define this as a string, but put a value in as though it was an integer. And you can see when I execute this, it won't convert one to the other. So again, the value that goes inside of your string variable is inside of double quotes. Now you reference strings just like you do with any variable. You can reference them by name. So I can print this out and just reference the variable name. And just like it's done with every other example we've seen, it prints out the contents of the variable. We will work with strings quite a bit later on, but let me show you one of the more popular things we do with strings, and that is to combine them. We call that concatenation. So let's say that we have two strings, one called firstName and one called lastName. If you want to concatenate them, you just put a plus sign between them. So here when I print it out, I'll say that I want to print firstName plus lastName. Now notice that when we execute this, we get the result, but there isn't a space between the two variables firstName and lastName. In Java, providing spaces in strings is going to be up to you. Now, if the string is a label of some sort and you know it will always be followed by a space, you can just define that variable with a space in it. For example, let me come up here and define another string. I'll just call it label and set it equal to customer : and then I'll put a space at the end. So now if I were to print all three of these together, label plus firstName plus lastName, you can see that I get the space that I had put inside of the label string. However, when you're storing data in a database, that information typically does not contain the spaces that you want when you print it out. So in that case, you can just add the space as part of your concatenation. And that would work like this. We print out the label plus the firstName plus a space inside of double quotes plus our lastName. So now we've just embedded the space inside of our concatenation. And that's what you would want it to look like. A lot of the information we will store for our reservation project will involve strings, so we will revisit this topic again. In this video, let's take a look at dates. Dates are very popular in enterprise applications where you are managing any kind of business data. Like strings, you want to have very robust support for dates so that you can do things like calculate dates in the past and future, compare dates, etc. For civil and business use, most countries use what we call the Gregorian calendar. You're probably very comfortable with this system, but in computing systems, it has a fair amount of complexity. Different months have different number of days, new months begin on different days of the week, the same date falls on a different weekday from year to year, and of course there are leap years. Things like calculating what the date will be 90 days from today is not trivial. There is some history behind how Java has handled dates. Skipping all of that, one of the new features of Java 8 is a totally revamped set of libraries for dates and times. Now, like strings, Java dates are not primitive types. They use a class, several classes actually. The one we will use for our project is called local date. One of the hassles of handling dates in earlier versions of Java was that a date variable included the date, the time, and the time zone. So if you were only interested in the date portion of that variable, you had to apply formatting to strip everything else out. Local date is a date variable that does not include a time or time zone, so it is very easy to set and work with. To define a local date variable, you start with the type, variable name, and an equal sign as usual. Since local date is a class, the type begins with a capital letter. So it would look like local date. We give it a name. I'll call this invoice date equals. And this is where things get a little different. Local date is a class that contains a library of functions that perform different calculations on your dates. In object-oriented programming, we call those functions methods. You may want to think of local date as being a handheld calculator, and each method is a different button you can push on that calculator. So to define a date, you list the name of the class or calculator, in this case, local date, and then you follow that by a period and then the name of the method or the button you're pressing. Now, if you want the invoice date to be set to today's date, the name of that method is now. As we work with methods, we will see that methods begin with a lowercase letter and end with open and close parens. When we execute this, we are actually going to get an error. And the error is saying that Java has no idea what a local date is, so it cannot create a variable of that type. The reason it doesn't understand this is because although the Java Developers Kit ships with thousands of classes, it would take an enormous amount of memory to load all of them at runtime. You can imagine a smart light bulb requiring 4 gigabytes of RAM to operate. So by default, only some of the basic classes are loaded. As we make use of Java's additional classes, we need to tell Java where to find them. Now, classes are bundled into packages, just like we created a package for our application. The Java documentation will tell you what package each of its classes are in, but local date is part of a package called java.time. When we write actual classes for our application, we will use a command called import to point to the additional classes that we need. For the Scrapbook, however, there is an easy way to point to these packages. Let me just get rid of this error. And the way that you tell the Scrapbook to point to an additional package is simply right-click in the editor and come down to Set Imports. Then we just add a package and we start typing the name of it, which is java.time. And there it is there. So I've now added it as one of the imports to our Scrapbook page. Now when I execute this, it will work. So let's verify that by printing it out to the screen. And so now I'll execute this little bit of code. And there is our current date, which is in fact correct, March 26th. That is how you can set a variable to the current system date. Now, if there is a rare case where you actually want to enter the date as you create it, you can do that with a different method called of. Let's say I want to create invoice date and set it to a specific date, let's say March 20th. I would just put it in the format of the year first, followed by a comma, then the month, another comma, and then the day. These might be derived within your application, or they may in fact be hard-coded, which is pretty unusual. But this is how you can set it to a specific date. And as you can see now, I've set my invoice date to March 20th. The last thing I'll show is just how to do a simple calculation on dates. One of the most popular things to do in business applications is to add a certain number of dates to an existing date, to find a due date of an invoice, for example. So let me create another local date variable, and I'll call this due date. I'll set it equal to, but in this case, I'm not setting it equal to the generic local date, which is what I use for new dates. What I'm doing instead is I'm basing it on our existing variable called invoice date. Now we'll learn more about this when we talk about object-oriented programming in detail. But in the same way that local date has a whole bunch of buttons on it, or methods, anytime you create a variable of that type, that variable will also have all of these methods available to it as well. So instead of saying local date dot something, I can also say invoice date dot and any of the methods that are available to our date variables. And in this case, I'm going to use one called plus days. So this will take the current value of invoice date. It will add a certain number of days to that. Let's just add 30 days to it. And it will put the result of that in a new variable called due date. So let's print out the due date instead of the invoice date. And you can see now that the result is 30 days from March 20th, which is April 19th. So we have taken advantage of something in object-oriented programming called inheritance. And that basically means that all of the methods that are available to a specific type will also be available to the variables that you create based upon that type. That's exactly what we did here. We'll talk about this in much more depth when we get into object-oriented programming, but this should get us started in defining dates. At this point, we've learned about all the different data types that can store information in our application. What I'd like to do now is revisit the class diagram that we built earlier and decide what kind of variables we want in each class. So let me just rotate this diagram a little bit so we have a little bit more room. What we want to think about is for each of these different classes, what type of information is important to store. Let's start with passenger. We definitely want to store the name of the passenger, and that name will use a data type of string. Now we could store lots of other information about the passenger. Address, city, state, zip code, frequent flyer number, etc. And if we were building a production application, we would store those types of things. But I want to just store the absolute minimum so that we can understand the concept. So for a passenger, all we're going to store is their name. Let's move on to a flight. So for any flight that we're going to take, we'll need to know where the flight is leaving from, and that will be a variable called the departure city. That will be a string. We need to know where it's going to end up. That will be the arrival city, also a string. And then we'll give each flight a flight number, and that will be an int. Now we could also deal with the time of each flight and do some interesting calculations around that. But again, I want to just leave this as basic as possible. For the seats, I'm only going to store one piece of information, and that is the seat number. As I mentioned earlier, we only have one airplane with 6 seats. So I don't need to worry about how those seats are configured or anything like that. If this were a larger scale application, I may have a class coming off of flight called airplane, and then a class underneath that for seat. But since we only have one airplane, I'm just going to put it underneath the ticket. So the ticket is our final class, and on our ticket, we'll need to know what date we're flying. So we'll have a departure date variable, which will be of the type local date. And then the rest of our variables are really just defining the relationship between ticket and the other classes. So instead of storing a piece of information like a string or a date or an integer, we're going to store the name of another class. So we'll store the passenger, and that will be of type passenger, pointing to the passenger class. We'll store the flight, which will be of the type flight, pointing to the flight class. And finally, we'll store the seat, which is of the type seat class. This will become clearer later as we build these classes, but just know for now that these define the relationships from one class to another. Now let me close with a little vocabulary. We've been generically calling this information variables, and that's a valid term when you're speaking generically. When you put a variable into a class whose sole purpose is just to store data, like these four classes do, instead of calling these variables, we specifically call them fields. So I'll be referring to these as the fields in the class from now on. So now we've expanded our diagram to include not only the names of the classes and their relationships to each other, but also the fields that are contained in them. We'll continue to expand this diagram as we go. In this video, we will create the first class for our airline reservation system. Remember that classes represent the nouns in our application, such as passenger, flight, seat, and ticket. We'll begin by putting our class in a package, and we created this package earlier. You create a new class just by right-clicking on the package, choosing New, and then Class. You can leave all these defaults as they are. All we need to do is provide a name for our class, and this class will be the passenger class. So we click Finish, and Eclipse takes care of the rest. The first line of our class is the package. When we built a class using our terminal, we didn't state this. But now Java knows that this class is part of a group of other classes that are in this same package. By pointing to the package when we created the class, Java put this line in for us. So we are already saving time by using Eclipse. You can also see that this line ends in a semicolon. Our easy rule was that if the line is not a comment, or if it does not end with a brace, then it needs to end with a semicolon. The next line is the class declaration. The word public is what is called an access modifier. Public means that the class can be accessed from any other class in your application. The other option is to not have an access modifier. In that case, a class needs to be in the same package as the class that's trying to access it. We are going to keep all of our classes public. Now you can only have one public class per source file, and that class must have the same case-sensitive name as the file. So as you can see, our source file is called passenger.java with a capital P, and so our public class must also be called passenger. Notice if I make this a lowercase p, that Eclipse gives us an error because it thinks that passenger with a lowercase p is a different class altogether than the name of our source file, which is passenger with an uppercase P. Finally, everything that you define as part of this class is contained within these two braces. This is known as a code block. So by pointing to our package and giving our source file a name, Eclipse saved us all of this typing. In this video, we will discuss how to put fields and comments into our class. Now that we have our class declared, the next step is to add the variables to it that will store information about that class. Remember that classes represent the nouns in our application, and this class depicts passengers. Each passenger will have certain characteristics. And in our class diagram, we decided that we will only store one characteristic about a passenger, and that is their name in the form of a string. Under the class, we will list the variables that the class stores. So let's enter string space name semicolon. Again, the variable begins with a lowercase letter. Up until now, we have been generically calling these variables. By declaring them in this way under the class, they are specifically called fields or instance variables. We will refer to them as fields. Just like classes, variables can have access modifiers. We know about public and the empty modifier, but fields can also be assigned the private modifier. This means you can only access the variable from inside of the class. All of our fields will be marked as private, which we will talk about a little bit later. We are also not setting them to an initial value when we declare them. That is because we probably don't know what it will be until we are ready to use it. Now, before we get much further, let's talk about comments. Comments remind you of what the different parts of your code are doing. For example, this section of your code is for the fields, so let's give that section a comment. You begin comments with 2 slashes, so maybe we'll just create a comment that says fields. Now remember that comments and lines that end with a curly brace don't end with a semicolon. You can also put comments as part of a statement. We call this an inline comment. Just remember that everything after the 2 forward slashes is considered part of the comment. Also, whatever is in front of the inline comment needs to obey the rules for semicolons. Finally, you can create multi-line comments without having to put the 2 forward slashes in front of every line. You do that by beginning your block with a /*. And this would be the first line of your comments. Now, when you're working on a team, it's common to put a block of comments at the beginning of all of your classes that describe the name of the file, who wrote it, and what it does. So maybe our first line will just be the name of the file. Then when I press enter, notice that it ends my block with an */, and everything in between these 2 lines will be considered comments. Now Eclipse also put a space and then another asterisk on this line. This is not required to make this line a comment, but you'll notice that it nicely aligns the next line with the first line. So I can just put in more text, and as I press enter, Eclipse will continue to align our comments for us. So let me just paste in a quick description of this class. So this creates a nice comment block for us. Now we have our field declared, and we have a couple of nice comments to tell us what our code is doing. I'll click Save, and we're ready to move on. In this video, we will add a class constructor to the class that we're writing. As a quick review, we have our passenger class that contains a block of comments at the top, followed by the package that the class belongs to, then the class declaration, and finally our field. We have seen how Eclipse has made us more productive by doing a lot of the typing for us. Also notice how Eclipse adds color to your code. We call that syntax coloring. Comments are in green, and notice how you can collapse blocks of code. This makes your code easier to read. You can hover over the collapse symbol and temporarily see the block. Variable names will be in blue, and reserved words will be in red. Reserved words are specific to the Java language, so you can't name a variable or a method name with a reserved word. Notice, for example, if I change this variable from name to class, which is a reserved word, now I get an error. So this shows us that Eclipse also performs syntax checking as you type, so that you can see mistakes without having to compile your class. The error symbol will be on the left, and the portion of your code that has the error will be underlined. If you hover over the symbol, you'll see the error message. So as you can see, there's a syntax error that says I can't use the word class as a variable name. Let me just change that back to name. So now there's just a warning on this line, which we will correct a little bit later. Now there are a lot of other things that Eclipse will do to make us more productive, but let's get to our main topic, which is to create a constructor. So we have a class called Passenger, but a class is not an actual passenger. It merely describes the characteristics of a passenger. Think of the passenger class as a template for passengers. When you create an actual passenger in your application, you ask the class to create what is called an object. This is where object-oriented programming gets its name. So the passenger class is the template for creating passenger objects. Part of our template is this field called name. That means that every passenger object that you create will also have a name field, and you can assign that name a different value for every passenger object. Now, when you create a new passenger, Java needs to know how you are going to assign values to these fields, and that is done through what we call a constructor. So let's begin to create our constructor, and I'll start off with a comment just to let us know that this is where the constructor is. Constructors have access modifiers, and you want to always make them public because you want any other class to be able to create a passenger object. Now, the constructor has the same name and case as your class, so ours will be passenger. Following the name of the constructor, you enter two parens. The parens are used when you are going to provide information about the object at the time you create it. Empty parens say the constructor should not expect any additional information about the passenger except that you want a new one. The purpose of the constructor is to set all of the variables either to a default value or to what you provide when you create the object. For this example, we are not receiving any information about the object, so the constructor will do the work instead. Everything that the constructor does is inside of a set of curly braces, just like our class. We have one variable called name, so the constructor's job will be to set the name to something. Since we aren't providing a name when we create a new passenger, the constructor will just set it to something generic and assume we will change it to something meaningful later. Let's have the constructor set name equal to, and in quotes, unknown name. And of course, we'll end our line with a semicolon. Now we can create passenger objects, and when we do, their name will be set to the default of unknown name. That may not sound very useful, but it is predictable. So if you create passengers in your application and never get around to setting their names, you will be able to find them easily because they will all have the name unknown name. In this video, we will create the getter and setter methods for our passenger class. When you break down a class, you basically have two parts, fields and methods. When you create an object from that class, the fields describe what that object is, known as the state of the object, and the methods describe what that object does, also called the behaviors of the object. The methods are the verbs that an object can perform. For example, let's say you have an object called projectile. The projectile's fields describe what the projectile is, such as its weight, speed, position on the screen, etc. The methods allow that projectile to do things, so you may have methods called accelerate, turn, or explode. The most common methods that you find in classes are those used to change a variable's value or return its current value. We call those methods getters and setters. Let's create the getter and setter methods for our passenger class. We've already created a method once before, and that is the constructor. I wanted to keep it separate because of its special purpose in the class, but it has the same format as we will use for our getters and setters. Let's create the getter first. We'll start by commenting this section of our code. Now the getter will return the value of the name field. It starts out with an access modifier, and as a general rule for this course, all of our methods will be public. You then specify what type of value the method will return. In our case, the name variable is a string, and that is what the method will return. We then specify the name of the method. Methods use the same naming standard as variables, starting with a lowercase. As a best practice, the getter method should be named get, followed by the variable name. So for us, that will be getName. Follow the name with parens, and we aren't sending anything to the method, so the parens will be empty. Finally, the instructions that the method will perform will be in a code block that we enclose with curly braces. This method does one simple thing. It returns the value of the name variable. We do that with the command return, followed by the variable that we are returning, and that is name. So getName is the method we will call when we want to know the value of the name variable. If we want to change the value of name, we will call the setter method. So let's create that method now. It will also be public, but it will not return anything. So the return type is void, meaning nothing. Notice that our constructor doesn't return anything either, but it does not have a void return type. Void is assumed with constructors, and leaving the return type out makes it easier to distinguish from other methods in the class. The best practice for naming a setter is to call it set followed by the variable name. So just like our getter method is called getName, our setter method will be called setName. Then follow it with parens. Now when we call setName, we are going to include the value that we want to set it to in the calling statement. So we need to tell setName to expect to receive that value. We do that by specifying what type of value it is going to receive. That will be a string. And we need to provide a variable name for that value. Let's call ours new name. Then we put our constructions between curly braces. Now the instructions are simple. All we need to do is set the object's name variable to what we just received. And we do that by saying name equals new name. So the setter method receives a string that we call new name, and we are setting that value to our field called name. Notice also that we used to have a warning here, and that has now gone away. The warning was saying that the name variable was never used. That is because it is defined as private, so it could only be accessed from within the passenger class, like we do with the constructor. But if another class created a passenger, you would never be able to see the value of name, thus the warning. The getName method allows us to return the value of name to any class that asks for it. So now we have a complete passenger class. This will let any other class in our application create a new passenger object, change the name of the passenger by calling the setName method, and refer to the current passenger name by calling getName. In this video, we are going to use our new passenger class by accessing it from the Scrapbook. We've been tiptoeing around some object-oriented programming principles like classes and objects, but we need to confront this head-on from here on out. Java is an object-oriented programming language, meaning that everything you create in Java is an object which comes from a class, with a few exceptions like the primitive types such as integers and booleans. Now that we have built a class called Passenger, let's see how to create and use passenger objects. Let's open up our Scrapbook page. Creating an object is a lot like declaring a variable. You first say what type of object you are creating. With variables, we created things like ints and booleans. With objects, the type is the name of the class that it comes from. Since we want a new passenger, we use passenger as the type. Notice it's an uppercase name. The object type needs to match the class name. Then we give our object a name. Let's use passenger1. Object names use the same naming standards as variables, which start with a lowercase letter. Then we'll set it equal to, and we will tell Java we want a new passenger object. So we say new passenger, and we follow it with parens and a semicolon. We are creating a new object called passenger1. It will have the type of the passenger class, and we'll create it by asking for a new passenger. Now we are not going to give the passenger class any information to help it in creating that new passenger. If we were, we would put that information inside the parens. Now, executing this statement inside of the scrapbook is initially going to cause an error. And I want to show you what this error looks like because you may see it again in the future. So I'll highlight the line and I'll execute it. And the error is passenger cannot be resolved to a type. Essentially what that means is Java just doesn't know what a passenger is. And really specifically, it's just that it doesn't know where to find this passenger class. That's because our scrapbook page is outside of the package that contains passenger. So with the scrapbook, we'll just tell it about this package. And we do that by right-clicking, coming down to Set Imports, and we're going to add a package. I'll just start typing it in, org.airline, and then I'll just double-click on it here. So now our scrapbook knows that it can look inside of here and find that class. This was similar to what we did when we were dealing with dates. So let me clear these errors out and try and execute this again. And now it doesn't cause any errors. Now it's not giving us any useful output because we haven't told it what to do with this new object. But it has in fact created a new object called passenger1. Let's loop back to a concept we looked at earlier called the access modifier. When we set up the passenger class, we set the access modifier to public, meaning that any class, no matter where it is in your application, can create an object from the passenger class, which is what we just did with the scrapbook. Now, if this wasn't set to public and we just left it blank, which is the other option, then the only classes that could create new passengers would have to be inside of this package. You'll notice that our scrapbook page is not inside the package. So if I save this and I go back to my scrapbook page and try and re-execute this again, you'll notice it says that the type passenger is not visible. So that means that Java knows about it, but we don't really have access to the class because we're outside of its package. So that's how access modifiers keep other classes from creating objects. Let's go back and set it back to public, which it should be. Now that we have a passenger object, we'll be able to access its fields and methods. And we'll pick that up in the next video. In this video, we'll take the passenger object that we created previously and access its fields and methods. Now, as a result of creating an object based on the passenger class, the passenger1 object has the same fields and methods available to it as the class. Passenger1 has a name, and you can call both the getName and the setName methods from our passenger1 object. You do that basically by referring to the object name, followed by a period, and then either the field or the method name that you're calling. So for example, the name variable. Passenger1.name refers to its name variable, and passenger1.setName and passenger1.getName will be used when we want to call its methods. Let's try to print out the name variable for our new object. Theoretically, when we created this new object, the constructor should have set its name to the string unknown name. So let's just do a quick print line to see if that's the case. Type system out.println, and we'll put the name of the variable inside the parens. Let me clear these errors out again. And let's see what happens when we try and print out this variable name. Again, we get an error that says the field passenger.name is not visible. Now, why did that happen? Well, if we go back and we look at the field definition, its access modifier is set to private. That means you can only refer to the variable by name if you're inside of the object itself. Our Scrapbook page is not. We've created the object in our own class, and now we're trying to refer to that variable name, which is private. Again, the access modifier is keeping us from doing that. And that's exactly why we created the getter and setter methods, so that we can get the names and set them to other values. So let's try that. So instead of referring to the passenger1 name directly, we'll just call passenger1.getName and empty parens. So this will tell it to execute that method. Clear this out and re-execute it. And there we go. So now we're getting the value of name, which was set by the constructor when we created the object. Well, if getName works, that means setName should also work. So let's set the name variable to a different value. We'll do that by saying passenger1.setName. And you recall that when you execute setName, you need to send it a string inside the parens. And that string is what you're setting the variable to. So let's put our parens in there, and let's set this to a string. I'll just set it to my name. And so now when we print it, it should print out what we set it to. Let's clear this and execute it. And there is our new name. So that seems like a lot of work. Why would we set our variables all to private and require our classes to access them through getters and setters? Well, the reason is when you set the name, you may want to put some constraints behind it so that end users can't set the name to something that's inappropriate, like a number or a date. So by requiring them to execute a method, inside of this method, not only can you set the variable, but you can perform logic behind it, like checking the input that they're sending. Even if you aren't going to do that, it's best to set it up this way, because then in the future, if you do decide to put constraints in here, all of your code is already setting the name in that way, so you won't have to go back and change it. So for all of our classes, we'll set the fields to private, and we'll create getter and setter methods for each of those fields. Now we know how to create new objects and access their fields through its getter and setter methods. In this video, we will learn how to create an automated test for our passenger class. We've used the Eclipse Scrapbook to create a passenger object and execute its methods, but doing that every time we want to ensure that our classes are working is a tedious and manual process. An automated test that creates an object from a class and runs every method in that class is called a unit test. You should consider it your responsibility as a Java developer to create a unit test for every class you write. The good news is that Eclipse makes this easy by supporting a testing framework called JUnit. By creating unit tests on all of your classes, you will be able to test your entire application with a click of a button. This allows you to release high-quality software. An even bigger benefit will come later when you make changes to that software. Now, with a click of a button, you will be able to see if that change has broken anything that was previously working correctly. We call this regression testing. Let's create a unit test for our passenger class. Each unit test we create will be contained in its own file. Typically, when you deploy an application into production, you don't want to include the unit test files. So we need a way to keep them separate from the actual classes we write for our application. One way of doing this is to create a source folder for our tests. Notice we have a source folder called src that contains our package and classes. If we create another source folder for our tests, we will eventually be able to build our application without including that test folder. To create a new source folder, right-click or control-click on the Mac on the reservations folder and choose New Source Folder. Give it the name Test and click Finish. Now we have two folders, one for our classes and another for our tests. We want our tests to execute inside of the same package as our classes. That way, if a method does not have a public access modifier, the test can still execute that method. Even though our tests are in a different source folder, they can be part of the same package. You do that by putting a new package inside of the test folder with the same name as your source folder's package. So again, remember that our package inside of src is called org.airline.reservations. Let's just create the same package inside of test. So I'll right-click, choose New, and Package, and I'll give it the same name, org.airline.reservations, and then click Finish. Now we are ready to create our test class file. It will go inside of this package, so we'll right-click, click New, and now we have to dig a little deeper. So we'll go to Other, and then inside of the Java folder, under JUnit, you'll find the JUnit test case. So let's select that and choose Next. Now we want to use the latest framework, which is JUnit 4. So I'll start by choosing that. If you right-clicked on your package, your source folder and package should be correct here. So now we'll give our test a name. The naming standard will start with an uppercase, just like a class. The name will be the class, followed by the word test. Since we're testing our passenger class, we'll call this passenger test. We'll leave everything here as it is, and then down here towards the bottom, it says class under test. In other words, which class are you testing? If you type in a class here, the test will look at that class and ask you which parts of the class you want to test. This will be a huge time saver, so let's enter passenger. Now down at the bottom, JUnit is warning us that JUnit 4 requires some configuration. We can do that now, but let's ignore the warning and I'll show you a really nice feature of Eclipse that will fix this. So we'll click Next. And since we said that this is going to test the passenger class, it tells us everything about it. So we can see the constructor and all of the methods. Now, just like objects come from classes, classes all come from a master Java class called object. For everything that you check, Eclipse will set up the structure of a test. Now, testing object is like testing the actual Java language, so we won't do that. But let's test everything that is part of our passenger class. You can click these individually or just check passenger. Finally, I'll click Finish. I'll ignore this warning for now and click OK. And here is our test file. It's set up similar to a class. It's in a package, as you can see. It has a class declaration, and it has methods. There's a similar method for each item that we are going to test. So the three things that we checked earlier are represented here: the constructor, the getName method, and the setName method. You'll also notice these import statements. We are going to be calling methods that are part of the JUnit framework classes. JUnit is not part of the core Java libraries, so we need to tell our test where to find these classes. We do that through the import command. This is just like what we did in the Scrapbook when we managed our imports, but here we are doing it as part of the class. Now you can see that the test has some issues. These are a result of that warning that we ignored earlier. I didn't fix it then because I want to show you a great feature of Eclipse called Quick Fix. Whenever you have an error, Eclipse will try to suggest how to fix it. By hovering over this first one, we can see that there are two quick fix suggestions. Eclipse is suggesting that we upgrade to a later compliance level. This is a set of rules that the Java virtual machine obeys, and JUnit 4 needs to be at level 1.5. If we do it for the workspace, it will work for all projects in the future, not just this one. So I'll choose that. We can ignore this error for now, so just click OK. And that got rid of part of the problem, so let's hover over it again, and we'll choose Fix Project Setup. We'll just add JUnit 4 libraries to the build path and click OK. Since JUnit is a third-party framework, it is not part of the core Java libraries. So adding it to the build path allowed Java to know where to find it. And that fixed all of our other errors as well. These were pretty specific errors, and it wasn't obvious which suggestion to choose. But when we have problems in our own code, this will make it easy to implement the fix. So our test file is set up. Next, we will write the actual instructions for each test method. In this video, we will write the test methods for our passenger test JUnit test class. When we created our test class, we did it in a way so that Eclipse did a lot of work for us. In fact, we did not type anything in this class. The class contains 3 tests, each one in a separate method. At the beginning of each test, you have this test annotation. An annotation makes the method run in a special way without having to include those instructions in the actual method. In this case, test tells the method to run as a JUnit test and to post its results in a separate window. We will see how this works in a minute. The instructions that the test performs are contained in the method. When we created this test class, we specified what we wanted to test, but Eclipse has no idea how to test those things. So it puts a placeholder instruction that forces the test to fail, and will give the reason for the failure as not yet implemented, meaning we haven't yet written a meaningful set of instructions that the test will execute. Let's see how to run this test in its current form. To run a JUnit test, just right-click on the test file, choose Run As, and specify JUnit test. The test runs, and the results come back in this JUnit tab. You can see how quickly it ran, which can be useful if you are doing performance testing. Then it shows that it ran 3 out of 3 tests, it had 0 errors, and 3 failures. This is an important distinction. The errors tell you whether the test itself had any compiler or runtime errors. So this means that the code in the test executed completely without any problems. The failures are the results of what was being tested. This shows that all 3 of our tests returned with a failing result. If you look below, it shows this visually, with each test being listed separately. So if only some of the tests failed, you would be able to tell which ones have a problem. The reason they failed is because they were literally instructed to do so. As I mentioned, Eclipse has no idea what to test here, so it just wrote an instruction to force them to fail. So let's actually test our class. We will start with the constructor. We test the constructor by using it to create an object, just like we did in our scrapbook. So instead of telling the test to fail, let's tell the test to create a passenger object. And we do that just like before by saying the type, giving the type a name, and I'll call it testPassenger1, setting it equal to a new passenger. Now, how do we know if this is successful when it runs? Well, if we look back at our class, when the constructor builds a new object, it sets the variable called name to unknown name. So if we can test whether the name is equal to unknown name, we will know if the constructor worked. Let's create a variable in our test called result. It will be of the type string, called result, and we will set it equal to the value of our object's name variable, which we can only see if we call its getName method. So let's set this equal to testPassenger1.getName. Now we will compare that result with what we are expecting it to be. This result will also determine whether the test passes or fails. We have a special JUnit method to do that called assertEquals. AssertEquals compares 2 values to each other, and if they are equal, the test passes, otherwise it fails. We pass 2 arguments into the method. First, what the passing answer should be, in this case, unknown name, and then what we are testing it against, which is the value of the result variable that we just created. Now, this is somewhat longhand, but I wanted to make it clear to read. In our next test, I'll shorten it up a bit. Let's run the test again. I'll rerun it by using the Rerun Test button here. And now you can see that this particular test now passes. So with our first test working, we're ready to work on the remaining tests, and we'll pick that up in the next video. In this video, we will write the remaining unit tests for the getter and setter methods of our passenger class. This next one will test the getName method. We already tested this in our first test, and we will use it again to test whether setName works. It is redundant to create a special test just for that method, so let's go ahead and delete it. Our last test is for setName. Every test you run should stand on its own, so we don't want to have to rely on the object we created earlier, because if that test fails, it may impact this test. So we will create a new passenger object called testPassenger2. Now let me show you another nice feature of Eclipse. And this is called Code Assist. What it does is recognizes what you're typing and then types out the rest of it for you. For example, if you're creating a new object, this syntax is so common that Eclipse recognizes it. And it creates a shortcut simply by just typing in the word new and then pressing Control spacebar to bring you into Code Assist. Now there are lots of new things that you could be doing, so you have to tell it what you're actually creating. For us, we're creating a new object. So I'll highlight that and press Enter. And now we are in what's called a Code Assist template. Notice the boxes around each part of the command. And the first box is highlighted in blue, so it's asking us the type of the object that we're creating. In this case, it's a passenger. Now there's a box right next to that around name, and I get to that by pressing Tab on my keyboard. So now it highlights it, and now it wants the name of our object. And we'll call it testPassenger2. Now it knew from the type that we would create a new passenger object. So now it just wants the arguments. And we aren't passing anything into our object, so I'll just press Delete and get rid of that. Now the green line at the end is where my cursor will go if I press Tab again. So that's just an easy way to get out of the statement so that I can press Enter. Code Assist will save us lots of time as we start typing in common pieces of code. Now we are trying to test the setName method, so we need to execute it. setName sets the name variable of our passenger object. So let's execute it for the object that we just created. And we do that by saying testPassenger2.setName, and we'll set it to the string, and I'm just going to use my name, tab out, put in my semicolon. Now, the only way to see if it works is to do a getName. So this time, let me combine the assert equals command with the result variable that I need to create based on the getName method. And it will look like this. Assert equals, and our two parameters are the literal string that I want to compare it to. And this is the shorthand that I referred to earlier. So I'm going to create this string and call getName all in one step. And I'll do that by saying testPassenger2.getName. So let's save and run our test one more time. And this nice big green bar is the good news that you're always looking for in testing. So as you can see, both of our tests passed. So we're running 2 out of 2 tests. We have 0 errors and 0 failures. So congratulations. We now have a fully unit-tested class, and the test is 100% successful. In this video, I will introduce the concept of test-driven development. Test-driven development originated as part of the Agile software development methodologies. Agile methodologies are useful when the scope of your project is not fully known or is at risk of changing before the project is finished. Instead of writing the entire application at once and delivering it, you break it into short development cycles with a limited number of features and add features with each cycle. There are several methodologies that are considered Agile. Extreme programming and Scrum are 2 of the more documented and practiced methods. You can find lots of information on Agile, Extreme Programming, and Scrum online. One of the core best practices of Agile is how you perform testing. Test-driven development was originally known as test-first design and was a core tenet of Agile, but is now more of a methodology on its own under the name test-driven development, or TDD. Let's take a look at how it works. In traditional software development, you receive a requirement, write the code, and then test it, if there's still time. With test-driven development, the first thing that you do after getting a requirement is to write the test. For example, if the requirement says you need to be able to enter new flights into your reservation system, then you can write a test that creates a new flight object based on the flight class. Then you can write tests that test all of the methods that will eventually be in that class. Now, you may be saying to yourself, why test something that doesn't exist? The tests will just fail. And that's exactly what you want to do. Running the test and ensuring it fails before you code anything tells you three things. Number one, the functionality that you are testing does not already exist somewhere else. Number two, you haven't written a test that always passes. And three, the test you write serves as the technical specification document for your class. In other words, it lists the names of all the classes, variables, and methods that you now need to develop. Your next step is to then write the code. As you write, you will rerun the test. As soon as the test passes, you know that you have written the minimal code to meet that original requirement. The final step is then to go through your code and clean it up so it meets standards, has comments, etc. A lot of people new to programming find this a little backwards, but once you see how Eclipse supports test-driven design, you will see how much faster this is than traditional software design. In this video, we will write our flight class using test-driven development. Looking back at our project class diagram, we can see that the flight class needs to store the flight number as an integer, as well as the departure and arrival cities, which are strings. So we will need those fields. We will need a constructor method so that we can build flight objects, and we will need methods that other objects will use to set and get the flight fields. Just a quick note about dates. To make things simple, we are putting the date of a flight on the ticket instead of storing it in the flight. Our one airplane operation makes the same flights each day. We will only need to create one flight object for every departure and arrival city combination and let the ticket combine everything together. So let's get to work. With test-driven development, we will create our test class first. So let's right-click on our package, which is under the test folder, and choose New, Other, and we want a JUnit test case. It should now default to a JUnit 4 test, and just double-check the source folder and package to ensure they are correct, and we'll give it the name Flight Test. Now we won't type in the class under test because the flight class does not exist yet. So now just click Finish. Everything is set up and it created the beginnings of our first test. We call that stubbing in a method. Notice also that all of the errors that we got when we created our last test are gone here. Since we set up the configuration and build path on our passenger test class, those will be set correctly on all tests from here on out. Now, looking back at our passenger test, the first thing that we tested was the constructor. So let's create a test for our flight constructor. We'll do that by creating a flight object. And again, using Code Assist, we can just type new control space and create new object. It'll be of type flight. The name will be test flight 1. It's of type flight here as well. And in the arguments, I want to pass in a value of 100. We won't actually use this, but it will save us some typing a little bit later on. So I'll tab to the end and press Enter. When we test the constructor, we want it to default values for each field, and we want to test each of those defaults. So here in the test, we will decide what those values will be and test whether that happens. Departure city is our first field. So let's write an assert equals test. Why don't we make the default city unknown departure city? and test that against our test flight 1's value of departure city. Now we already know that fields will be private and that we will need to use a getter to return values of our fields. But bear with me, and when we create the actual flight class, you will see why I'm doing this. So let's do the same thing for arrival city. And again for our flight number. Now flight number is an integer, so you don't put the test value in quotes. Let's set the default to 100, and we'll test it against test flight1.flightNumber. Now you could test each of these individually by creating 3 separate tests, but that is probably overkill. Besides, our test is about the constructor, so we should test the whole constructor in one test. The next step is to run the test and ensure it fails. So I'll save it, right-click, and choose Run as JUnit Test. Now it says that there are errors in reservations, which there are obviously because we're trying to create objects from classes that don't exist yet. But that's okay. Eclipse will allow us to run this test in spite of the fact that there are errors. So I'll go ahead and proceed. And of course our test fails, which is what we want it to do. So we've completed step 2, which was to create a failing test. Our next step will be to write code until it passes. We have our flight test class, so now we need to create the flight class to which the test refers. And as a popular movie villain would say, this is where the fun begins. The first line of our test tries to create an object from a class that does not exist. Eclipse knows this and marks it as an error. Well, instead of creating a new class source file, just hover over the error and take a look at our quick fix options. Just choose Create Flight Class. Everything looks good here, except that the source folder is where the test file is, and our classes need to go underneath src. So let's just change that and click Finish. And voila, our flight test class. Our class needs a constructor, but don't write it. Instead, go back to our test and look at the second error. If we look at Quick Fix, we can create a constructor for our new class. It shows up with a code assist template. The access modifier is correctly set to public, and the name matches the class name as it should. Because we passed an int in our test, it created a constructor that receives an int as a parameter. For now, we just want a simple constructor without any parameters. So I'll delete this. So why did I go to the trouble of setting it up this way in the first place? Well, all classes have a default constructor that looks just like this. If I didn't pass anything in my test, there would not have been a quick fix suggestion to create a constructor, because Eclipse would just assume that we could use the default. So then why create a constructor that is the same as the default? Well, for one, it makes our code more readable. The other reason is so we can default the values of our fields. Now again, Java can also default all of your fields whenever you create a new object. But by writing our own, you don't have to remember things like, does Java default strings to null or empty string? This way, you are in control and you have better documentation. So let's save this and also remove the argument from our test. We will learn more about passing data between methods later. Okay, now let's think about our fields. Our constructor needs to set all of our fields to default values. But before we can do that, we need to declare our fields in the flight class. Well, our test already specifies what those should be. So instead of coding those, we can come here to our test and, you guessed it, hover over the error and let Quick Fix do it. As your class gets built up, the test will reveal new errors that Eclipse knows it can fix. There's our field with a code assist template. We want our fields to be private, and our field departure city is going to be a string. Now back to our test, and let's create the other two. So one for arrival city, again, private string. And finally, flight number, which will be an int. So I'll save this, and in our next video, we'll see how Quick Fix can create the getter and setter methods for our flight class. In this video, we will continue building our flight class using test-driven development. And as we look back at our tests, we wrote them in such a way that we could access our fields publicly. We did this so that Quick Fix would give us the option of creating the fields. But now that they are private in our class, we will need to access them through getters instead. As you can see when we hover over the warning, it says that they are no longer visible. But look what happens when we hover over the field name. We can build the getters and setters for the field. So just click OK. And notice what happens to the field. It now uses a getter call. And when we look at our class, we have two new getter and setter methods. Now they are both set to public access as we want. The getter method looks just like the one we created for passenger. It will return a string, which is the value inside of the departure city field. The setter method is interesting though. It starts out normally by being public and not returning anything, i.e. void. When we built our passenger class, I came up with a unique name for the parameter versus the field that it is setting. Here, as you can see, Eclipse is using the same name for the parameter and then uses this interesting syntax to set it, which is this.departureCity equal to departure city. So what does this mean? This stands for this object. So this.departureCity means the value of departure city that belongs to the flight object that you just created. When you define a variable outside of any methods, as I said earlier, it is called a field or instance variable. Any method inside of that class can refer to that variable by name. Whereas if you define a variable inside of a method, it is called a local variable, and it can only be accessed from inside of that method. This is what we call variable scope. So the parameter departure city is a local variable and is different from the departure city that is in our field, even though it has the same name. If I double-click on departure city, the field, you can see everywhere that it is used within our class. Notice the parameter is not highlighted. If I double-click on the parameter, it matches up with the right side of my setter command. Now, some people think that the this syntax is more readable than using two different variable names. That's your choice, but number one, it can be hard to come up with a meaningful alternate parameter name for all of your variables. Number two, Java has the ability to create its own documentation on your methods based on things like parameter and variable names. So that documentation will be clearer if it uses the same parameter name as your variable. So back to our test. We have two more sets of setters and getters that we need. Now, one way to create those is with Quick Fix like we just did, but let me show you another way as well. Instead of looking at your test, if we go back to our actual class, we can come up to the source menu and choose Generate Getters and Setters. This way you can generate them all at once by just checking them here. Now there is one caveat to doing it this way, and that is if you do, you'll have to go back to your test class and change all of your variable names to the getter method. Now to make this completely test-driven, I'll just use Quick Fix on each of these variables. That looks great. Remember, we are using our test to tell us if we are done coding or not. So let's run the test to find out. Now it comes back with no errors, but the test actually failed. If I look at the trace, it says that it was expecting the departure city to come back as unknown departure city, but instead it came back as null. If we go back to the constructor of our flight class, we can see that we never actually finished it. So we'll write the constructor and finish the rest of our tests in the next video. In this video, we'll write the flight constructor to match its unit test as well as write the remaining unit tests for the class. Looking at our test, we can see that both of the cities need to be set to unknown city, and our flight number needs to be set to 100. Now, unfortunately, Quick Fix has no way of knowing that this needs to happen inside of the constructor, so we'll just need to write the code to do it. The constructor currently has this comment that Eclipse created that begins with the word to do. Although the Java compiler will ignore this comment, the word to do is recognized by Eclipse as a task. These are useful when you aren't ready to write a certain block of code, but you don't want to forget about it. Let me close the class and show you how it works. If I now go to the window menu and say Show View Tasks, I will get a window that shows me everywhere that I have a to-do comment in all of my projects. Now let me just move this to the bottom of my screen. Here's the one for my flight class. All I need to do is double-click on it, and it will open the class and highlight the comment. Now let's finish the constructor. So we'll want to set departure city equal to unknown departure city. And then the same thing for arrival city, so I'll just copy and paste to make it a little faster here. And then finally for our flight number, set that equal to 100. So our class looks done. Now let's run the test to see if it passes. It does. We've used test-driven design to create almost all of our class. Now we haven't actually tested the setter methods yet. I probably would have written those tests before I let Quick Fix build my class, but I didn't want to get lost in all of those details. So we'll set those up in the next video. In this video, we will finish writing our tests for the flight class. We created a successful method to test the flight constructor. Let's give that class a meaningful name called TestFlight. Now we need to create the remaining methods for the setter and getter methods of our class. All of our tests begin with the test annotation. But if you remember to put that in at the end, Code Assist will help us with everything else. So let me show you how powerful Code Assist can be once you get the hang of it. I'm going to create a new method right here, and it will start with the public access modifier. So I'll type pub, then Control space for Code Assist, and I'll choose a public method. The return type will be void, and the name of the test that I'll create will be called test set departure city. I'll tab down to the next line, and the first thing it will do is create a new flight object. So again, Code Assist with the word new, Control space, create a new object. It'll be of type flight. I'll give it the name TestFlight2. It'll be a new flight with no arguments. Now I'm going to test the setDepartureCity method, so I'll start by saying TestFlight2 dot, and you'll notice Code Assist comes up with all the methods available to me. I'll just put in an S to reduce that once more, and I'm going to test setDepartureCity. We pass in the string that we will be setting the departure city to, so let's set it to Los Angeles. Tab to the green bar, enter, and now we run our assert equals. Our test string is Los Angeles. Tab to the green bar, comma, and we'll test that against the get method, so test flight2 dot, let Code Assist come down to get departure city, tab to the end, and a semicolon. And there's our test. So you can see how productive Code Assist allows you to be. I only typed about 50% of that test. We've tested the setDepartureCity method, and as a result, we've also tested the getDepartureCity method. So we need to repeat this for arrival city and flight number. Code Assist may be just as fast as copying and pasting, but let me go ahead and just paste in the new test and then just make the changes. So this will be for arrival city. I'll copy that so that I can use it again. I'll create a flight test 3 object. I'll set the arrival city to Chicago, and then I'll assert equals that Chicago is equal to testFlight3 dot get arrival city. There's our second test. Now we just need one more for flight number. This one's probably different enough that I should just use code assist for it. Public method, return type void. The name is test set flight number. We'll create a new object of type flight, test flight 4 with no arguments. Then we'll run our set method. So test flight 4 dot set flight number, and it's an integer, and I'll set it to 1000. And finally assert equals 1000 to test flight 4 dot get flight number, and there's our test. Okay, so as I mentioned, all of our tests need to start with this test annotation. For some reason, if I had put that in first, the public code assist doesn't work right. So that's why I left it until now, and I'll just paste it in to each of our tests. Well, let's see how our test works. Go ahead and save it, and then run it. I'll just rerun it right from here. Get a nice, beautiful green bar. We're running 4 tests, and we can see that all 4 of them ran without any failures. Well, great. Now we're ready for the last step in test-driven development, which is to clean up our code. If I go back and look at our actual flight class, a lot of times when you use quick fix, it will place the results where you don't want them. For example, sometimes I get the fields below the constructor instead of above it. So the first thing that you'll want to do is just read through your class and make sure that everything is where it needs to be. So I've got the class, the fields, the constructor, and then getters and setters for all of my fields. Everything looks great there. Now let's just add a few comments. So at the beginning, I'll put a comment block. I'll just name my file. I'll put my name. And maybe I'd put a little description below that, but this will be fine for now. Then I'll put a comment here for my fields. One here for my constructor, and then one here for my getters and setters. Okay, so now we have a nicely commented class. It's fully tested, and so we can call this done. You are now a test-driven developer. We've learned how to write our unit tests for a class first, then use quick fix to rapidly generate a class based on that test. Now that you know how to write a test class and generate the associated class from it, I'd like you to try and build the seat class on your own. Looking at our project diagram, it only has one field, the seat number, which is an integer. So using the flight or passenger test class as your guide, create a seat test class and use quick fix to generate the seat class. If you get stuck, I've included the 2 classes in the working files. I'll also perform the solution in the next video, but don't cheat, give it your best shot first. In this video, I'll show you the solution for creating our seat class using test-driven design. So of course, first we'll want to create our test class. I'll do that underneath the test folder by choosing New and Other. Then we'll be creating a JUnit test case. We'll give it a name, which is seat test, and click Finish. So here's our class. It's stubbed in the first test for us. And let me give this a nicer name. So test seat will test the constructor, and I'll want to write that test out. The test will create a new seat object, so let me use code assist for that. We'll create a new object. It will be of type seat. The name will be test seat 1. And in order for quick fix to create the constructor in the actual class, let me just put an argument of 1 in here. Then we'll do our assert equals, and we'll test the value of 1 against test seat 1 dot seat number. And again, we want to use a public variable name so that quick fix will create that field for us. Later, it will change it to the get method. There's our first test. And then our second test will be to test the setter method. So I'll create a new method. I'll start off with pub and use codeAssist to create a public method. The return type is void, and our test will be called test set seat number. Again, we'll create a new seat object. So I'll use codeAssist for that. Create a new object of type seat. The name will be test seat2 with no arguments. We'll execute the setSeat method. So we'll say test seat2 dot set seat number, and we'll send it a value of 2. And finally, we'll test whether that comes back correctly with an assert equals, and we'll test the integer 2 against test seat2 dot get seat number. Okay, so we have our test class. Now let's use QuickFix to create the seat class. So we'll QuickFix off this first name, create the class seat. We'll want to move it to the source folder. And by the way, if you forgot this step and your actual seat class is down here in test, you can just drag it up here and drop it into the src folder. I'll finish. We've got our class just fine. Now we'll move over here, create the constructor. Everything looks good there. At this point, we'll delete the parameters, both on this side and on the test side. Come back and save that. Then we'll build our field, which will be private. It'll be an int, and it will be called seat number. Now that we've got the field, we can tell the constructor what to do. So we'll just make seat number equals, and we need a default for this. Since our airplane only has 6 seats, why don't I set the default to 10? That way we'll know if we have a seat object that hasn't set the seat number correctly. Save that, and then come back here and we'll create our getter and setter methods. And it says there's a compile error. That's just because we've created the additional test underneath it. So we'll just continue. Double check here. And our getters and setters look just fine. So our class is actually finished. If I save this, it recompiles and all of our errors go away. So all we need to do now is run our test. So I'll right click, run as a JUnit test. Looks like we've got an error here. Let's see what that says. And as you can see, it was expecting a value of 1 right here when we created our seat, and it got back a value of 10. So when we generated our constructor and I had this thought of setting this to 10, I didn't carry it over to our original test where I set it to a value of 1. So let's just set it to 10. Try that one more time. And now we're looking good. Okay, so by using test-driven development, we were able to create our tests and then generate our class for seat. In this video, we will learn how to use the toString method that is part of every class that you create. Many times as you work with objects, you want to be able to view them in a human-readable form. For example, having a list of objects display in a drop-down list, or if you want the object to appear in logging or error messages. Ideally, we want a method that has the same name in every class and returns a string representation of the title of that object, if you will. It turns out that every class inherits a method from its object parent class called toString. So anytime you create an object, the toString method is automatically available to that object. Let me give you an example, and I'll use our whiteboard page here. Let me create a new passenger object. I'll use codeAssist by just typing in the word new, control space, create a new object. So this will be a passenger, and I'll just give it the name passenger1 with no arguments. So that creates a new passenger object. And now anytime I refer to that object by its name passenger1, it will execute the toString method. Let me do that by printing it to the console. inside of the parens, I'll just put in the name passenger1. And now when I execute this, it executes the toString method and prints out a text representation of that object. So we mentioned earlier that every class is a child of another class called object. And the object class has a bunch of methods available to it that get inherited by any class that you create. toString, of course, being one of those. So by default, the toString method prints this out. And as you can see, it still is not all that readable. What it does is it mentions the package and the name of the class where the object comes from, then an @ sign, and then a hexadecimal representation of the pointer to the object you just created. So the Java virtual machine maintains a list of every object that you create. And when you need to find an object, it does so through this identifier. So this is the identifier to the passenger1 object. Now what we can do to make this more readable is to modify the output of the toString method. And we won't do that in the object class. We'll do that in the class that we built. In this case, we'll do it inside of passenger. When a class is a child of another class, and you rewrite one of its parent class's methods, that's what we call overwriting the method. And that's a key concept in object-oriented programming. For example, you may have a class called Cannonball, and then a bunch of subclasses for different types of cannonballs. And so the Cannonball class may have a method called Trajectory, but each child class could then override that method and change how the Trajectory method actually operates. And that's exactly what we're going to do here. So the object's toString method returns this output. We're just going to write a new toString method for our passenger class. I'll start out like all of our other methods. I'll type in pub control space and create a public method. It's going to return a string, and the name of the method has to be toString because we're overwriting the toString method in our object class. So this works a lot like a getter method that we've written before. All we do is return the string as we want it to appear. So passenger has a name field. Maybe I just want the return value to be the word passenger, space, and then the name of the passenger. So going back to what we learned about strings, we can concatenate all that together. I'll just type in passenger, space, close the quote, and then concatenate that with a plus sign. And then for good form, I'll use the this syntax and the getName method. Now we've overridden the toString method from the parent class of passenger, which is object. And Eclipse tells us that by putting a little triangle here. So you can see that we're overriding the Java Lang object class's toString method. So we'll save that. And let me just stop this JVM here. That's what that warning was before. And I'll reevaluate this. So now, when I run toString, it comes back by saying passenger and then the passenger's name. And this unknown name is coming from the constructor of the passenger class. So if we actually gave this passenger a name by saying passenger1.setName and setting it to something, now when we evaluate it, it should come back with that passenger's name. Now we have a way to represent an object in its human readable form. This way you can just refer to an object by its name inside of logging or error messages or anywhere that you want to just refer to this name. And if you put a toString method in all of your classes, which is a good recommendation, then you can refer to any object that you've created by its name and get back a human-readable text string. In this video, we will learn how to combine all of our unit tests into a single test suite. Every time that we've created a new class file, we've been building a new test to go along with it. So far, we have 3 test files that make up our unit tests. Now we can run all these individually just by right-clicking on them, choosing Run As, and saying JUnit Test. And that's fine, but when you have 10 or 20 or 200 of these files, that's not going to be a good solution. So JUnit has the ability to combine your tests into what are called test suites. And a suite is just a group of test files. So let's combine our 3 test files into one suite. You create a test suite in the same way that you create a test. Just right-click on the package, choose New, Other, and then you can see here under the JUnit folder, where we've been creating test cases, now we are just going to create a test suite. I'll choose Next. It will be a JUnit 4 test suite. It's under the correct source folder and package, and by default it calls it All Tests. That name is fine, or you can rename it. Maybe I'll associate it with my application, and I'll just call it Reservation Test Suite. Now here's the nice thing under here is it asks you which test files do you want to initially include in your suite. This will be a great time saver for us because we won't actually have to write any content in this file. I'm going to just leave all of them checked because I want all of them in the suite and click Finish. And this is what our test suite file looks like. Like everything else, it's in our package. It imports the appropriate JUnit libraries, and then it has a couple of annotators. The first one being run with, and that just tells JUnit that this is a test suite. And the most important line is this one here, which is suite classes. This contains the name of all of the test files that you want to include in your suite. And by having all of those checked, it automatically included our 3 test classes. The one thing to note is here the file name is, for example, flighttest.java. But when you add it to the list, you use the syntax flighttest.class. And that just tells JUnit to run this test as a class. Then finally, it has a class here as all source files need, and it has the name that we gave the test suite. There's nothing inside of the class, and there doesn't need to be for your suite. You can, however, do some fancy things with suites, like do some setup operations before it actually runs these tests, and then maybe do something after all of the tests run to clean up the objects, for example, that you built. But we're simply going to use the suite to run this group of tests. Well, that's all there is to it. It's ready to go, so let's see if it works. I'll just right-click on it and run it like I've run all my other tests. It comes up green, which is great, but notice what we have here. We've actually run 7 tests. They came back with 0 errors and 0 failures. And when we look a little deeper here into our suite, I can open this up and I can see that it ran our 3 separate tests, and each test had its own individual test cases that it ran. So now with one click of a button, I ran all of these tests. And this is where the power of unit testing comes into play. With a large application, you should be running thousands of tests. And by combining them into a suite, you can see now that you can run all of those with just a single button click. In this video, we will learn about using parameters and arguments in our methods. We know that methods perform some type of action when you call them. However, oftentimes, methods require additional information to perform those actions. For example, let's say you have a method that adds 2 numbers together. When you call that method, you would probably need to supply it with those 2 numbers in order for it to perform that action. And we do that through the use of arguments and parameters. Now, we've actually been doing this with the classes that we write. We just haven't gone into this level of detail yet. So let me open up some of our classes and we'll take a look. I'll start by opening up the passenger test class, and right alongside it, I'll open the passenger class. And let me stack these side by side and then minimize the Project Explorer. So in this test, where we're testing the setter for passenger, we create a passenger object called testPassenger2, and then we're calling the setName method. So over here in the passenger class, we have a number of different methods that we can execute. And of course, when you create an object, of typePassenger, you inherit all of these methods. So as we've done many times, when we set the name, we're providing additional information for that method, in this case a string with the value Mike Kelly. Then as that method gets called, the method is receiving that information and then uses it to perform its action, in this case setting the value of a variable. So let's look at some details about what's actually happening here. When a method expects to receive information from its caller, you describe what that information will look like inside of the parentheses right after the method name. This is what we call a method parameter. The parameter contains two parts. It contains the name of the parameter. So this is an arbitrary name that you are going to assign to the information that gets passed into the method. So when Mike Kelly gets sent, it gets assigned to a variable called newName. Now, in addition to the parameter name, you must also specify the parameter type. And that's because Java is what's called a statically typed language, meaning every variable must be told what type of information is going into that variable. So newName will be a string, and your parameters can be of any type. They can be the primitive types like integer or Boolean. They can be the complex types like dates and strings, and they can even be objects. Nevertheless, whatever you specify as the type must be used when you call that method. For example, if I call setName, which is again expecting a string, but instead I send it an integer like 100, you can see that right away Eclipse checks that and it gives us an error. If we tried to compile this file, we would get a compiler error as well. So as you can see, the error message says the method setName, which is expecting a string, is not applicable if you are calling it by sending it an integer. So this is the method caller, and the information that I'm sending the method is what's called an argument. So callers pass arguments into the methods that contain parameters, and the argument that you send must match the type of the parameter. Let me just set this back so that we don't get that error anymore. Now in this case, I am passing a single argument into this method. However, methods can contain any number of parameters, which in turn allows you to send multiple arguments into a method. Let's look at an example in our flight class. So let me open that up. And here we have methods that set the departure city, again with a single parameter of a string, and the arrival city. And when we call these methods, we pass those arguments. Well, what if we wanted to set both of them at the same time? We could do that by creating a method that has multiple parameters in it. Let me just show you what that would look like, although we won't keep that as a method in this class. So I'll create a new method, and I'll just call it setCities. So the key here is in defining multiple parameters. All you do is you just separate the parameters with a comma. So if I want to set both the departure city and the arrival city, I would create one parameter of type string for the departure city, separate it with a comma, and then create a second parameter of type string for the arrival city. And then just like I'm doing here, I can take those and set them here. So now my method has two parameters, and I use each of those to set my two fields. So I'll save that, and I'll just bring up my whiteboard here. So the way I would call that is I would create a new flight. Maybe I'll just call it flight 1. And I don't pass any arguments in the constructor, but now I can call my setCities method and just pass it two arguments. So I put the first one in quotes because they're strings, and then the second one. So this is how you pass multiple arguments into a method that has multiple parameters. So the combination of your method name and the parameter list is what we call the method signature, and that simply describes how you call the method. In this video, we will look at receiving results when we call methods. We call this a return value. I've opened up the passenger test class, which is a caller to many of the methods over here in the passenger class. And this will show us an example of how one class can return a value into a calling class. We've seen this several times before as we access the getter methods from our different classes. So in a similar manner to when a method receives information from its caller, a method that returns information to its caller must specify the type of information that it is going to return. Here's an example of the passenger's getName method. So the method returns a value, which is the value of the field called name. Now we know that the name field is a string already because we define it up here. But when you define your method that's returning a value, in addition to the name of the variable that you're returning, you must also specify its return type. And that's right up here. So because name is a string, we have to specify that in its return type up here when we define the method. Now, if a method doesn't return anything, you still have to specify a return type. And we do that by specifying a type of void. That means it's simply not going to return anything back. And you can see that in our setter method, and as a result, there are no return commands. So this method returns a string, and this method returns nothing. Now, when you call a method that is going to return a value, you can do that in a few different ways. For example, we created an object called testPassenger1, and now when we call the getName method, it's going to return a string back, which is the object's name. One way of receiving that return value is to set it equal to a new variable. In this case, I created a new variable called result to receive the results of calling the getName method. Now, knowing that that was going to return a type of string, the variable that I defined must also be a string. So all of these things must match. If, for example, I thought that this was going to be an integer, notice I get an error here saying that it can't convert from string to integer. So this is returning a string, and I'm setting that equal to a variable of type int, and it just doesn't work that way. The same is true within the method itself. The name field is a string by definition. If I say that it's going to return name, but I think that it's of type int, this will also produce the same error, because it knows that name is a string, but I'm trying to return it as an int. One thing to note about return values. We know that when we put parameters in a method, we can put multiple parameters separated by commas. That is not true of return values. You can only put one item in the return statement. Now that item could be a special type of list or even an object, which would hold multiple fields and values. But nevertheless, you can only put the name of one item in your return statement. Now, the other way to accept a return value is just to call it as part of a parameter in another method. So here we're using the assert equals command, and we're passing two arguments, one of which is a string, and the other of which is a call to the getName method, which we know also returns a string. So as long as this argument is required to be a string, you can make calls to methods that also return strings. So it's very common when calling methods to expect some kind of result back, and we do that with the return command. In this video, we'll learn how to create multiple constructors for our classes. Whenever you create objects based on a class, you end up calling that class's constructor. For example, when we create new passenger objects, we're calling this particular constructor method. As you can see, this method has no parameters. So when we create a new object of type passenger, it then sets the name field to the string unknown name. Well, in almost every case that we've created a new passenger, we've immediately then invoked the setName method to set that passenger's name. It would be nice if we could create the passenger object and set its name at the same time. And we can do that simply by having a constructor that has a parameter. Now we don't want to change this constructor because we're already using it. The nice thing is that you can have many constructors in your classes. So all we have to do is create another one. As our first constructor did, it will start with the word public, and the name of the constructor still has to match the name of your class, so it will be called passenger. Constructors are the only methods in your class where you can have two of them with the same name. The difference being the parameters inside the parens must be unique for each constructor. So in this case, when we create a new passenger object, we want to also be able to send it the passenger name. So we'll create a parameter of type string, and we'll just call it name. So now our constructor, which will begin and end with curly braces, can set the name field based on the argument that the caller passes in. Now in this first constructor, when we set the name, we just set the field name equal to a string. And since we are writing the code for this, we can ensure that this string meets the criteria of the name field. However, when you're passing in a parameter, you can't always guarantee that what gets passed in is appropriate for setting that field. And that's exactly why we created the setters for our class, because it will allow us at some point to put logic inside of this method that sets constraints against the value of our field. So since we're passing in an argument, we want to make sure that we do the same thing. So instead of directly setting the field, what you'll want to do is make sure that you just call the setName method instead, and just pass in the parameter that you just received. So now you have two ways of creating a passenger object. Just to show you back on our whiteboard page, the original way, if we create a new object, we can say passenger, and I'll just call it P1, is to use the old constructor that has no parameters. If we use this way, then we'll have to immediately set the name by using the setName method. And this is how we've been doing it all along. Well, now that we have another constructor, we can do all this in one line, and it will just look like this. I'll use Code Assist again. So we'll still create an object of type passenger. I'll call it P2, but now we set it to a new passenger, and we pass in the argument at the same time. So both of these are valid ways of creating new passenger objects. This first one we'll call our first constructor here, and the second one, since it's passing in an argument, we'll call this second constructor here. It's nice to have multiple constructors on your method, and most methods do have many constructors, so that you have lots of options on how you create objects. In this video, we are going to create our ticket class and learn how to use objects as field types. If we look back at our class diagram, we've already created the flight, seat, and passenger classes, none of which are directly related to each other. The class that hooks everything together is the ticket class. And just like the other classes, it has several fields. The first field being a date, which will be our departure date. But these other fields are quite a bit different than what we've done before. Instead of what we saw, say, in the flight class, where we had fields of type string and integer, what we want to do is link a ticket with the other classes that we've created. So a ticket will contain a passenger. We do that because we want to be able to reuse the passengers that we create in our application. We don't want to have to define the passenger every time we create a ticket. Likewise, once we've defined the 6 seats on our airplane, we want to be able to reuse those seats for the tickets that we create. So in order to do that, since a ticket contains a passenger, we define a field like we've always done, but the field type is the class that contains that passenger. So instead of this being a string or an integer, it's a type of the object that it's connecting to. So the passenger is of type passenger, the flight is of type flight, and the seat is of type seat. Other than that, there's no difference on how we're going to use these fields. So let's create our ticket class. We'll come up to our source folder, and under the package, we'll create a new class. We'll call it ticket and click Finish. So as we've done with our other classes, we'll define our fields. Now, normally I would use test-driven development to do this, but I think a combination of creating the test and then using Quick Fix to define the ticket would cause a little bit of confusion with all of these new concepts. So I'm just going to create the class directly. Starting with our fields, let me create a little comment here. Our first field will be of the type local date. That's that new Java 8 class that's available for us for easily creating date fields. The name of the field will be departure date. Then our next field will be the one that connects to passenger. So it will be of the type passenger, which is the name of the class. And I'm just going to call the field passenger as well, but I'll use a lowercase, which is the correct naming standard. Same with flight. It's of the type flight, and I'll call the field flight, and seat as well. So those are the 4 fields that make up a ticket. Now I need a constructor for the class, which will start out as public. It will have the name of the class, and it will begin and end with curly braces. When you create an object of type ticket, I'm going to have it default the departure date to the current date. And as we learned in the dates video, we do that by just setting the variable departure date equal to local date dot now. And that will just grab the system time off of your local machine and set it equal to the departure date. Next, we'll create the getters and setters, and we'll let Eclipse do that for us based on these fields. So we go up to Source, we say Generate Getters and Setters, and I want a getter and setter for each of our 4 fields. So I'll say Select All, and then OK. And here are all our getters and setters. Notice it created all of them as public, and as we've said before, we want all of our fields to be private, so why don't we add that to all of our fields here. And there's our ticket class. Let's just move this comment up so that it goes along with our getters and setters. Now you may also want to create an overriding toString method, but I'll leave that to you as an exercise. We still want to test this class. In the next video, we'll create a unit test class for ticket. In this video, we'll learn how to create ticket objects by writing some unit tests. We know that a ticket object contains the departure date, but it is also linked to a passenger, a flight, and a seat. So how do you link those objects to a ticket? Well, let's find out by creating a unit test that does just that. I'll come over to the package under our test folder and create a new test. It'll be a JUnit test case, and we'll just call it ticket test. So the test I'm going to write will be that for setting a passenger and linking it to a ticket. So I'll call it test set passenger. So just like all of our other tests, the first thing that I'll need to do is create a ticket object. So we'll start by saying new, Control space for code assist, and create a new object. This will be of the type ticket. I'll call it test ticket 1, and it'll be a new ticket where the constructor will not be passing any arguments. Now, if I go back and look at a ticket, in order to set a passenger, the setPassenger method has a parameter of type passenger. So that means I need a passenger object to pass into this method. So I'll create that. When I go back and look at my passenger class, one of the things I did that I recommended that you do also was I created an additional constructor that allows me to create a passenger and pass in the passenger name as part of that constructor. So this is the constructor I'll use when I create my passenger. Let's go back to our test, and we'll create that passenger object. So once again, new, Control space, create a new object. This will be of the type passenger. I'll call it testPassenger1. It'll be a new passenger, and I'll include the argument, which is the passenger's name. So what I want to do next is call the setPassenger method on this object and pass in as an argument this passenger object. And that will look like this: testTicket1 dot setPassenger, and the argument that I pass in is the name of the passenger object, which is testPassenger1. So that now links this passenger to this ticket. To see if it's successful, we'll do an assert equals, and I want to ensure that the passenger on this ticket has the name of Mike Kelly. So I'm specifically testing against a string, Mike Kelly, and the way I'll return that value is by using the getPassenger method for our test ticket. So we say testTicket1 dot getPassenger, and this returns the passenger. However, what it's returning is an object. So it's returning the entire passenger object. What we want is just the name of that object. Well, the nice thing about object-oriented programming is you can just tack on methods to the end of other methods. So since the getPassenger method returns an object, that object should have inherited all of the methods of the passenger object, which includes the getName method. So I just add that to the end. So this returns the name of this passenger that is linked to this ticket. The only thing left is to see if it comes back successful. Let's run our test and find out. There we go. So in this test, we created a ticket and a passenger, linked them together, and tested not only the setPassenger method, but also the getPassenger method. You should go back and write the remaining tests for the other set methods in the ticket class. In this video, I'd like to review what we've done up to this point and also make some suggestions on what to do before moving ahead. We've made a lot of progress in creating all of our data classes. With each class, we designed them with a specific structure. And I'd like to point out that Eclipse will display that structure for you right here in the Project Explorer window. If I open up my flight class, for example, I can see that it contains a single class called flight, just as we defined it here. If I open that, it divides up our flight into all the different fields in the class, followed by the constructors, and then finally the different methods that we wrote, some of which return values and others contain parameters. So all of that is outlined here in the Project Explorer window. Now, so far with all of these data classes, we've defined what we are going to store, but we haven't decided how we will store that data. For example, if this were a game, since you start over again every time you play the game, you could probably just store all of your class information in memory. Whereas if this were an enterprise application, you may want to store it in files or in an enterprise database. How we are going to store this data should not be stored in the data classes itself, because that may change, and ideally, we don't want to be modifying classes that have successfully running tests against them. We call this practice separation of concerns. So in other words, we'll describe the data in one set of classes, we'll write methods for accessing that data in another set of classes, and then we may have other classes in our application for things like business logic and how we will present that data to the end user, whether it be on a smartphone screen or a web page, etc. So by keeping all of these things separate, we can change how one layer behaves without affecting the others. Now, before moving on, I'd like to recommend that you do a few things in all of the classes that you've built. Number one, add a second constructor to everything. And that constructor should allow you to create objects and at the same time put values in all of the fields. So for seat, you should be able to create a seat object and set the seat number simultaneously. Same thing with flight, where you set the flight number, departure and arrival city, and with passenger, set the passenger name. Now, since you're populating your ticket with objects, you don't need to do that for ticket, but do it with all of the other classes. Next, I showed you how to create a toString method, which lets you represent your object as a human-readable string. You should go back and do this on all of the other classes. Here are some recommendations on the string that this method could return. So for the seat, we put the seat number. For the flight, we combine the flight number and cities. The passenger has the passenger name. And for extra credit, your ticket could return everything about the passenger, flight number, dates, and destination cities. Finally, since you've added a lot to the classes you've created so far, make sure that your tests cover all those new things. Number 1, add the ticket test class to our existing test suite. Then for any new constructors, getter and setter methods, and your toString methods, make sure that you add those to your existing tests. Then finally, rerun your test suite and make sure it comes back with all tests running without any failures. I recommend that you do this so that it reinforces everything we've learned up to this point. In the working files, I've included a file called classes.zip that includes all of the data classes and the unit test files. You can check your work against those files to make sure that we're both in the same place as we move forward. In this video, we will see how to use an array list to store a list of items. Now that we have defined all of our data classes, we need a way to organize and access the objects we create from those classes, such as the passengers, tickets, etc. If you recall from our unit test classes, each time we ran a test case, we created new objects. By giving each object a unique variable name, we could keep them separate. However, this will become unmanageable when we want to work with our flights as a group. For example, looking up a flight by its flight number or departure city. When you want to work with objects as a group, you put them into what is called a collection. Think of a collection like an egg carton, where each egg in that carton is a different object in your application. A collection is given a variable name, just like other objects, except when you refer to the collection by name, you are referring to all of the object in that collection as a group. Now, just like there are different styles of egg cartons, there are different types of collections. Each collection type has its strengths for performing certain types of operations that you want to perform on its contents. For our application, we want to add objects to the collection randomly, such as passengers, and then be able to easily find a passenger in that collection. For a general purpose random list of objects, we use what is called an array list. We will create a different array list for each group of objects that we create, flights, passengers, seats, and tickets. Then we will be able to perform operations on those array lists, like for a given date and flight, tell me which seats are still available. Let me show you how to define an array list. We'll use our Scrapbook page for this. You define an array list in the same way that you create a new object, with one addition. So let me write this out first. If I wanted an array list of strings, like a list of names for example, I would just say ArrayList followed by the name of the variable equals new ArrayList. So this is how we've been defining objects up to this point. Now the one difference with array lists is that you need to specify what type of objects will be contained in the array list. In our case, it will contain string objects. So you put that type inside of angle brackets right after the word ArrayList. So I'll put it there, as well as here after the new command. This gives me an empty collection that can hold string objects. So you can't mix your array list with different types of items. Now it's important to point out that array lists hold lists of objects. So that does not include primitive types like int and Boolean. Luckily in Java, there are object equivalents for all of the primitive data types for situations just like this. So if you want an array list that holds ints, for example, you just use the object type of integer, and that's spelled with a capital I. You would also, of course, put integer here and probably change your variable name. Likewise, you can use Boolean with a capital B, long, double, etc. All of the primitive data types have object equivalents. Now for our particular use, we will be storing a list of our data objects in each array list. So for example, if I say ArrayList flight and put flight here, we can hold a list or collection of flight objects. By creating a new class containing all of our reservation objects in ArrayLists, we will have a simple in-memory database for storing and retrieving our application data. In this video, we will create a class to hold and operate on our data objects. One of the basic principles or patterns of programming is to organize your application into layers that perform similar activities. This is called a service-oriented architecture. This is one of many ways to design software, but the main goal of using something like a service-oriented architecture is to minimize the impact of change. The theory being that a major change to part of your application should only affect the layer to which that change belongs. Now, to put that into context with our application, all of our data classes represent one layer of our application. We will now need to write a class to create, access, and process that data. We will do so in a way that stores all of our application objects into array lists, which are stored in memory. That means that our data will only exist as long as we keep the application running. But this is fine for the purpose of this course, which is to learn the basics of the Java language. Eventually, we may want to store our data permanently, also called persisting our data. When we do that, it would be ideal if we could just change this one class that we are about to write instead of having to rewrite all of our data classes as well. That is the benefit we will get by using a service-oriented architecture. So with that background, let's start to build our database class to organize our data and perform the business logic governed by our application requirements. The class will look a lot like a data class, but it will have additional methods that do more than just get and set values. And we will use the test-driven development methodology to build our class and unit test. Since our class is called database, let's create a database unit test. We'll just come down here to our package, right-click, choose New, Other, and then create a JUnit test case. We'll call our test case database test, and then click Finish. So here is our unit test class with our first test pre-configured for us. We want this test to test the constructor of the database class. So let's rename the test and call it test database. And to test the constructor, we'll first have the test create a new object based on the database class. So we'll be creating a type of database. We'll call that database object testDB, and we'll set it equal to a new database. Now I would like to pass an argument so that we can use quick fix to build the constructor. We saw how that worked in a previous video. So I'll just pass in an integer of 1. So with that statement, quick fix will allow us to create the database class and its constructor. We'll just hover over database, we'll create the class, and we'll want to make sure that the new class goes into our src folder with our other classes. Otherwise, everything else is fine. So here is our database class. Then I'll come back to the test and create the constructor. So our constructor will be a public method. It will be called database, and you can see that it has a parameter of int. This was all made possible by passing that integer in as an argument, but I don't really want the constructor to have a parameter, so I'll just delete that here, save it, and then go back to the test and delete it here as well. Just by way of review, if I hadn't passed anything in, there wouldn't have been a quick fix option to create a constructor. So there is the beginnings of our class and unit test. In our next video, we'll continue on by creating the fields and the rest of the methods. In this video, we will continue to use test-driven design to create the fields and constructor for our database class. So far, our unit test creates a new database object called testDB. And as a result, we were able to use QuickFix to create the database class as well as the default constructor. Now, what we would like this constructor to do is to create empty array lists that will hold our seats, passengers, flights, and tickets. And we can use test-driven design for that as well. What we need to do is come up with a test that checks for the existence of these array lists. And the easiest way to do that is to check the size of the array list. In other words, when we create a new array list in the constructor, it shouldn't have anything inside of it. Therefore, its size should be 0. And we can check that with a test. So we'll begin our test with assert equals, and the result that we are testing for is a size of 0. And we'll perform that test by looking at our testDB object. We'll look at the field, which is the name that we want to give our array list, and we'll create the seats array list first. So I'll call that seats. And finally, to check for the size of that array list, I use a command called size. So that's how we will test that the constructor created the array list called seats. With this test built, we can use QuickFix to add that field to our class. So I'll hover over, and I'll create the field seats in our database class. As with all of our other classes, we want our fields to be private, and it will be an array list which holds seat objects. So I'll put our seat class inside of angle brackets, and I'll call the array list seats. Now, as we hover over this error on array list, we can see that the actual error is that it cannot be resolved to a type. And that simply means that Java doesn't know what an array list is. This is a lot like our local date variable that we created earlier. ArrayList belongs to a library in Java called util. So all we need to do is import that library into this class, and QuickFix will do that for us. So now it knows about ArrayList. So now we have the variable declared, so let's initialize that variable down here in the constructor. Again, it's called seats, and I'll just set it equal to a new array list of type seat. It won't take any arguments, and we'll end it with a semicolon. So let's save that and go back to our unit test. And now that we've made seats private, we can't access it just by calling out its variable name. We'll have to use some kind of getter for it, which QuickFix will change for us. So let's create getter and setters for seats. We'll click OK. And as we've seen before, it changed that now to the getter. Okay, last thing, we'll go back over to our class. And so we can see that QuickFix added our getSeats method, our setSeats method, and it modified the constructor to use setSeats as opposed to accessing the variable directly. Now, this is the pattern that we've been using in all of our data classes up to this point. But this isn't exactly how we want our database class to work. The getSeats method is perfect. It returns the entire list of all of our seats, which is exactly what we want. However, setSeats has a parameter of ArrayList seats, which basically means it's expecting the entire list of seats as its argument. And we will never be setting seats in that way. We'll be creating seats one at a time. So this is not a method that we need. However, if we delete it, then our constructor doesn't work either because it's relying on setSeats. What I really want is just this getter method and the constructor as we originally had it. So let me just show you an alternative way of setting this up. I'm going to press Ctrl-Z or Command-Z on the Mac to undo this. Click OK because the undo needs to affect both the unit test and our class. And now we're back to where we started. So instead of doing a quick fix here on this variable, what I'll do is on the database class itself, I'll use the source menu to create just the getter that I want. So I'll go to Source, Generate Getters and Setters, and now I can choose just what I want, which is getSeats. So I don't want a setter method. I'll click OK. I've got the get method that I want. My constructor is the same as it was, so it hasn't changed. And now I can go back to my test And the quick fix for this error, instead of generating getters and setters, is simply to replace the variable call with our getter. So now this is working exactly like I need it to. Okay, let me do a multiple save so that everything is saved. And I should be able to test this and have it run successfully. I'll say run as, unit test, and our test case is running successfully. So this is the pattern for setting up the field and the getter for our seats array list. What I'd like you to do is pause the video and follow this same pattern to create the passenger, flight, and ticket array lists. Once you've done that, come back to the video and you can double check your work. Okay, so your final test after it's all finished should look just like this. You're checking for the existence of all 4 of our array lists and that they have a size of 0, and as a result of using Quick Fix, your class should now have 4 fields, a constructor that creates all 4 array lists, and then all 4 getters. I've also added some comments as we've done in the past. Then when we run our test, it should run successfully. Now we have a lot more to do on this class, but we'll be doing that in the next few videos. In this video, we will learn how to add items to our empty array lists. Let me show you how to do this first using the Scrapbook. First, let's create an empty array list made up of strings. I'll call that names. Now, just like with our classes, the Scrapbook isn't going to know where the ArrayList library is. So we'll need to tell it that by modifying the imports. So I'll do that by right-clicking on the Scrapbook and saying Set Imports. What I need to do is add the java.util package. So I'll enter that here and click OK. So now this command will work. Now, ArrayList has a number of methods that allow you to add, modify, and delete items. We call those items elements. So when you want to add a new element to an array list, you just specify the name of the array list, which in our case is names, dot, and then you call the method add. With the add method, as a parameter, you just send it the type of item that you're adding. So in this case, it's a string. So let's add a string, and I'll just send it my first name. So this will add the string Mike to our array list, which is called names. Let me add a second name, and I'll just add my last name. And so now if we check the size of the array list, I'll just do a print line saying there are now, and I'll print out the size of the array list followed by the literal names. It should show that there are 2 items in the array list. I'll just execute that, and sure enough, it says there are now 2 names. So using the add method, let's create a test that adds a new seat to our seats array list. I'm going to create a new test. I'll just paste it in to save a little bit of time here. So we start out with test. The name of the test will be test add seat. And the test will begin by creating a new database object called testdb2. Now, since I can't directly access the testdb2 object outside of the class, I'll need to call some kind of a method for this object. And we'll need to create that. But assuming that it exists, we'll write a test for it. And what the test will do is first call the method, which I'm going to call addSeat, and I'm passing in an integer of 2. That's because seat has just one field, which is the seat number. So essentially what I'm saying is I want to create a new seat object, set the seat number to a value of 2, and then add that seat object to the seats array list inside of our testdb2 object. Now, assuming all that works, the seats array list should now have a size of 1 because it contains one seat object. And that's what I'm going to test. So I'll perform an assert equals, I'll test for a value of 1, and I'll look at my testdb2 object, run the getSeats method, which brings back all of the seat objects in the array list, and I'm just going to ask how large that array list is by running the size method. That should return a value of 1, which I'm testing here. Now, this addSeat method doesn't exist yet in our database class. So let's use QuickFix to add that method. It puts it down at the bottom. It should be public. It's not going to return anything, so we'll leave the return type as void. It's going to be called addSeat, and it will take as a parameter an integer, which is the seat number. So what will this method do? Well, to our seats array list, it's going to perform the add method, just like we did in the Scrapbook. Now, we're not adding a string. What we're doing is we're adding a new seat object. And we do that by saying new seat and pass in this parameter here in the method we just created. Now, I isn't a very good parameter name, so let's call it seat number instead. And we'll need to make this the same. So there's our method. So this is creating a new seat object and passing in an integer, which is the seat number. Now, the only way that this will work is if there's actually a constructor in the seat class that can receive an argument of seat number. Let's just double check that. And in our constructors, here's the one that allows us to create a new seat by passing in an integer. Our class should be good to go, and our test should run successfully. Let's see if it does. I'll just come up to the JUnit tab and rerun our test. Everything looks good. I'll open this up, and sure enough, our addSeat test is working. Now, let's not be fooled by a test that always runs successfully. So just to double check, I'll add one seat to the array, but I'll see if it returns a value of 2. This test should fail, and it does. So we know that we haven't created a test that just always runs successfully. Why don't you pause the video and recreate this test for passenger and flight? Now, ticket will be a little more complicated, so we'll cover that a little bit later. So here are the 2 additional tests I wrote, one for flight and one for passenger. And the database class now includes these 2 new add methods for flight and passenger. Yours should look essentially the same way. In this video, we will learn how to access a specific element in an array list. When you add an object to an array list, you are creating an element in that array list. Every element is assigned a number called an index. By referring to the index, you can return the object associated with that element. This is done by calling the ArrayList's get method. Looking back here in our Scrapbook, we created an array list called names and added 2 elements, a string with a value of Mike and a string with a value of Kelly. Now, the first element receives an index value of 0. So if you have 2 elements, they will be numbered 0 and 1, and the array list size will be 2, as we already know. So that's a little weird, but that's just how Java works. So if I want to see how this works and get the value back for this first element, I'll just do a print line of our names array list, and I'll run the get method on the index 0, and then close the paren. So let's just give that a shot. And so you can see that it prints out the size of our array list, which has 2 elements, and the value of the first element, which has an index of 0, is Mike. If I look for our second element, which has an index of 1, I should get Kelly. So we use the get method along with its index value to return the element in the array list. Now, knowing that, we can improve our unit tests by not only returning the size of the array list, but also ensuring that the value was added properly. So here, where we added a new seat object with a seat number of 2, we should be able to use the get method to ensure that it returns a seat number of 2. We'll do that by saying assert equals. We are hoping to get back a value of 2 for the seat number. And so we'll do that by pointing to our test db2 object. We'll get all the seats back by running the getSeats method. And so that will return all of the items in the array list. Now to get this specific object back that we added, we say get followed by the index number, which is 0, being the first element in the array. Now we should have a single seat object. Then, to get the actual value of the seat number, we just execute that class's getSeatNumber method. We've added a seat with a seat number of 2. Let's create a failing test first to say that we're expecting a seat number of 3. When we run our test, we can see that it fails. It was expecting 3, but it came back as 2, so that's good. Now we'll change it to the successful test, save it, and when we rerun it, it runs successfully. So now we have better coverage, not only getting back the size of the array list, but we're ensuring that it added the object correctly. You may want to add this additional test to these 2 others down here. In this video, we will initialize our database using a process called bootstrapping. Most applications contain certain lists of objects that don't change over time and need to be available when the application starts. For example, a list of all the countries that users can select when entering their address, or perhaps an initial list of game pieces that exist when a game begins. Although your application may have screens to administer these lists, it is also nice to be able to have the application add these items automatically when the application starts, or when you first put it into production. We call this process bootstrapping. Typically, you would create some type of external file containing your Bootstrap data, and then import it into the application. Now that's a little out of the scope of this course, so we will just create a Bootstrap method in our database class that uses the add methods we just wrote. We have 2 lists of data in our application that do not change. Those are the 6 seats on our airplane and the set of flights that we take daily. Remember that we fly the same routes every day, so we put the date on our ticket and just make reference to the flight object to which that ticket pertains. So let's create this new method in our database class. I'll use Code Assist by typing in pub for public, then pressing Control Space. I want to create a new public method, and the return type is void. It doesn't bring anything back. And I will call the new method Bootstrap. It also does not take any parameters. So all this will do is call our addSeat and our addFlight methods that we created earlier. And that way I can quickly add our 6 seats and our 4 flights. So to add seat number 1 of our aircraft, I just call the addSeat method and pass in the seat number. And I do that for the remaining 5. For our flight, I just call the addFlight method, and I pass in the flight number, the departure city, and the arrival city. And again, I'll do that for the remaining 4 flights. So here are our flights going from LA to Chicago, Chicago to New York, and then back. So when our application starts, we will call this Bootstrap method one time, and it will initialize our database with these objects. Now we can do a simple test to ensure that these objects were created. And again, we'll just check the size of each array list to ensure that there are 6 seats and 4 flights. This is pretty straightforward from what we've been doing already. So let me just paste it in here. And I'm going to call it test bootstrap. It'll create a new database object. We'll call the bootstrap method, and then just check the size on the seats array list and the flights array list. I'll save everything and then run this. And everything is looking really good. So here's our bootstrap test that ran successfully. So this method will be part of what we call every time our application runs. In this video, we will learn how to search an array list for a specific element. One of the reasons we put objects into collections is to be able to search through them for the existence of a particular element. As is common to most of the Java collection types, ArrayList has built-in methods for performing searches on its elements. The first method we will look at will search an array list for an instance of its type. In other words, we can provide a search string to an array list of string objects, or an integer for an array list of integers. If it finds it, it will return the index of the first element it finds. This works for basic data types like strings and numbers. It doesn't really apply to our application since our array lists are made up of custom objects like seats. But it is a common syntax that you will probably use in other applications, so I want to show it for completeness. The name of the method that we will use is called indexOf, and it takes your search criteria as an argument. So in our scrapbook, let's look at how this would work. I'll use this array list called names, which contains two string elements, Mike and Kelly. So if I want to search for the existence of one of these two strings, I would use the indexOf method. So we'll do that, and we'll just print out the results. So I'll do a system out print line, and I'm going to be searching through my names array list using the indexOf method. And let's say I want to see if the string Mike exists as an element in my array list. So if it does, it should return the index of that element. Mike is our first element, so this should return back an index of 0. Let me just close my paren here. And when I run it, I get back the index of 0. If I look for the instance of Kelly, it should find it in element number 1. Now, if you send it a search criteria and it doesn't find it at all, it returns back a -1. Element indexes can't be negative values. So returning a -1 tells you that that element doesn't exist. The second method for searching is simply to let you know if an array list contains the criteria, but not to say where it is. So it just returns a Boolean of true or false. The method is called contains. So instead of asking for the index of the element, I can just ask if it contains it. And if I look for Mike, when I execute this, it comes back as true, meaning that Mike does exist as one of the elements in my array list. If I look for something that isn't there, then it returns false. So this is useful when you just want to say, if it is there, then do something. But you are not doing something to the actual element that you searched for. Now, since our array lists contain custom objects, we will need to loop through all of the elements and inspect them individually. We'll look at how to do that in the looping section of the course. In this video, we will see how to remove elements from an array list. It is not as popular to remove items from an array list as, say, adding or searching, but this will round out our study on collections. As with adding and searching, ArrayList has a remove method that uses the element index as an argument. So on our scrapbook page, we have our names array list with two elements. And I'm printing out the size of our array list, which should return back a value of 2. So now let me remove one of these elements. We do so simply by specifying the name of the array list, which is names, and then using the remove method. You specify the element that you want to remove with its index. So if I want to remove this first element, that is index 0. So if this removes correctly, I should then be able to check the size, and it should have a size of 1. So let's try that out. So when I first create my array list and check its size, it has 2 elements. Then I removed one, and now I'm down to 1. Now what you should understand is that by removing this element, you're not leaving a hole in your array list. So if at the bottom, I ask it to return the value of the first element, notice what happens. So I start out with 2 elements. I remove the first one, which is Mike. That leaves me with 1 element. And when I ask for the value of the first element in my array list, it says that the value is Kelly. So what that means is that when I removed this element, which had index of 0, it shifted all the remaining elements up by 1. So now Kelly has the 0 index, whereas before it had an index of 1. So when you remove items from your array list, it fills in all those gaps by pushing everything underneath it up. This will come in handy later when we want a list of available seats when we are booking a ticket. We will do that by starting with an array list of all seats and then remove the ones that are taken for a given flight. In this video, we will begin to learn parts of the Java language that extend the abilities of our application beyond just storing and retrieving data. First, we are going to look at what is called a while loop. One of the primary reasons computers were invented was to be able to perform repetitive tasks quickly. As a result, you will find commands in every programming language that allow you to execute a list of statements over and over again. We call this a loop. The while loop is one of several looping techniques that we will look at in this chapter. In general, all loops have a beginning, which is the state of the application under which the loop starts, and they have an end, which is the condition that tells the loop to stop. With a while loop, the starting condition is set outside of the loop, and then it repeats until the ending condition is met. Let me give you an example. Let's say that a game initializes by setting a variable called lives remaining to 3. That would be the starting condition. You may then start a loop that lets you move your spaceship around until it is hit by an object, at which point it subtracts 1 from lives remaining, and then it repeats until the lives remaining variable equals 0. In other words, continue looping while lives remaining is greater than 0. Let's work in our Scrapbook page. I'll start by setting the starting condition, and I'll do that by creating an integer called lives remaining, and I'll set that equal to 3. So this is the starting condition, which I'm setting outside of the loop. Now I create the loop by starting with the word while, and inside of parens, I put the stopping condition that it's looking for. And for us, that will be lives remaining greater than 0. So now, as long as lives remaining is greater than 0, we want to perform a list of statements. And those statements will be in between a set of curly braces. So anything I put in here will be part of the loop. Now, I'm not going to write a big class that describes how to move a spaceship around, so let me just put a comment in here that says, move around until you are hit. Now, once that happens, I want to subtract 1 from lives remaining, so I could say lives remaining equals whatever it is currently minus 1. Now, this is considered longhand, and it's very readable. There's a shorthand version, however, that is so popular that almost all programmers use it. And that is when you are going to subtract exactly 1 from a variable, you just list the name of the variable and then follow it with 2 minus signs. So lives remaining minus minus is the same thing as saying lives remaining equals itself minus 1. Now you can do something similar when you are adding exactly 1 to a variable, except instead of saying minus minus, you say plus plus. So this is the same as lives remaining equals lives remaining plus 1. So the next time you're at a cocktail party with your programmer friends, you can tell this interesting story. Quite a while ago, a programming language was invented that had the name C. In fact, today it's still one of the most popular programming languages. Well, when they added object-oriented functionality to the C language, instead of calling it C version 2, they called it C++. You've probably heard of that language, and that's how it got its name. It was basically a nod to all the programmers that understood this syntax. So, back to our example. We're going with lives remaining minus minus, that subtracts 1 from our lives. And then let's just print out on the screen that we've been hit by something and our lives have been subtracted by 1. So I'll do a system out print line and I'll say kaboom, you have, then I'll print out the value of lives remaining after we've subtracted 1 from it, and follow that up with the words lives left. So that's our loop. It will just continue doing this over and over again until lives remaining is equal to 0. Then at the very end, after we've left the loop, just to let us know that that's happened, let's print out another statement to the console that just says game over. So that's the syntax of a while loop. Let me expand my console a little bit, and right before I execute it, let me close this paren here, and now we'll execute our loop. Okay, and there's the result. So we started out with 3 lives. Once we got hit, it subtracted 1 from that. That left us with 2. Then it printed out the statement. Then it went through that loop 2 more times. Each time it was looking at the lives remaining variable to see if it was still greater than 0. So the last time it went into the loop, I still had 1 life left. And then when I got hit, it subtracted 1 while I was inside the loop, giving me 0. Then it went back up to the top of the loop again and checked if I had greater than 0, and I didn't. I had exactly 0. So then it just went to the next line after the loop ended and printed out that last line. So that's an example of how a while loop works. You will find as we learn other ways to loop that for almost any situation, you can take your pick on which looping syntax to use. I find from a readability standpoint, when I don't know up front how many times I'm going to repeat a loop, I tend to use a while loop. In other words, loop until something is true, regardless of how long it takes. In our example, the loop itself does not know that it will only execute 3 times. It simply repeats until you run out of lives. We will use a while loop a little later when we write the main class of our reservation system, which loops until the user exits the application. In this video, we will learn a way to make your code repeat itself by using a for loop. A for loop is similar to a while loop in that it has a beginning condition, or an initialization, an ending condition, also called the termination, and an increment. With a for loop, however, all of these are stated in the opening statement of the loop, which for some makes the loop more compact in its syntax. Let's take a look. A for loop begins with the word for and then an opening paren. Now, unlike a while loop, all of the parameters for the for loop are going to be between these 2 parens. So the first parameter is the initialization. Since you are initializing a variable, you'll need to include its type. So let's use our lives remaining example as though we were doing this for a game. If we are going to be iterating through the number of lives that we have in the game, that would probably be an integer. So we would say int followed by the name of the variable and then its initial value. You follow that with a semicolon, and then you have the ending condition. In other words, what is the loop going to check for to know whether it should end or not? So we might say lives remaining greater than 0, then another semicolon, and then finally what you are going to increment within the loop. In our case, we are going to subtract 1 from lives remaining. So we say lives remaining minus minus. And again, that's the shorthand version of saying lives remaining equals lives remaining minus 1. So all of that is stated at the beginning of the loop. Then you create a code block with braces, and whatever your loop is going to do will be inside of these braces. So this is where the logic would go that occurs inside the game. Let me just put a printout statement that says kaboom, you have, followed by the number of lives you have left, and then the literal lives left. So this will work just like our while loop. Let's execute it. And here are the 3 iterations of the loop. It ran as expected, but let's look at some differences between this and the while loop. Notice here that you go into the loop without incrementing. So we set our initial value to 3, and that was the value we started with when we went into the loop for our first cycle. If that's the wrong value, you may need to adjust your initialization variable. Also, with a for loop, you don't have a choice on whether or not the loop will increment. it simply does so every time it goes back and repeats the loop. Whereas with a while loop, you could theoretically make the increment conditional. Finally, you may have heard the adage, "you can't take it with you." That is also true of a for loop. What I mean by that is anything that is declared in the for statement or inside of this code block is lost once you exit the loop. For example, if you want to return lives remaining back to a calling object, you need to declare it before this statement. And I could easily do that simply by saying int lives remaining, and then just remove that here. And so this would work exactly like it did before. However, once I exit the loop, I now have the value of lives remaining available to me, so I could return that. In summary, for loops are mostly used when you know exactly how many times you are going to repeat the loop. It is also one of the few times that it is acceptable to use short variable names, since they only live inside of the loop. The variables I, j, and k are recognized as looping variables and can shorten the syntax even more. So for example, I could just use the variable I here. And since I is only going to live inside of the loop, we don't need to put a long variable name to keep track of what it means. You can see how much it shortened up the syntax inside of here. So this is the syntax for creating a for loop. In this video, we will learn about the enhanced for loop, which is designed to work with collections of data. For loops are most useful when you have a predefined number of iterations you are going to repeat. The enhanced for loop takes this a step further by allowing you to initialize your loop with a collection of data, such as an array list, and then it automatically sets the iteration and termination parameters to coincide with the items in that collection. For example, if you create a for loop with a collection of 10 passengers, it will iterate through each passenger and end after the last object in that array list. This will be very handy for the methods we still need in our database class. So let's take a look first to see how it works. On our Scrapbook page, let me first create one of our database objects. I'll do that by setting the type to database. I'm going to call the object DemoDB and set it equal to a new database. So now DemoDB will inherit all of the methods that are part of our database class. What I want to do is create several passengers and then iterate through all of them. So one of our methods is to add a new passenger, and that's done with this method here called addPassenger. The method takes a parameter of the passenger name, which is a string. So let me add 2 passengers to our demo database. I'll say demodb.addPassenger, and then just give the passenger name. So our first passenger will be myself, and then I'll add another passenger, and I'll just make this John Smith. So now that we have some data to work with, let's create our for loop. As with a regular for loop, we say for, and inside the parens, we put in our initialization, termination, and increment. However, the syntax is different when you are going to iterate through a collection. Just like with a regular for loop, we'll first specify the type of object for which we are iterating. And our array list contains passengers, so the initialization will have the type passenger. Then you specify the variable name. So this is what you are going to call each passenger as you're going through the loop. You can call this anything you want. I'm just going to call it item. You follow that with a colon, and then finally you specify the array list that you are going to iterate through. So what we need is an array list that contains all of our passengers. And you can either specify that directly, or you can call a method if one's available. In our database class, we have a getPassengers method that returns an array list of all of the passengers in our database. So that's how I'm going to get our array list in our loop. I'll just specify our database object, dot, and then call the method, which is getPassengers. And that's how you set up the loop. So now the loop will just be inside of a code block, which we enclose in curly braces. And what will happen is, as it goes through every passenger, while it is in the loop for that individual passenger, you can refer to it by the name item. And that item will be a passenger object. So just like with our database, you can inherit all of the methods and fields from the passenger class while you're inside of this loop. Let me just do something simple, like print out the name of the passenger. So I'll just do a print line of the item object, which is a passenger, and if I look at my passenger class, I'll be able to call any of these methods. So let's just use the getName method. So item.getName will return the name of the passenger for that iteration of the loop. So we've created these two passengers. The loop should simply return these two names back to us. Let's see if it works. And there we go. So it iterated through our passenger array list and called the getName method on each passenger. Once we have covered some other commands, we will use the enhanced for loop to calculate things like what seats are available for a given flight and whether to treat a passenger as a new passenger or a returning one. Now we will take a look at a command called if. Being able to make decisions is an important aspect of any programming language. This requires an application to evaluate an expression that returns a true or false answer, which we know as a Boolean, and then execute a block of code depending on that answer. We call this an if condition. Let's take a look at a quick example. Using a game as our example, let's define a variable called highscore. We'll make it an integer, and we'll set it equal to 100,000. Now let's create another integer variable called finalScore, and we'll set that equal to 110,000. So these variables might be passed into a method or could be initialized, for example, at the beginning of the game. But using these two variables, let's create an if statement that will execute some code depending on how we evaluate these two numbers. An if statement looks a lot like the looping commands we've done earlier. We say if, and then we put a condition inside of parens. And you can probably guess where we're headed here. We want to compare the high score to the final score. And specifically, I want to know if my final score is greater than my high score. So that evaluation would simply be final score greater than high score. If that's true, I want to execute a block of code, which, as with everything else, is in between a set of curly braces. What do I want to do? Well, for this example, let's just print something out to the console. And maybe I'll say, you set the new high score. So it will go into the if condition, compare these two values, and if the answer to this evaluation comes back as true, then execute everything inside of the code block. If it comes back false, then skip the code block and just continue on with the next statement. So perhaps I'll just ask if they want to play again. So that's a very basic if condition. So let's give this a try. Let me just close my statement here with a quote. And we have our final score set higher to our high score, so it should execute the statement inside the code block. Which it does. So we set the new high score, and then it continued on after that and executed this statement. Well, sometimes you would like it to execute one block of code if this comes back true, and a different block of code if it comes back false. We can do that by adding something to our if statement called else. So else is just another block of code that executes if this comes back false. The else is also enclosed within a code block, and maybe I'll just print something different. So I'll just copy this to save a little bit of time. And if we didn't beat the high score, let's say not a bad score, keep trying. So now, if this is true, it executes this. If it's false, it executes this. And regardless of the answer, it continues on and executes this. Let's clear the console and give it a shot. So the way it's set now, we beat the high score. Let's change this to 90,000, which is below the high score. And now it executes that code block. So it skips this and executes this instead. So oftentimes, this is what we refer to as an if-then-else condition. In other words, if this is true, then execute this. Otherwise, or else, execute that. Now, the last thing that's common with an if statement is to compare multiple things. And this is done by simply nesting multiple if statements inside of each other. For example, this will check to see if you beat the high score, but what happens if you tie the high score? Well, that's a different comparison than final score greater than high score. All we have to do is put in another else followed by an if statement. So we'll close the first code block and we'll say else if, and then we just start over again. Final score equals. Now this gets a little bit fancy. If you just have one equal sign, you're changing the value of a variable. And we don't want to do that. We want to compare one variable with another. And that's done with two equal signs. This is what we call equality, as opposed to one equal sign, which is known as assignment. So if final score is equal to or has equality with the high score, then execute a new code block. And why don't we just print out, you tied the high score. So if this is true, it does this. If it's false, it first checks this to see if this is true. And if none of those are true, then it executes this. So we've seen the first and the last part work. Let's tie our high score and see if that works. And there we go. So those are the three possibilities you can get with an if statement. We called the if command a conditional statement. You may also hear it referred to as branching logic because it allows your code to take different paths depending on the answer to the if question. In our application, we will put an if statement inside of an enhanced for loop to branch our code as we loop through array lists of our data. In this video, I'd like to talk about the different ways that you can compare values. So far, with all of the looping as well as with the if statement, we needed to compare one value of a variable to another. This was pretty easy by just putting the one variable on the left side and the other on the right. And what was in the middle is what we call the operator. We've been using standard mathematical operators, and up to this point they've pretty much made sense. But I would like to formally discuss the operators that are available to us when we are comparing values. We've looked at greater than, which just asks, is this value greater than this? You also have the ability to say greater than or equal to, and conversely you can say less than or equal to. We also learned that if you wanted to see if they were exactly equal to each other, known as equality, you could put two equal signs. Now there's also the converse of this, which is saying that one item is not the equivalent to the other, and that's done with the exclamation point and an equal sign. So this means that final score is not equivalent to high score. So all of those operators work with the primitive variable types. And again, those are integers, booleans, longs, doubles, etc. Specifically, if you are going to be comparing the equivalence of strings, you can't use the double equal sign. So let me set this up really quick. In this example, I've created two strings, existing passenger, which is set to Mike Kelly, and a new passenger, which is set to John Smith, and then I want to compare the two. So recall that a string is not a primitive type. It's actually an object. And when Java creates string objects, it puts each string into a stack and then takes note of the memory location where that object is located. Now, in some cases, when you create a string with a value and then create another string with the same value, in other words, if new passenger was also equal to Mike Kelly, Java may point these two variables to the same memory location. However, there are other instances when even though they contain the same value, Java builds separate string objects and thus they point to different memory locations. Now I go through all that because the double equal sign, when it pertains to strings, will compare the memory location of the strings as opposed to the value in the strings. So this double equal sign can produce unpredictable results. When you're comparing strings, in order to compare the value in the string, we use a method called equals, and then put what you're comparing to inside of parens. So this is saying, is the value of existing passenger equal to the value of new passenger? So dot equals is the operator we want to use anytime that you're comparing strings. So that covers all the different operators that are available to us. We'll be using a variety of these as we finish up the methods in the database class. In this video, we will combine an enhanced for loop with an if condition that allows us to add new passengers to our database. We already have the ability to create a passenger in the database class. However, when we try to add a passenger, we do not want to add a passenger that already exists. So I would like to modify that method to perform that check. Now, addPassenger currently takes a string of the passenger name. It then creates a new passenger object and adds it to the passenger's array list. Instead of just blindly doing that, let's loop through all of the existing passengers in the array list and see if that passenger exists. Now, one of the ways I would like to improve this method is when I send it a new passenger name, I would like to know whether or not it added that passenger. So I'm going to have it return a Boolean which contains the value of true or false. So instead of having the method return void or nothing, let's have it return Boolean. Now changing this is going to break any tests on this method that you already have. And that's okay, because we're going to rewrite these tests in a little bit. So now let's declare this Boolean variable and then return it at the end of the method. We'll declare the variable type, and I want to call it passenger exists. And initially, I'm going to set it to a value of false. So essentially, I'm assuming when I send it a new passenger name that the passenger doesn't exist, and I'm going to add it to my database. Now, when all this is over, I want to return the value in passenger exists. Knowing that we have this array list called passengers, let's loop through it and see if the passenger name is in that array list anywhere. We already did this once in the Scrapbook, so it should be pretty familiar to you. We'll create a for loop, and the objects we're looping through will be of type passenger, and within the loop, each object that we loop through will give the name item. Now we have to supply the for loop with that passenger array list, and we can do so by calling the method getPassengers. So now let's create the loop, and for every item within our array list, we want to see if the passenger name is equal to the name that we're passing in. So this is where we will nest our if statement. And what we are comparing is this passenger name, and we will check if it has equality to, which we do with the dot equals method, and we're going to compare it to the item, which is a passenger object, and we'll call the getName method on that object. So if that comes back true, in other words, the passenger we're trying to create already exists, then we want to set this variable to a value of true. So we'll simply change passenger exists to a value of true. Now, once we've looked at every passenger, we then can make the decision on whether or not we are going to add that new passenger. So what we'll do is we'll only add it if this value is false. In other words, if the passenger doesn't already exist. So let's add another if statement, and we'll say passenger exists equals false. Then if it's false, we'll add our new passenger. Otherwise, we won't do anything, and we'll just return this passenger exists equals true. So let's just review this one more time. When I call addPassenger in my database and pass it a string like Mike Kelly, I'm first going to assume that Mike Kelly doesn't exist. Then I'm going to look through all of my existing passengers and see if the name on any of those items is equal to Mike Kelly. If I find one, I'm going to change passenger exists equal to true. Then after I've looked through all of my passengers, if I didn't find a Mike Kelly, then I'll add Mike Kelly as a new passenger. Otherwise, I'll skip this and just return a value of false back to the method that called this. Now, this all looks good so far, but we'll want to test this to make sure it's all correct, and we'll do that in our next video. In the previous video, we modified our addPassengers method to check for existing passengers. Now we will write a test to see if it works. Our current test adds a new passenger, but is not expecting the return value that we added to the method. Technically, it still works, even though it just throws away the return value. So if I run our existing database test, it does come back successful. What we need to do is write a test that checks both conditions of our if statement to ensure all branches of our code work. So let's just add another test right underneath this one. We'll start it with @test, and it will be a public method returning void, and we'll call it test add new passenger. So just like our previous test, we'll need to create a new database and then add a new passenger. I'll call the new database testdb6, and instead of just calling addPassenger, I know that it's now going to return a Boolean. So let's set the calling of this method equal to a new Boolean variable, and I'll call it result1. So now result1 will be the result of calling this method, and it will contain a value of true or false. Now with a brand new database, when I add a new passenger called Mike Kelly, the result should be false, meaning that the passenger didn't already exist. So let's write that test. We'll say assert equals, and we're comparing a Boolean of false, and since that's not a string, it's not in quotes, and we're comparing that to result1. Now when we add the passenger, we're adding it to our new database, which is testdb6. So that's one branch of our code, adding a passenger that doesn't exist. Now let's test the other branch, which is adding a passenger that does exist. So if I attempt to add Mike Kelly again, the result should be true, meaning that the passenger does already exist. So let's just repeat this with new variable names. So this will be result2. We'll add a new passenger to our database with the same name. And now we should get back a true value for result2. Now I'd like to test this one piece at a time. So let's comment out this second part of the test and only test the first part. A nifty little trick in Eclipse that you can use is just select multiple lines of code and then use a Control or Command / to put in comments in front of each line. So I just want to check this first passenger, and it should come back with a result of false, meaning the passenger didn't exist already. Let's change it to true so that the test fails. That way we know that we haven't written a test that always passes. So that works. Now let's set it to false, and the test should pass the way we intend it to. Looks good. Now we'll test this second part. Again, Control or Command / will get rid of the comments. Let's set it to false so that it fails. Rerun the test. We get a failing test, and now change it back to true, and everything should pass. So now we've completed our addPassenger method to our database. We've extended it so that it checks to see if a passenger already exists when we try and add it. And we have a set of tests to ensure that our code is correct. In this video, we will get closer to finishing our database by writing the addTicket method. addTicket will eventually be called from some kind of form on our screen once we have all the information we need to book a reservation. That includes the departure date, passenger, flight, and seat. The form from which all that information comes can be one of several things. It can be the console, a web page, a desktop application, or a smartphone application. That means that we want to make the inputs that we pass to the method as simple as possible so that we don't need to change the method if we switch the front end of our application. So let's go ahead and start writing the method. I'm going to set the signature of the method to look like this, and I'm going to do a lot of copying and pasting just to speed things up. So it starts out as a public method. It's going to return a string value, which I'll talk about in a moment. The method name is addTicket, and then it takes 3 parameters, a date for the departure date, a string, which is the passenger name, and then 2 integers, one for the flight number and the seat number. Now I want the ticket to return a string that summarizes all the info for that reservation. If you remember, the toString method in our ticket class does exactly that. Now you can see we have an error here, and that is that our database class doesn't know what the local date type is. And that's just because we need to import the Java time library. So I'll do that with Quick Fix, and it will put that up at the top of our database class. We then need the method to take these inputs and create a ticket. Now the problem is that if you look at the constructor for a new ticket, the flight, passenger, and seat fields are all objects, which need to come from one of the items in each of the array lists in our database. So for each object, we need to take the input, search through the array list, and find the object that matches our input. We just did this with the addPassenger method, so the principle is pretty straightforward. Let me show you what we'll do first for passenger. So we'll initialize a passenger object and call it ticket passenger. That's the passenger that I'm adding to this ticket. Now I'm not going to create a new passenger object because I'm going to get it through our for loop as we look through the array list. So I'm just going to initialize it by setting it to null, which means an empty object. Then just like we did for addPassengers, we'll set up a for loop that looks through all of our passengers in the array list, compares the name of each one to our input, and then when it finds it, it sets the ticket passenger object to that item in the loop. So nothing really new there. Why don't I just add a comment so we know what's happening? Now we're basically going to do the exact same thing for flights and for seats. So let me paste in that logic. And as you can see, it's exactly the same as what we did with the passenger. We look through the list of flights and set the ticket flight object to the item we find, and then the same thing with seats. So now let's assemble a ticket. We'll create a temporary ticket object, add everything to it, and then add the ticket to the ticket array list with the other tickets. And that will look something like this. So we create a new ticket object. We are going to call it temp ticket because once we add it to the array list, it doesn't really have any specific identification. Then we just call the methods of our ticket class and add our date, our passenger object, our flight object, and our seat object to the ticket. Then we add that ticket object to the tickets array list. And you recall that that's just part of our database, just like passengers, flights, and seats. So now we've just added a new ticket to the database. And the last thing we'll do is return out of the method by calling the toString method. If I look back at Ticket, I can see that toString returns a nice summary of the ticket. It says ticket followed by the passenger name is departing on a specific flight from the departure to the destination on a specific date and what seat you're sitting in. So this is basically the report that shows up on your ticket. So now let's give it a try. I'm going to do this in the Scrapbook, but you could write a unit test that does something very similar. First, we will create a database and add the standard flights and seats to it by using the Bootstrap method. So we'll create this new database called testDB, and then we will run the Bootstrap method from our database class. And as you'll recall, that just adds 6 seats and 4 flights to the database. Now let's add a passenger. So I'll add myself as a new passenger. And finally, we'll call our addTicket method and set the return value to a variable called result. So we'll create a string called result. We'll call our addTicket method, and we'll send it the current date as our departure date, myself as a passenger. We'll book flight 1000 and seat number 1. And then I just want to print out the result to see if the toString method looks correct. So let's make sure that everything is saved, and we'll give it a try. And there's the result of our toString method. We've added the ticket, Mike Kelly departing on flight 1000. Here's our flight information, the departure date, and our seat. So now we have this ticket in our tickets array list. We can add additional tickets as passengers book new reservations. This was a pretty long method, but if you go back and review it carefully, you will find that it is mostly a review of things we have already done. In this video, we will write the final method for our database class, which tells us which seats are available on a given flight. In order to get a list of open seats, we need to look through a list of tickets for a given flight. The method we create will therefore need the flight and date as inputs, and return an array of seats that are still available on that flight. Let's create the new method in our database class, and I'll do some copying and pasting just to keep things moving along. First, here's what the signature of the method is going to look like. So the method will return a list of available seats as an array list, and it will take as inputs the date of the flight and the flight number. Now the way we are going to solve this is to first create a list of all seats on the airplane. This can be done by just creating a copy of the seats array list. And so we'll do that like this. We'll create a new variable of type ArrayList made up of seats. I'll call the ArrayList OpenSeats, and I will just call the getSeats method from our seat class. So that will return seats 1 through 6 as an array list. That's every seat that exists on the airplane. Then, using some for loops and some if conditions, I will look through all the tickets, and for any ticket that is for the day and flight I am trying to book, I will remove the booked seat on that ticket from my list of open seats. This is very similar to what we've been doing in our other methods. So we'll do it with a for loop. We'll look through every ticket in the database, and if the departure date equals the departure date we're sending, and the flight number equals the flight number that we're sending, then remove that seat from our array list of open seats. Now the only thing that's new here are these two and symbols. So this is how you say and in a condition. It just simply means that this and this must be true. So by the time we look through all of our tickets and remove any seats that are booked, the open seats array is simply a list of remaining seats that are available. Now, a database would be really good at doing that without having to look through every single ticket. But since we are relying on ArrayLists for this course, this works just fine, and with any modern computer, it is still really fast. So finally, we need to return the ArrayList containing the list of remaining seats that weren't taken by other tickets. And we'll do that by simply saying return openSeats. Now, although I am returning an ArrayList, if I refer to openSeats directly, it will use the toString method for the seat class to represent each object as a string. So let's try this out using the Scrapbook. This is what we did when we added a new ticket. So first, we'll create a new database, and then we'll book a ticket for Mike Kelly on Flight 1000 using seat 1. Now let's run the getOpenSeats method to see what seats are remaining. So I'll create a new variable of type ArrayList made up of seats. I'll call it seats remaining, and I'll call the method getOpenSeats for today's date on Flight 1000. So the only ticket that meets this criteria should be this one. Therefore, our remaining seats should be seats 2 through 6. Well, let's save everything and give it a try. So there's the result of booking our ticket, which we saw earlier. And here is the array that gets returned when we ran getOpenSeats. So we took seat 1 when we made our first reservation, and now that leaves seats 2 through 6 remaining. So before we book a ticket, we will make sure to call this method to let the user know from which seats they can pick. Well, that completes our database class. If you didn't follow along, I have included both the database class and the database test class in the working files. So far, we have created several layers in our application. We created data classes such as flight and seat, and then we created a data access layer called database. This allows us to switch out our storage method from using ArrayLists to something else like writing files or using a database without having to rewrite any of our data classes. Now it's time to add the final layer to our reservation application, which is the user front end. Once you have mastered the basics of Java, you can take additional courses that specialize on the different user experiences, such as mobile apps, web apps, or desktop apps. Each of those are entire courses on their own. So for this course, we will simply use the console for our input and output. We will need a class that is dedicated to the flow of our application in the console. We will write it in such a way that we can switch it out later with a different user interface without having to rewrite any of the other parts of our application. So let's create a new class called console. We'll put it in our source folder by saying new class, and we'll call it console. I mentioned in the very beginning of the course that somewhere in one of the many classes that you write, you must have a method called main. The main method is the first method that runs when your application executes. So far, we have not created a main method in any of our classes. We are going to create it now in the console method. It has a special signature that Eclipse will create for us just by checking this. Finish and create the console class. Now initially, this looked very strange to us, but by now we should really understand what it is. It's a public method, which is static. Now, this is actually new. Static simply means that no other class can call this method. The main method is special in that way. But it doesn't return anything back, so the return type is void. The method is simply called main, and it takes an input of an array of strings, which we call args. That stands for arguments, so this is just a variable name. And its type is just an array of strings. What that means is when you execute your Java application, you can pass in a bunch of different strings at the time that you execute it, and those get passed directly into the application. Think of the main method as the main loop of your application. It typically does contain a loop because when your application gets to the end of the main method, it terminates. So we generally create a loop that executes over and over again until the user exits the application. Let's outline what we want the loop to do in terms of input and output. Since we should comment the method, let's use our comments as an outline. So the very first thing that we need the main method to do is to create a new database. So I'll just put a comment in here that says initialize database. Then we will initialize our console. Now this is no different than what we've done in all of our other classes. It will just contain a number of fields and their initial values that are used by the console. At that point, we are then ready to start some kind of loop. So the first thing the loop will do is ask for our passenger name. And if that passenger doesn't exist, then we will add it to the database. You're probably recalling the method that we wrote earlier that will do this for us. Then we'll show a list of flights and ask for the flight they want to book. After that, given the flight that they want to book, we'll show the available seats, assuming they want to fly today, and we'll ask them to tell us what seat they want. Then with all that information, we'll create a new ticket and return all the information about that ticket. Then we'll just start again, and that will allow us to create a new passenger, flight, etc. So this loop will just create tickets over and over again until we exit the application. So that's the outline of our main method. We'll fill these in from top to bottom, starting with the next video. In this video, we will fill out the structure of the main method loop of our console class. So the first thing that we created in our outline is to initialize the database. And this we have done many times before in our different unit tests and methods. So it involves creating a new database object. It'll be of type database. We'll give it a name, and since this is our real application, let's call it prod.db for our production database. We'll set it equal to a new database object. Then once we have a new database, we want to add all of the seats and default flights that we have for our system. We can do that by calling the bootstrap method of our database object. So we'll say prod.db.bootstrap. And so now we have the database that we will use while our application is running. Well, now let's look at initializing the console. There are several variables that we will need to initialize. And I'll add to this list as we go through each item here in our outline. But the first thing we need to initialize is the variable that will begin our loop. I'm going to be using a while loop, which, if you'll recall, is used most often when you don't know how many times you'll be going through the loop. Since our application will stay in the loop as long as we keep the application running, the while loop is the best candidate for that. So let me create a variable for the beginning condition of the loop. I'm going to use a Boolean, and I'm going to call it always. I'll set it equal to true. And so I'll create a while loop that checks to ensure that always is equal to true. Essentially, I'm never going to change always to false, so that will keep us in this loop forever. So let's create the basic structure for that loop. I'll start out with the word while. I'll put my condition in here, the longhand being always followed by two equal signs and the word true, but let's use the shorthand, which is just specifying the name of the variable. So this is shorthand for if the always variable contains anything at all, then this comes back true. Then we'll begin our loop, and we'll end it where we said we're going to repeat. Okay, now let's tackle a little bit of this first item, which is to ask for the passenger name. Now, since all of these are inside of the while loop, let's select them all and press Tab so that they all indent. So to ask for the passenger, I simply want our console to print out some text. Maybe we want it to simply say, enter passenger. Well, we've done this a ton of times. We just use our system out println command and just put the prompt that you want to show up in the console. So maybe I'll have it look something like that. Now we'll talk about the adding part a little bit later. So this is the beginning of our loop. Now if we run it like this, it will just print out enter passenger over and over again, because it will just go back and forth throughout this loop. So for testing purposes, let's actually tell the loop to end. And we'll do that just by setting the always variable to false. That will make this condition false, and it simply will exit the loop. Okay, let's save it and give it a whirl. Now in Eclipse, our console is just going to be down here. If you were running this outside of Eclipse, it would show up in a command prompt. But let's just run it from right inside of Eclipse. We'll just right-click on our console class, come down to Run As, and because this class contains a main method, we can run it as a Java application. So I'll choose that, and there's our result. Our database initialized, then it went into the loop, and it printed out our first prompt to enter a passenger name. Well, in the next video, we'll learn how to take whatever we type in here and then use that to add a new passenger. In this video, we will continue working on our console class by creating a new passenger from the name that we type on the screen. As we discussed earlier, you will eventually choose the user experience that you want to focus on as a developer. Although we are using the console for our input, I won't be covering every detail of how it works. When you are working with input, whether that is from a user, a file, or otherwise, we put all of that information into an object called a buffered reader. Think of it as a bucket where we will toss information as we receive it. To set this up, we need to initialize a buffered reader object by creating a new one. So we'll do it right here in our initialization section. We initialize it just like we do when we create any type of object. We specify the type, which is buffered reader. We give the object a name, and I'll call it screen input, and then we set it equal to a new buffered reader object. Now the buffered reader needs to know where the information is going to come from that it's going to store. For us, that is going to come from another type of object called an input stream reader. So we'll create a new input stream reader object inside of the buffered reader. So an input stream reader just reads one character at a time, versus a file reader, which can read an entire file at a time. So finally, we need to tell the input stream reader where its information is coming from, and that will come from system.in. Now this should feel a little bit familiar to you, because whenever we use system.out.println, we're printing a piece of information to our console. So system.in is just getting information from the console. If this were a file reader, this would be the name of the file that we're reading. So we're getting information from our console, sending it through the input stream reader, which basically just converts everything to characters, and then it's sending all of that to the buffered reader that we're calling screen input. Well, now that we have this bucket set up, we're ready then to receive a piece of input from the console. And we'll do that right after we print the prompt of enter passenger to our screen. So right below this, whatever we type in the console, we want to assign to a string. So we'll create a new string variable that I'll call passenger name, and we'll set that equal to screen input, which is again what we're receiving from our console, and we'll execute a method called readLine. So essentially what's happening now is we're printing out our prompt to the screen, and then this command is basically saying just sit and wait till someone types something on the console and presses their enter key. That's the line that it's going to read. Now we have a passenger name. We want to check if that's an existing passenger or whether we need to create a new one. Now we've done that before by just calling the addPassenger method in the database class. And that's what we will do next, so let me just paste that in. We will call the addPassenger method on our prod database, and depending on whether that was an existing passenger or it adds a new passenger, it just returns a value of true or false. Now I'd like to let the end user know what it found. In other words, if you're an existing passenger, I'd like it to respond back by saying welcome back, followed by your name. Whereas if you're a new passenger, I'd like it to say welcome followed by your name. We can do that with an if statement. I'll save us a little bit of typing here. And so it says if result equals true, that's the shorthand for just saying result, that means you're an existing passenger. So we'll just print a line out to the console that says welcome back followed by the name that you typed in. Otherwise, it should just print out welcome followed by your passenger name. And of course, in between those, we'll put an else. So now we've accepted the passenger name from the console. Now there's a few things we need to do before we can test this. Number one, input stream reader needs to be imported into our class, so we'll do that with quick fix. And then that results with one more error here on the screen input. Now this is a little bit more complicated to fix, so I'll explain it in more detail in the next video. In this video, we will learn how to handle exceptions, or minor errors, in our application. If you've been a computer user for more than, say, a month, you have probably experienced some kind of system crash. On a Windows machine, we call it the blue screen of death. Macs and Linux machines have something similar. Usually, those kinds of errors occur when something very major has happened to your system, like a hardware failure. As programmers, unfortunately, we have the power to cause similar crashes by simply writing bad code. Let me give you an unlikely but graphic scenario. Let's say you ask a user for input in the form of an integer, but instead the user supplies a string. A well-written application will catch that and either tell the user to try again or give the user an understandable error message and stop the application. Whereas a poorly written application will just go ahead and throw the string into an int variable, causing your application to halt, and your user will see some ugly error. You get the error because the Java virtual machine is looking for application errors and caught the one that you didn't catch. Now, if the JVM doesn't recognize why your application crashed, it could also crash and bring down all of the other running Java applications with it. Then your operating system will see that the JVM crashed, and if it can't figure out why, then it could crash, and that's where you get the blue screen of death. I say all this because calling certain Java methods is known to be risky. Anything that accepts user input falls into this category. So the writers of the actual readline method added instructions that require you to check for what we call an exception before actually acting on the result of the method call. If you don't perform this check, the Java compiler won't agree to even compile your class, which will in turn keep it from ever running. The way we perform this check is by creating what is called a try-catch block. It feels a lot like an if-then-else statement. Now, as you can see, Eclipse can actually write this for you by using quick fix. So let's do that here. What it's done is it's taken our original call to readline and it's put it inside of this try-catch block. So this is kind of like dipping your toe in the water to see if it's cold. You're telling Java, instead of just blindly taking the screen input and assigning it to the passenger name variable, try it out first and see if it returns some kind of exception. An exception is just a minor error. Then, if it does throw an exception, assign it to a variable called e, and then do something. Now, by default, Eclipse will just print what is called the stack trace. And that's just a list of everything that was going on when this exception occurred. What we could do instead is just have it print out a nice friendly error message to the console. Something like this maybe. Sorry, I don't understand, and just send it down to the console. Now, if it does throw this exception, it will print this out, and then your Java application will quit. You could get really fancy and put this try-catch block inside of a while loop. And that way it will let you try again by entering another passenger name, and it will see if that causes an error. But we won't go that far here. So we're almost there. Now we are safely checking our screen input. However, what's happening here is that the passenger name is being set inside of a code block. And remembering that rule, you can't take it with you. That means that passenger name won't be accessible outside of this block. In fact, we're attempting to do that later on, and we're getting the error now that says that this variable hasn't been initialized anywhere. So we can have QuickFix do that for us. Now what it will do is it will set it to null, and it will initialize it right above the loop where it's located. And that will work fine, but I've got this whole section here where I'm initializing everything. And I would kind of like to keep all my initialization commands together. So let me just move it up here. Again, both will work, but I think this is a little bit easier to read. I'm not seeing any errors, so let's save this, and now we can give it a try. I'll go ahead and run it. It asks me to enter a passenger, so I'll enter myself, and it responds by saying, "Welcome, Mike Kelly." In other words, I'm a new passenger. Now I'm telling my loop to stop here by setting always to false. Let's remove that so that the loop will execute indefinitely. I'll clear my console and run this again. So we'll enter a passenger, I'll put myself in, and it says, "Welcome, Mike Kelly." Then it says, "Enter another passenger." Well, if I put myself in again, I should be an existing passenger, which you can see it knows because now it says, "Welcome back, Mike Kelly." And if I put in a new passenger, like John Smith, it goes back and says, "Welcome, John Smith," because John is a new passenger. So we've learned how to correctly and safely ask for input from the console. We can now apply this pattern for the remaining inputs that we need for our ticket, and we'll do that in the next video. At this point, we can ask for a passenger and add them to our database. Now we need to do the same thing for our flight number. Everything we need to do we have already done before, so let me save some typing time and paste this in. So we're going to start out by just printing a line to our console that says, "Here are the available flights." The \n just prints a blank line before we print everything here. Then I would like to list all of the available flights in our database. Remember, we only added the flights once because the same flights occur every day. And we have a method in our database class called getFlights that will return our array list of flights. This for loop will then take that array list and print out every flight to our console. By referring to each flight object, which we're calling item inside of the loop, it will automatically execute the toString method for that object. So that will give us a list of flights on our console. Then we prompt the user to enter a flight number to book. Now, just like with the passenger name, getting input from our screen is risky, so we're going to put that inside of a try-catch block. It will take our input and assign it to a variable called flight number, and if there's an exception, it will print out this error. Now, just like with the passenger name, we need to initialize the flight number variable. So let's put that up here at the top. It's an integer, and where we set strings to null when we initialize them, we'll set integers to the number 0. Well, let's save this and give it a try. It starts out by asking us for our passenger. I'll enter a new passenger. Give us a little more space here. It's a new passenger, so it says, "Welcome, Mike Kelly." It prints that blank line from the \n, and then it says, "Here are the available flights," and then it loops through all of the flights in the array list, executing the toString method on each one. Then it says, "Enter the flight number to book." So here it's just asking for more input. So I'll enter 1000, press enter, and then it loops all the way back to the beginning again, because there's just nothing else for it to do. So far, so good. Now let me show you a little hidden landmine that's waiting for us. The first thing I'll mention is that anytime you take input from the console, it comes in as a string. So this integer.parseInt method takes the string and it converts it to an integer, which is the variable type of flight number. Now this is specific for console input, so I'm not going into a whole bunch of detail about it. But here's where the landmine is. If I hover over this, I can see that parseInt will throw a numeric format exception. Now that's the same thing we saw earlier with readline, which throws an IO exception. Meaning you need to check for a numeric format exception, or else this wouldn't compile. Now the issue arises because right above this we have a try-catch block. And so Java assumes that we're checking for this exception. But really all we're checking for now is the IO exception. So if we catch an IO exception, we're in good shape. We'll get a nice friendly error message. But if we happen to throw a numeric format exception, we're not going to catch it, and we're going to get a JVM error instead of our nice friendly error message. In fact, let me show you what that looks like. So just beginning our loop again, I'll put in a passenger. And then when I say enter the flight number to book, let me put in my name, which is a string. When integer.parseInt tries to turn this into an integer, it can't, and our application crashes, giving us this error. So now you can see why it is so critical to handle exceptions properly. Now the nice thing about try-catch blocks is you can look for as many different types of exceptions as you want to. You just add additional catch blocks one after another. So right after this one, I can just put another one which looks for a numeric format exception. And if it catches that, it'll give me an error that says that wasn't a number. So let's try this one more time. I'll save it before it runs, put in my passenger, which it creates, asks me for the flight number. I'll put in a string, and it gives me the error. And because this is in a loop, it just starts all over again, asking me for the passenger again. Now we could put a fancy loop around this try-catch block, but this one's working just fine. So now we have our flight all set up. All we need to do now is get our seat figured out, which we'll do in the next video. In this video, we will get our last input from the user, which is the seat number. This is identical to what we did with flight, so let me paste in the code here. Let's take a look. So we start out with a couple of console prompts. The first one says, assuming you are flying today, then on the next line it says, here are the available seats on that flight. What I'm doing here is I'm going to be assigning the departure date to today's date. That's just to make things easier for us. When we learned about dates, we learned how to parse a string into an actual date. And I'm just going to avoid that here to make things easier for us. As extra credit, you may want to take input from the user and then convert that into the departure date. Then, given that we've already asked for the flight and we know what date they're leaving on, we can execute the getOpenSeats method, pass in those two variables, and get a list of open seats back. Once I get that back as an array, I'll just loop through the array and print out each seat, separating it with a comma. Then, as we've been doing, we'll prompt the user to enter the seat number, and then we'll read that seat number from the console. Now this is the first time that we've used an ArrayList type, so as we've done with other classes, we'll use QuickFix to import that up at the top. Then we have two new variables that we haven't declared yet, and those are departure date and seat number. So let me go back up to the top where we are initializing everything, and we'll just initialize those two variables. So here's the local date set to today's date, by executing the now method. And again, this is the first time that we're using the local date type, so let's import it. And here's our seat number. Because it's an integer, I'm initializing it to 0. So just to run right up to the top here, here's where Eclipse imported the local date library and the ArrayList library. Okay, let's save it and give it a try. Enter a new passenger. Here's our flights. Let's book flight 1000. And here's our seat information. Assuming you are flying today, here are the available seats on that flight. Gives us a list. We could do a little fancy logic and get rid of the last comma if we wanted to add that in, and then it asks for the seat that we want. So maybe I'll book seat 1. And then it starts all over again. Okay, so that's all of the user input that we need before we can book a ticket. So in the next video, we'll create the ticket object based on all the user input and then see how everything looks. Now that we have all the input we need from the user, we can create a ticket object. Back in our database class, we have a nice way of doing that with the addTicket method. This method was written in such a way that we only need to supply it with strings, dates, and numbers, and it takes care of the rest. So in our console method, we don't have to worry about all the lookups and loops to hook it all together. If later we decide to build an HTML form instead of using the console, that form can submit the same simple information and the database will do the heavy lifting. Looking at the addTicket signature, we can see the inputs it needs, which we just collected from the user, and it will return a string, which is the result of the toString method on the ticket it creates. So creating the ticket will just be a one-liner. We'll set up a string variable, call it ticketinfo, and set it equal to the result of calling addTicket on our prod database, and then supply it with all the variables that we just collected from the user. Now we just need to print out the ticket. Let's do it this way. We'll print out a new line saying your reservation was successful, here are your details, and then we'll just print out the ticket info that was returned when we created that ticket. We'll follow that with a blank line because now it's going to loop back again and start the process all over by asking for a new passenger. So piece of cake. Well, let's give our reservation system a try. We'll run our console class, and just to give us some room, I'll double click here on the tab so that it runs in full screen. So our new passenger will be myself. It welcomes me, meaning it's a new passenger. Let's take flight 1000. Here are all the seats that are available. I think I like seat 2. And there's the reservation. Here's our details, the ticket, Mike Kelly departing on flight 1000 with the departure and arrival, the date, and the seat I'm in. Then it starts all over again. Well, let's add another passenger. Let's book him on the same flight as Mike, and you'll notice that seat 2 isn't available. That's because, of course, Mike is taking that seat, so John will have to pick something else. And there's John's ticket. There we go. We have a working application. I'd encourage you to add any polish you think it could use. And if you play with it enough, you may even find a hidden bug or two. But you know a lot of Java now, so see if you can figure out how to make the changes you need. This is a big milestone in the course, but there is a lot left to learn, so pat yourself on the back and let's carry on. In this video, we will package up our application so that it can run on its own. Once you have finished writing your application, you can deploy it to run on any device that has a Java virtual machine installed. If your application has more than one source file, you need to bundle it together into what is called a jar file, which stands for Java Archive. For our application, we have all of the classes we created under the source directory, as well as several core Java libraries, such as the Java Utilities and Java Time libraries. Because we installed the Java Developers Kit, we have access to every Java library, but those take up a lot of space. So a jar file only contains the libraries that our application uses. Building a jar file can get very involved when you're creating complex applications. But ours is pretty straightforward, so we can just use the stock tools in Eclipse to create our jar file. To get started, we can just go up to the File menu and say Export. To export our application as a jar file, you just open the Java folder, and you have your choice between a standard jar file and a runnable jar file. The difference is that a standard jar file just contains all of the different Java classes and libraries that your application needs. You'll recall that in order to run your application, you need to specify which class contains the main method. And if you package up your application into a standard jar file, you will need to specify that path when you execute the file. So that will include a fairly lengthy command that not only includes the package name, but also the class containing your main method. Now this can be convenient if you have multiple classes that have main methods and you want the flexibility of being able to start your application using either one. However, in our case, we always want to start our application by running the console class, because that's where our only main method exists. So creating a runnable jar file will do just that. It will include some extra files that instruct the Java virtual machine where the package, class, and main method resides. So let's choose that. And I'll choose Next. And the first thing we do is specify our launch configuration. Now what it's done is it has looked through all of our classes and it's found two files that have a main method, demo, which we created at the very beginning of the course, just to illustrate how Java works, and our console class, which is the one that we want. So we'll choose that, and that will tell our jar file to execute main inside of the console class. Then we just say where we want the jar file to go. So let me put it in a simple path since I'm going to be using my terminal to execute it. I'll just put it on my local C drive under my home directory. Then I just give my jar file a name. I'll call it reservations, but you can call it anything, and click Save. And then finally click Finish. Now what this is saying is that our application uses libraries in addition to these that we wrote ourselves. Some of those libraries may have copyright or licensing issues that come along with them. So it's just reminding you of that. All of our libraries are open source through Java. So we can just continue on. And now we have a jar file. So this will allow us to run our application anywhere that we have a Java runtime environment. I'll just open up my user folder to ensure that the file is there. Again, I put it under my C drive, under my home directory, and there's our reservations.jar file. So now we're ready to run the file anywhere that we like. Any device that has the Java runtime environment installed can execute your application after it has been packaged into a jar file. Our application was designed to run in the console, so all I need to do is open up a terminal. This is my Windows machine, and my Windows command line terminal is open and pointing to my user directory. If I look inside, I can see my reservations.jar file that I built earlier. To run the file, I just execute the Java command, followed by the -jar parameter, which says I'm going to run a jar file, followed by the full name of the file, which is reservations.jar. I press enter, and I'm on my way. It looks exactly like it did in Eclipse, but now it's running in my console. So just as I did before, we can just try it out really quick, put in my name, my flight, my seat, and it books a ticket. So this is running under the minimal Java environment known as the Java runtime environment. All it contains is a Java virtual machine. Now, the promise of Java since the very beginning was the concept of write once, run anywhere, meaning you create your Java application one time, package it up into a jar file, and with no further modification, that jar file should run on any device with a JVM. Well, let's take advantage of some cloud storage and virtual machine technology to see if that's the case. So here is an Ubuntu machine running Linux. I've downloaded the jar file that I was running on my Windows machine. You can see it right here. So let's try and run it. Once again, java-jar space reservations.jar. And there it is, running once again. It works just like it did on my Windows machine. Let's try it again. How about on an OS X machine? Again, I've downloaded the jar file. So I just say java-jar reservations, and there it is. So as you can see, Java lives up to its promise. With one jar file, I was able to run it without any modifications on 3 different operating systems. So this could have included anything else, like a smartphone that's capable of running Java, your tablet, or any other device. In this lesson, we will introduce the concept of inheritance by creating a subclass. The idea behind inheritance is that once a class has been created and tested, you don't want to introduce changes that may affect that existing functionality. So instead of modifying that class, you create a new class that extends the original with new fields and methods that you want to add. This new class is called a subclass. Because the two are related, any objects that you create from the subclass will inherit all of the fields and methods of its parent, or the superclass, but it will receive all of the new fields and methods that are part of the subclass. Because the superclass has not changed, objects created from that class will continue to function as they always have. This is a popular way to refactor your application, because if done correctly, it will not break any existing code or tests. Let's look at an example. Because we only owned one airplane, our flight class only contained the flight number and arrival and departure cities. This allowed us to put the departure date on the ticket because our airline flew the same flights every day. Well, because our business has been so successful, we've been able to purchase a second airplane that we will dedicate to charter flights, where the customer determines the date, time, and destinations of each flight. One way of solving this would be to add a date-time field and a flight type field to our flight class. Then when we create a flight object, we would set the type to regular or charter and enter the date and time of the flight. But this would probably break our application in several places. A better way to handle this is to create a charter subclass and just add what we need, keeping the original functionality of the flight class intact. So let's do that. We'll right-click on our package and create a new class and call it Charter. Let me rearrange things a little bit here so it's easier to see. So here is our Charter class, which is going to become a subclass of Flight. So the first thing that we'll do to say that this is a subclass of Flight is in the class declaration, it starts out the same, public class charter, but we then say it extends the flight class. So that means when we create a new charter, we are going to get all of the fields and methods from the flight class available to us, and we don't have to redefine them here. All we have to do is define the new fields and methods that we want for a charter. So let's do this in the same format that we have the flight class in. I'll create some fields, and I still want the departure and arrival cities and the flight number, so I'll inherit those, and all I need is my new field, which is going to be the departure date time. So that will be a private field. It will be of the type local date time. Now we've used local date before. Local date time just allows you to also include a time along with the date. And we'll call this field departure date time. Okay, so we'll need to import this library, so we'll add it through Quick Fix. And that takes care of the additional field that we are going to add to our charter class. So now let's create the constructor. As with our flight constructor, it will be a public method. It will be called charter, which has to be the same name as the class. And our inputs into the constructor are going to be just like we do for flight when we want to send all of the different fields into the constructor at once. So it will include all of the flight parameters plus our new field. So I'll just copy these, put them here. So when I create a new charter, I'll be able to include the flight number, the departure city, and the arrival city, plus a string, which will be the departure date time. Even though these fields are not part of my class, since charter extends flight, I can use all of the fields that are part of my superclass. Now here's where things get a little bit interesting. In order to set these variables, which aren't part of my subclass, I need to actually call the constructor over here in the superclass. And the way I do that is with a command called super. And then I just send these variables as though I were calling it from a different method, which in fact I am. So I say flight number, departure city, and arrival city. So this will call this constructor of flight, and it will set all those variables using flight's set methods. All I have to do now is deal with this departure date time string that I'm sending in, and so I'll create a statement that sets that, which in the same format as these will just be set departure date time, and I'll set it to the string that I'm passing in. Well, we'll just wrap our constructor in a code block, and it's ready to go. All we have to do is create this setter method. We'll create setter and getter methods for this subclass in the next video. Previously, we created a charter subclass to extend the functionality of our flight class. In this video, we will continue building that class and learn how it works. So far, we've defined our subclass with a new field called departure date time. We also built a constructor that can accept 4 arguments, 3 of which come from the flight superclass, and the last of which is the new field that we created in the charter subclass. What we need now are the setter and getter methods for our subclass. We already have them for the fields that are part of flight, so all we need is a getter and a setter for our departure date time field. Let's use Eclipse to make those for us quickly. We'll just go into the source menu, say generate getters and setters. Here's the field that we see, and we want both a getter and a setter for that field. So the getter is fine, it's just going to return the value in the departure date time field. But the setter has a little bit of a problem, and that's because in our constructor, we're sending departure date time as a string, because it will be coming from some kind of a user input form. The setter that Eclipse created that parameter as a local date time variable, because that's what it looks like up here in the field. So let's just change this to string. And now this is a problem down here, because this is a string up here, and this is a local date time type down here. What we can do is we can take our input, which is a string, and convert it into a local date time type by using the parse method of the local date time class. So all we have to do is say local date time dot parse and then put our argument in parens. So now departure date time comes in as a string from our input screen. As it passes through the constructor, it will call setDepartureDateTime, pass in that string, and then in the set method, it receives that string and parses it back to a local datetime type. So now our subclass is ready to go. When we create new charter objects, they will have all the fields and methods available to them that the flight class does, plus they will have a new field and the 2 new getter and setter methods available to them. I'll show you how to do this by creating a unit test for our charter subclass. We'll do that in the next video. Previously, we finished writing our charter subclass. In this video, we will create a unit test, which will show us how to create new charter objects. Now, first of all, even though we created all this new functionality for our charter class, we haven't modified our flight class at all. In fact, I can run our entire test suite and see that everything still runs without any errors. Many of those tests had to do with the flight class. So everything having to do with flights still works just as it did before. All we've done is extended that functionality with new fields and methods that are part of our charter subclass. So I'd like to show you how to create charter objects, and although we could do that on our whiteboard, let's go ahead and just create a test. So I'll right-click on our package and create a new, go to Other, and make it a JUnit test case. Now, since we've already created the charter class, we can take advantage of that by putting it here in the class under test, and we'll give our test the name charter test. So Eclipse sets all that up, and it has our first test configured. All we have to do is write it now. So I'll just create a simple test that uses the constructor to create a new charter object, and then we'll see if some of the get methods work. Let me call this test charter. And the first thing we'll do is create a new charter object. It's just like any other class that we've used. We just start with the object type, give our object a name, I'll call it charter1 for our test, and we'll set it equal to a new charter. And using our constructor that allows us to pass in the flight number, departure city, arrival city, and departure date time, we'll pass all those in here. So we'll say that charter flights begin with 6,000, so flight 6010, which takes us from San Diego to San Francisco, and the departure date time is in a string, and it takes this format, year, month, day. So let's say that it's going to leave on June 15th, and then to add the time component, you just put a capital T and then the hours and minutes in a 24-hour format. So maybe we want to leave at 9:30 in the morning. That should be a comma there. So this is how we create new charter objects. So the constructor allows us to pass in 3 arguments that are part of the flight class, and then the 4th argument, which is part of our new charter subclass. Now, because charter extends flight, that means we should have all of the flight methods available to us as well as all of the charter methods. And so let's see if that's the case. Let me create a quick test, and I want to test the flight number. So I should get back 6010 as my test result, and I'll do that by calling charter1 dot, and notice all of the methods that are available to us in our charter1 object. Here's our get departure date time, which is the new one that we wrote, but notice all these others. Get departure city, get flight number, those are all the methods that were written as part of the flight class, but are now available to us in our charter class because charter is a subclass of flight. Now, every class is a subclass of the object class, and so any methods that are in the object class are also available to us. So that includes toString and all of these others that we haven't really worked with yet, but are in fact available to us. So I should be able to call this getFlightNumber method on my charter object, even though the method comes from flight. I should also be able to call my charter methods. So let's see if our departure date time returns this same string. So that's the value we are going to test against. And let me just paste in the method call here to save a little bit of time. So I'm going to call charter1 getDepartureDate. And since this is a string and getDepartureDate would return a local date time object, I'm going to convert that to a string as well. Okay, so we are calling methods from both the superclass and the subclass. And let's see if the test runs. I'll just right-click, run as a JUnit test, and it comes back successfully. So now you can see how you can create objects from your subclass and take advantage of the inheritance of all the fields and methods from the superclass. In this video, we will learn about a concept related to inheritance called overwriting. We know that by creating a charter object, we inherit all of the methods of the flight superclass. Sometimes, though, we want a method from the superclass to behave differently when it is called from the subclass. This is what we call overriding a method. Here's an example of a method before overriding. We know that the flight class has a method called toString, and it returns information about the flight, such as the flight number, departure city, and arrival city. Charter does not have a toString method, so if we call toString on a charter object, it will simply run flight's toString method. Let's see that in action by running it in our scrapbook. I'll just paste this in real quick. So I'm creating a new charter object, calling it trip1, and I'm passing in all of the arguments. Then I'll print out the result of trip1's toString method, which will actually be calling the method in the flight class. When I execute this, you can see we get the normal toString output that we've always seen out of flight. Unfortunately, though, it doesn't contain any of the information about the departure date or time. So the toString method would be a great candidate for overriding. Now, if you want to override a method in a subclass, you simply create a method by the same name as the method you are overriding. It also needs to contain the same return type and parameter list. So flight's toString method returns a string and doesn't contain any parameters. Now I want it to return something very similar to flight, but I just want to add some additional information. So why don't I just copy this and paste it into my charter class? And then at the end, I'll just add some additional information. So let me paste that in and clean it up a little. So it prints out everything it did before, but then I'm adding the information about the departure date and time. And as you can see, it takes the variable, which includes both the date and time, and I'm splitting it up by calling two methods that are part of the local date time class called toLocalDate and toLocalTime. So now let's try this again back in our scrapbook. I'll paste in a new set of commands. So this time, I'm creating a new flight object called trip1, and then a new charter object called trip2. Then I'll execute the toString methods of each one, and we should get a different result for each. So here is the return string for the toString method of flight, and here is the output from calling that same method in charter. So depending on your object type, the toString method works differently. Overriding is very common when you are creating subclasses that are almost the same as their superclass, but just need a little tweak to make them better. In this video, we will discover how to read data from a text file. Reading from files is very common, especially when you need to initialize a list of objects in your application. We hard-coded this before in our database class through the Bootstrap method. Let me show you an alternative to that by reading a list of objects from a text file. I'm not going to replace the Bootstrap method entirely, but I'll show you the basics of reading from files. When we built our console class, we took input from our screen by creating a buffered reader that read a stream from system.in, which is our console. Reading from a file is very similar, except we use a file reader instead of an input stream reader. And we replace system.in with the file from which we are going to read. I've included the import file called flights.csv in your working files. As you can see, I created a new source folder by just coming up to reservations and saying new source folder. And then you can just drag the flights.csv file from your desktop right into the folder. So let's go back to our database class and add a new method called bootstrap.csv, which will read our flights file. You may also want to consider applying what we learned in the inheritance chapter by subclassing the database class and overriding the bootstrap method with what we are about to do. I will leave that as an exercise for you to try on your own. Now there'll be a fair amount of typing here, so I'll copy and paste a lot of this to save some time. Here's the signature of the new method that we are going to create. Again, it's just called bootstrap.csv. Now the first thing that we'll do is we will initialize a new buffered reader and we'll call it flight import. So it's of the type buffered reader, and we just create a new buffered reader object, which also creates a new file reader object. Now inside of the file reader, we put our path to our import file, and that goes inside of quotes. Here's the path to mine, although yours may differ depending on where your project directory is. Now we need to import the buffered reader class that comes from Java IO, so I'll add that. And the same thing for file reader. So it just added those to the top of our class. Now as you can see here, file reader throws an exception because, as we discussed before, it's risky. For example, the file may not be where you're saying it is. So we need to surround it with a try-catch block. We'll just let Eclipse add that for us. And now if the file isn't where it says it is, it will just print out the stack trace. You can put in a fancy error message here if you want to. Now the other thing you want to do when you read a file is to close it when you are done, or you may end up with a bunch of open files. So after you open it, we'll add this close statement at the end. Everything that we are going to do with the file we'll put in between these two lines. Now notice that closing the file can also throw an exception, but this time it's an IO exception as opposed to a file not found exception. So we can handle that by adding another catch clause to our try-catch block. So now we can catch either problem. So now we want to read each line of the file and do something with it. Since we don't know how many lines there will be, a while loop will work best. So I'll put that right in between the open and the close, and it will look something like this. Now I'm doing something kind of fancy here. Normally with a while loop, you initialize some variable, you check if something is true, and then you're altering some kind of variable inside the loop. I'm doing that all at once right here inside of the condition. So I'm going to read a line from my text file, just like I read a line from my console. I'm going to set that equal to a variable called flightLine, and if it's not null, in other words, if there is a line in that file, then I want to do something. Now I do need to initialize this variable flightLine, so I'll just have Eclipse create a local variable for me right above it. Now I'm just going to do something very simple with each line of the text file, and that is I'm just going to print it back out onto the screen. This is just to show you that we are in fact reading a line from the file. So let me save this, and we'll just try it out right from our scrapbook. So by pasting this in, I'm creating a new database called testDB, and then I'm executing the bootstrap CSV method. That should read our file and print out each line of the file here in the console. Let's give it a try. So there we go. Here's every line that was inside of this flights.csv file. It read each line one at a time and then printed each line to our console. So these are the basics of reading lines from a file. We could go on and split each line up into parts and assign each part to a field in the flight object. I want to be careful though because there are very efficient libraries out there that are designed for importing CSV files. So I don't want to go down the path of coding it up manually. This lesson was more about showing you how to open and read a line from a file. In this video, we will learn how to write to files. If you understand how to read from a file, writing to a file is almost identical. Let's write a method in our database class to write all of our seats to a text file. I have the method where we read our flights right above so we can compare the two. I also created another source folder called export, which will hold our new file. So our new method will be public, it will return void, and I'll call it export seats. Now, just like we have a buffered reader to read input, we have a buffered writer for sending information somewhere. Let me paste this in and we can compare them. So just like we have a buffered reader, we begin by creating a new object called seatExport, which is of the type buffered writer. It constructs a new buffered writer object by also constructing a new file writer, just like we had a file reader up here. Inside the file writer, we have the path to the file we are creating. So I used the same path, except I'm putting it in the export directory, and I'm going to call the file seats.csv. Other than that, you can see how similar these two lines are. Now we will also need to import some libraries, so we'll import BufferedWriter and FileWriter. And then FileWriter can throw an exception, so we'll surround that with a try-catch block. So things are continuing to look very similar to how we read a file. Now I also want to close the file after I write it, so I'll put a seat export and call the close method here. And then everything in between is what we'll do as we're writing to the file. Now there are ways to close the file even if an exception is thrown, but we're not going to cover that here. We will want to write to the file by looping through all of the seats and writing them one at a time to our file. So as we've done many times before, we'll just create an enhanced for loop for that, and I'll just paste that in here. So we create the for loop. It will go through objects of type seat. For each one it loops through, we'll refer to the seat object as item, and we'll get our list of seats by calling the getSeats method. Now, for each seat that we are going to write to the file, we just call our BufferedWriter, which is seat export, followed by the write command. That's very similar to what we did here, where we called the BufferedReader and used the readLine command. So this will write each seat to the file, and then I'll follow it with a line break, which is signified here by the \n. Now, just to make sure everything works properly, once we close the file, let me paste in a command here which will just print a line out to our console that says that the export file was created. That's all there is to it. Let's save it and try it in our scrapbook. So I'll create a new database object. I'll run the bootstrap method, which will add those 6 seats to our database, and then I'll run the export seats method that we just created. And here we go. It created the file, as we can see, and now let's go take a look. Here's my projects directory, so I'll go into reservations. Here's my export directory, and there's the file it created. So I'll just open the file, and I'll just use WordPad to do that. And there they are, all 6 of my seats. So as you can see, writing to files is almost identical to reading from files. Once you've defined your BufferedWriter, all you have to do is create variables and write them to the file. In this video, we will get an introduction to the different application logging options that are available in Java. Logging is simply the ability for your application to send messages while it is running. For example, you may want to send a message to an end user that their credit card transaction was successful, or you may want to alert a server administrator that a new passenger was created. Detailed logging can also be helpful to developers if you start to receive unexplained errors and you want to debug them. One of the benefits of logging is that you can send different types of messages to different places. For example, end-user messages can go to their screen, server messages can be written to a file and archived, and debugging messages can go to the server console so a developer can see them in real time. Recording log messages can cause a performance hit on your application, and it can be difficult to find problems if you are flooding your logs with messages. So Java gives you the ability to assign each message a severity and then configure the logger to only send messages that meet or exceed the level of severity that you have turned on. The list on the left shows the different levels of logging that are available. Each location can be set to only receive messages at a certain log level or higher. For example, if you set your log level to info, you will only receive the messages that are at that level or above. The find messages will not get sent. However, if you need to debug the getOpenSeats method, you can temporarily set the log level to fine, and you will get all of those messages since they are at or above the set log level. Through the use of configuration files, you can change your log level while your application is running. This allows you to temporarily get debugging messages if there is a problem, and then set the level back to normal once you are done. In this video, we will learn how to use the default or global logger. Although you can configure logging to work differently for each class, there is default logging functionality already set up. This is called the global logger. The global logger is configured by default to send any log messages of the level info or above to the console. So the most basic way to send a log message is to send it to the global logger. For example, we may want to send one of the exceptions in our console class to log an error. We would do this like so. Right now, when we're asking the end user for a flight number, we check to see if the number that they input is in fact an integer. And if it isn't, it will throw this number format exception. Well, instead of just sending a system out print line to the console, we can send a log message instead. You refer to an object called the logger object. So after you refer to the logger object, you need to tell it which logger you are sending the message to. For us, that will be the global logger, and there's a really easy way to get the name of the global logger, which is by just executing a method called getGlobal. So you could provide the name of the global logger here, but it actually has a really long name, so this is a lot easier to do, and if that name happens to change, this will always return the correct name. So we know we're sending an error message to the global logger. Now we need to tell it the severity of the message that we're sending. Since this is not a fatal error, it's one that can be corrected, let's just make it a warning. And then finally, in parens, you send it the actual message that you want the user to see. This will be in quotes, since it's just going to be a string. And I'll just tell the user, flight must be an integer. Okay, so that's essentially the statement. Now, when Eclipse saw you type in the object logger, it tried to help you out by importing the logger library. And you can see that right here. Now, unfortunately, this is actually the wrong library. What we need is the logger library that's inside of Java util. So if you see that Eclipse did the same thing for you, just go ahead and delete this. And then if we come down back to where our statement is, we can hover over it and tell QuickFix to import the correct library, which is this one right here. So now our error messages have gone away. So let's see if we can force this exception to happen and actually get this logger message. I'll do that by running our console class. And let me just maximize it so we have lots of room. And I'll just enter a passenger. And then it's asking for our flight. Well, instead of putting in one of these flights, which would be an integer value, let me just put my name in again. And this should throw that exception. And sure enough, here is our error. So it's of type warning, and here is the string that we sent. So as long as our error message is of the level info, warning, or severe, it will log the message. So if you want to send messages with other severities, you need to either change the global logger settings, which is not usually done, or set up custom logging, which we will do in the next video. Previously, we sent a log message to the global logger. It is more common to configure logging at the class level, so we will do that in this video. To set up logging for a specific class, we first define a logger object. The logger is at the top of the logging hierarchy, so to speak. Like a read buffer is for a file, the logger is an overall object that receives messages. It applies to the entire class, and there can only be one logger per class. We will create one for our database class, since this class has a lot of complex logic that we may need to debug. To create a logger, under the fields, we'll define a new logger object. So just like our other fields, this will be private, but we are going to make it static, which means that it applies to the entire class as opposed to an object that you may create. The object is of type logger, and we'll call it database log. So that's the name of the object that we are creating. We'll set it equal to the logger class, and then we need to tell the logger the name of this class. Now that needs to include the package as well as the class name. And we send that as an argument inside of the getLogger method. Now the generally accepted way of doing this is instead of typing in the package and the class, since this class could move to a different package someday, we wouldn't want this statement to break. So what we can do instead is just type the name of the class, which is database, and follow it with the class.getName method. class.getName will return as a string the package and the class name. That way, if this moves, this will continue to return the right string. Now, just like we had with our console class, there's an error here, and you may be getting that because Eclipse tried to import the wrong library. So just like we did before, you can just delete this and then have QuickFix import the Java util logging library. So that's the first step, is creating the logger. The second step is to create the location where you are going to send your logging messages, and we call that a handler. So we will create another object, which will also be private static. Now there are many places to choose from, 5 to be exact. That includes the console, files, ports, etc. So you can have as many handlers for a logger as you want. Maybe for us, we want to send debugging messages to the console so that you can see them right away. So let's set up a handler that goes to the console. Now again, it won't look very pretty since our application's user interface also uses the console. But we would only be turning this on when we need to debug some kind of problem. So the type of handler that we need is called a console handler. And I'll give it the name log screen, because we're sending our messages out to the screen. We create it by saying we need a new console handler. And you'll need to import these libraries as well. The last part of the setup is to attach the handler and set the log level. This needs to be done in a method of the class. So let's come down to where our setters are, and we'll add a new method to do this. It'll be public and void like everything else, and I'll just call this setLogging. The name of our handler is called database log, so we just refer to that object, and we call a method called addHandler. We pass in the name of the handler that we just created, which is called logScreen, and now we have a console handler added to our database log. Now, both the logger and the handler can have a severity level set. For example, the logger can receive all messages from, say, fine and above, but choose to only send messages of info and above to the console. Now, since this is our only logger, we'll set both levels to the same. So we'll set database log, and we call the setLevel method, and we pass in level dot followed by the name of the level in all caps. So we'll set that to fine. So now our logger can receive all messages of fine or above, and then our console handler will also receive the same level of messages. So I'll just copy and paste it. So now our logger is all set up. In the next video, we will add the actual logging statements and try it out. Previously, we set up our logger for the database class. Now we will add our logging statements and try it out. We put all of our logging settings here in this new method called setLogging. In order for them to take effect, we'll need to make a call to this method, and we'll do that in our console class. So right here where we initialize our database, right after we bootstrap it, why don't we call our setLogging method? So now our logging will be set up for our database right after we create and bootstrap it. With those settings, we can now send logging messages from our class. So let's say we are having trouble with generating our ticket and we want to set up logging to see why. Here's where we start to create our ticket. So I'll send a very basic message right at the bottom, just before I return back to the console. I send a message by first referring to the logger, which is called database log. Then I specify the severity of the message, which I'll use as info for this example, and then the string that I want to send. So I'll just say ticket created. Okay, let's try this out. I'll run our console class and maximize it. So I'll create a passenger called Mike, book flight 1000, and seat 1. And here's the message that we get. It's of the severity info, and the message is ticket created. Notice, however, that we received a duplicate message. And the reason is that the global logger also received this message and printed it out. Remember, the global logger will send any messages of info or higher. So once you set up logging for your class, you may want to turn off logging that's performed by the global logger. We can do that with a simple command. And I'll paste in that command right here in our setup. The command is just database log, which is our logger, and then we set use parent handlers to false. That simply means don't send any messages to any loggers above this class. So now we'll only get one message when it's an info or higher. Well, let me set up some logging messages for each of these sections. I'll paste one in here right at the top that says beginning ticket creation. It'll be of the severity fine, because we're dealing with debugging level messages. Then let me put another one right here, and this one will say finding passenger, and I'll put a couple on all of these other sections as well. So now I have logging messages for finding the passenger, finding the flight, finding the seat, and then right before we start to create the ticket. That should tell me how well the method is working and just give me logging for the basic flow. Now, if I still can't figure out what's going on, maybe I want to look at more detail into what's happening here as I look up the flight. So as I loop through every flight, why don't I send some logging to say what it's looking for and what it's comparing it to? I'll just paste it in here. And notice I'm setting it to the severity of finer. So I can turn this on if I want even more detailed logging. And it will just say I'm comparing the current flight number to the flight that's inside of my loop. So now let's go up. We've got both of our logging levels set to fine. So we'll get all of the logging except for this line here, which will need to have the severity set for finer. Let's try it out. So we'll enter our passenger, our flight, and our seat, and now we should get all the logging. I mentioned it's a little unpredictable because we're sharing our console, but here's where it started to create the ticket, and then here are all the different parts of the method it went through. So it went to find the passenger, find the flight, find the seat, create the ticket, and then finally it successfully created the ticket. So there is fine level logging, but let's say we still haven't found our problem. So now we can turn on the finer level logging. And so let's just go up here and set everything to finer. And we'll rerun our console again. We'll go through the same actions. And now we've got all of the finer logging as well as the fine logging. So it's going through our loop here. Looks like I could have added another space, but it's comparing flight number 1000 to flight 1000. Didn't find a match. So then it compared it to flight 1010, flight 2000, and flight 2010. So you can add additional detail as you need to know more information about what your application is doing. Now, once you're done debugging, you can just turn everything off by just setting your levels to off. Now you won't get any of that logging at all. So we've been sending all of our logging to the console. It's very straightforward to send this to a file as well, and there's many examples on the web if you want to research how to do that. Logging is an expected feature of all Java applications. So as a developer, it's your responsibility to provide good logging with everything that you write. Well, we've reached the end of our journey. First, let me offer a heartfelt thanks for watching and participating in this course. I hope you have found this to be much more than just a class in coding. As an active member of a development team, you will be expected to know much more than just syntax. Responsible software developers use object-oriented programming to improve the efficiency and maintainability of the software they write. Their code is commented, tested, and follows industry patterns for solving problems. That is why we covered all of these topics in the course. Let me give you some resources that will get you thinking about the next steps to take in mastering Java. First is the Java API documentation. Always keep in mind that you should never be reinventing the wheel with your code. There are thousands of APIs already available for things like sorting, file management, workflow, gaming physics, etc. Spend a little time each day reading through the APIs that will help in the areas that you are interested in. Second, know that you are not alone. One of the largest communities of programmers that are willing to answer questions and share code examples is on stackoverflow.com. You will find that the majority of problems you run into have already been experienced by others, and they are happy to give you advice on how to solve them, especially when they see that you help others with the knowledge that you have. Your skills as a programmer will grow with practice. I encourage you to review the concepts that we covered and apply them to new examples that interest you. Before you know it, you will have a portfolio of applications and experience that will qualify you for thousands of opportunities that are available around the world.